Stationeers is a base building game, not top-down view, but first-person actually. You're in the middle of the action, and the base that you're building is very relevant for your survival, because it's also a survival game. You need the right gas mixture for your air, you need the right temperature, and you need to eat, you need to drink. The plants themselves that you have to plant, they are dependent on the atmosphere, and to make the atmosphere happen, you need to gather some stuff, and you have to heat or cool the room, and you need to prepare some materials, which in turn need some other things and so forth. It's all interdependent, and this makes for a very cool emergent gameplay. The game is still in early access, but I've played it for almost 2,000 hours now, and the people that I keep seeing on Discord every day, they also played it for a long time. It's great, so it's one of the best investments you can make if you can get over the high entry hurdle. Really, it's hard to get into. And the tutorials are kind of lacking at this point still. They don't even tell you how to build an airlock. And now today I want to do yet another beginner introduction video. But, and I'm not sure about this choice actually, I don't want to do it on the two easiest worlds, which should be the ones that you start on if you don't know your way around yet. But I want to do it on Europa, which is a little bit harder. And I don't know if I will have enough time to talk you through everything. So, yeah, this is all going to be real time, no cuts, except if I have to go somewhere. And if you want a more fast version, look in the description. There's a link to a 35, I believe, minute video that gets you from the complete beginnings to a working station with water, drinking, and so forth. Very not time wasting. So let's get into it. Europa is the moon, is a moon of Jupiter. Very cold, only oxygen atmosphere, and so the cold is a problem because it doesn't creep into your suit, but for example, the gas tank with air that you start with oxygen will cool down, and once it gets too cold, you can no longer use it, so you have to protect that, for example. So there's creative mode, which is significantly different from other modes. If you want to experience the simulation, you should play these three. And of course, as a beginner, we choose easy. Then you can choose the starting equipment. For more challenge, you can go for brutal, but that's really not for beginners, because the term brutal fits. It is brutal. Let's use the standard stuff. Maybe you observe that we have a flashlight, and just use WASD to get out of there. Let's press L to turn that off, because it consumes your suit's battery. I just press the left Alt key to get the mouse cursor, which you would use all the time. Here you can see the battery is actually losing energy, and this is, I guess, from my heating in the suit. I'm not sure exactly how this works. It could also just be oxygen. I think it will be suit heating also. But anyway, the battery's in the cold, and so it will be discharged. There's also an aspect. The graphics are a bit rough. Oh, wait a second. There, I just changed the graphics settings. The graphics are a bit rough, but the landscape system is currently in the process of being replaced. It can be any time now that we get a new one, which will be much more high-res and such. And then we get also terraforming, which is probably going to be an expansion. I mean, this game really has very deep simulation already, but once terraforming is added into the mix, that will be so cool. Anyway, so I'm pressing left Alt to open my inventory. I can also use the keyboard keys, 1, 2, 3, 4, 5, 6. And this is all the stuff I have. Here is my space helmet. I can even open that.
Temperature critical.
Which I shouldn't do here, because my lungs will quickly take damage, and the more damaged they are, the less oxygen I can take in. If they are too damaged, I will of course die, because that's simulated. Here you can define the suit pressure, not important for beginners. Here you can change the suit's internal temperature. Here you see your gas tank, your air tank, and here you see your waste canister. You breathe in oxygen, you breathe out CO2, and the CO2 will be pumped here. And the filters here are necessary for your suit to be able to do that. For example, if you have a mixture in here that has some nitrogen, which is fine, not a problem to breathe, and you only have CO2 filters here, then only the CO2 will be removed from your suit. The nitrogen will stay. So since more air will be pumped pumped into your suit from this canister here over time, eventually there will be primarily nitrogen in your suit which will not be removed. And so at some point nothing more can be added, you will suffocate. What you can do then is you click here, flush, which wastes a lot of oxygen, a lot of gas from this tank. But then your suit will be refreshed, will be vented. So that's one thing you can do, but ideally you have a pure oxygen mixture here. Let's take a look at what gas is in there. We have the handheld tablet. I will drag that over here. Alternatively, you can press the right mouse button. I will do that henceforth, which is faster. Then we have several cartridges that we can use. I will use the Atmos Analyzer cartridge. You can just drag that in here directly, or you can click on the tablet itself. Yes, things can have inventories, and those inventories can have inventories. It's not very deep by standard, but you can put, for example, a backpack in your backpack and so forth, which is a bit cheaty. I hope they cap that at some point. Now press the right mouse button to use this thing. You can see the world is at minus 141 degrees. We can also see that at the right bottom here. I'm a bit fast, I know, but this world demands us to be a bit faster. And since I'm talking, wasting time, something I would normally be able to pull off easily, play this thing on hard mode and survive, I might not be able to pull off now on easy mode because I have to invest so much time explaining. It's getting a bit warmer because the sun is coming up. The day will be like 145. Wait, what? What am I saying? Oh, I was mistaken. I thought the sun was coming up. Anyway, so let's take a look at the oxygen canister. You can see it's cooling down, and we currently don't have anything to breathe. But there's still gas in the spacesuit, so that's not a problem. You can see it's oxygen. And in our waste canister, we even also have some oxygen.
Temperature low. Temperature critical. Temperature low.
And since, I mean, it's saying the temperature is low, why would it say that? How is that relevant? Well, I guess the gas here from our canister, our breathing canister, will also be used for heating or for cooling. So some of that is just being pumped into the suit since it has a certain temperature, and then we're fine. Some of that is then pumped out because if the gas cools down, it's bad for you. So that gas that is too cool will also be removed, or that's too hot. This should mean that our waste canister is actually very cold. I didn't take note of that. How cold is it?
Waste tank critical.
Yeah, it's
temperature low.
negative degrees.
Temperature critical.
So you can see that is also being used for air conditioning. So this is our lander. That's the equipment that we came with, and there's a little bit of equipment, some food in there in our landing capsule also. I will now not waste time. Here, that's some stuff that we have. Unscrewing these manually because that really I don't have that time in this on this world with all the explanation. See, here we have a tip in the tooltips. You should always read those as a beginner. They're very, very informative and they're dynamic. So depending on what the situations, they will show different content. It says here construction supplies, and it is fastened to slot 1 on the lander, and you can use a wrench to remove this. I will right-click the wrench to teleport it into my hand. I can switch my two hands with E. You can see that down here where the mouse currently is. There are some tips here, and that's the sun going down. Whoops, and now it falls down. But instead of doing that, I can... Okay, let's take any tool in the hand and then point at the lander. Without the tool, you see a simple tooltip, that just warns you that if there's a storm, the lander would be damaged by storms. But if I use a tool, and that tool is not one that you can actually use on the object that you're pointing at, because that's a thing all across the game, then it will show you more details. If I use an angle grinder, I can do something meaningful here. I can deconstruct the lander. Let's do that. I will swap with the angle grinder, and then the lander that I will no longer need has been deconstructed and all the things fall to the ground. Let's take a look at the oxygen tank that we brought. The temperature is 19.2 degrees already, so it's cooling down. Here are some handles that I can click. Many objects have many click points. For example, up there I shouldn't click. This will release some of the oxygen. And here we have, you can see the highlighting here, yes? That is where we can put our air canister. I will do that.
Air tank critical.
Now we have higher pressure in here, and that pressure is not arbitrary. The thing here has 7.5 megapascals pressure, and this temperature, and is actually convecting away its heat at this rate, and is radiating away its heat not at all, which I find a bit weird actually, but okay, let's ignore that. And more often I put my tank in here, the lower the pressure in here will be. And this is not some kind of gimmicky fluff simulation to make you feel better or whatever. This is just part of the engine. This is a systems game. It is has some very high abstraction systems upon which everything is built. So this is a real simulation game. Now, since I'm basically in the process of dying, though my body doesn't feel it yet, I mean, my resources that keep me alive, they are falling away. For example, my battery is emptying itself. I will now start with the base building. We have multiple supplies. One of them is the construction supplies. You have to build your base on iron frames or steel frames. We don't have steel yet, so let's do that then. Not everything has to be built on frames, but some things do. And so my base foundations are always just frames. Right mouse button once again turns the device on. In this case it allows you to get this green build ghost, which is also called the blueprint, and with the left mouse button you place them down. They are not yet completely built, you can fall into them, and they're obviously not airtight. You have to weld them. For that you need iron sheets in this case, or in the case of steel frames you would need steel sheets. Oh, I thought I had more of these. Yeah, there are some more. And one should take care not to overbuild at the beginning. Now it looks like I am doing just that, but it's not really a problem yet, because this is just the iron frame. So I have some of those, I have enough of those, and I will not need them so much in the process of building the station at first. So now I will prepare some... yeah, that was not so wise. Oh, that works? Hilarious. Let's do that. Okay, I'm gonna take the things here, the cereal bars and the water bottle. Right mouse button to teleport. Oh, I can't. My inventory is full. Yeah, that's one thing you should do. You should, if you want to be fast, which I have to be currently, you can swap some things away that you don't need. I don't need to track my location now relative to a beacon, so put away the tracker. These are for the tablet. And I don't need to analyze cable networks currently, which you rarely need, as in the first hours of your gameplay anyway. I will need the iron walls, I will need the glass sheets to complete the iron walls. The portable solar panel I will probably not need. It's pretty effective, but I will not have the time to deal with this thing the whole time. Then the duct tape is pretty important if your suit gets damaged, because then you need that on hand, but I will try to take care that this doesn't happen to me. Then we have the mining belt. I will keep that on me, and the pill is needed in case my lungs get damaged or my body otherwise. And you only have one of these. You can manufacture them later, or you can also use a cryogenic tube. A cryotube which will also heal you, but we're not that far yet. Definitely not. This will take some hours to make. So, thank you for not tipping back. Asshole. So, I wanted to... Ow! It jerked itself free. I just wanted to deconstruct that, because this too is no longer needed. It is pretty useful though, I mean you can see it from a distance, but now that's over with. Okay, let me just use the screwdriver to look at the frames, like I looked at the lander. Without the screwdriver, we see nothing. With the screwdriver we get the tooltip that tells us we can use the angle grinder to deconstruct these guys, and we get them back in our hand, or they fall to the ground since my other hand is full. Or we can use the welding torch and one iron sheets, I have iron sheets here, to continue construction. So the welding torch doesn't work unless you turn it on. The tooltip tells you that. So once again, right mouse button. And I'm welding them twice because I need them airtight. I mean, the oxygen out here is nicely breathable if it just weren't this cold. Also, if I have plants in my station, pure oxygen won't do it. You will also need CO2. This indeed means that the stuff that you breathe out can be used for the plants. Don't stand inside while you weld, your suit will be destroyed and then you're dead. Yeah, I'm already making the mistake of welding too much. Not good. Okay, I will just get some of the things back. Should have planned this a bit, huh? I don't like to plan. Takes away from the time that I can enjoy myself. This is also why my stations usually look pretty samey, and then they slowly evolve over time to be a bit more interesting. You just heard one of the many alarm messages that there are, and it's telling me that my battery is down to 50% already. So, here's the mining belt. I will now teleport the mining drill into my hand. You can also use drag and drop, and you can also use this guy. Welcome to Minecraft. But, yeah, let's use this thing. Right mouse button to turn it on. I didn't weld the ones in front here because I will need some area out here to walk and build, and that doesn't have to be airtight, so I can save on resources and time, hypothetically. Now I will do something pretty wicked. I will take this here, my oxygen tank was cooling down and cooling down. It's not good, it's really not good. And build something that I don't need to build on the moon or on other worlds. A little box where it can be, where it can stay. Okay, now I took the wall. This is like building the frames, but it's different because these you can meaningfully rotate. For example, by holding whatever key is shown to you here in the tooltip. I reconfigured my keyboard, so just look here, it will tell you. And I'm pressing R and using the mouse wheel. I'm just pressing R multiple times, that also works. And more, furthermore, this is a kit. Like most things in the game that you can hold in your hand are kits. Here we have, for example, the kit. Oh, it's not a kit. Oh, never considered that. Anyway, so if you use a mouse wheel, you can use different types of things. This is a wall, this is a wall, this is a wall. There's no difference, it's just some slight cosmetic difference. But here we have the iron window. And you can see in the tooltip that not only R or whatever your key is can be used to rotate this, but you can also use the 6 keys above the arrow keys, delete, page down, and so forth, to rotate this. So this is not yet a built wall. The wall 2 consists of multiple parts. This is a very zen game, so that's something you have to get used to. Except at the beginning, you're hurried. So this game, in contrast to many others, tosses you in at the deep end. Really, that's a significant difference in Stationeers. You start in a harsh survival situation, instead of like on level 1 before you get the real big enemies or something. So let's put this guy in here. With the handles, there's a bug, stupidly, that they haven't yet fixed in a long time. Pretty annoying. Which is when I try to... Where is it? When I try to get this handle here, one of the ones in the front here where the lid is, and I click, then I will have it grabbed from a different angle. So if I want the lid in front, I still have to do some acrobatics. Here we go. Now let's get some
Air tank critical.
air, and then I will do something that is probably a bit unexpected. I will light some road flares. And then I will close this up. Because guess what? They excrete heat. And the minus 150 degrees in there will now heat up to, I guess, like 30 degrees or so. And my oxygen will be heated. Not to 30 degrees, because the thermal mass in there is not that high. Because as much as the air in there heats up the tank again, as much the tank cools down the air in the box. So, yeah, this is thermodynamics. Now I need to take care of electricity. That's really a big concern I have. But before I do any of these things, I will carry my boxes here onto my base foundation, because eventually I have to have them in my station, or at least the materials. I mean, I don't need to keep the crates around. I can also just destroy them with a drill. This is also shown in the tooltip. If you're holding a tool while pointing at them, or even normally, I don't know, let's see. Yep, only if you hold a tool. So hand drill required to deconstruct, and then everything will fly all over the place. This is for later, not for now. You might wonder why I haven't put the water 2. This is the water tank, which is also not insulated, even though they are insulated variants of this. On this world, weirdly, you don't start with the insulated ones, but I like it. It's a survival challenge. This is actually an insulated one, I think, one of the advanced ones. You can yeah, see, 20 degrees. It's not cooled down. You can tell the difference easily by looking at this, which is a progress bar. It shows you how full this thing is. Or it should. I mean, I'm a bit confused that it's not showing anything here. Because there's fuel in there. The same stuff that is here in my welding torch. And you have maybe already seen up there, there's a hint that tells you F1. I press F1, and here's the Stationpedia, currently in paused mode. Could also have paused the game with this, or unpaused it. You definitely want to read that when you have time. So let's take a look at the gases. We have oxygen, obviously, then we have nitrogen. That's like 80% of the atmosphere we have here on Earth, or 79%, completely harmless. Except you don't smell it. So if there's only nitrogen about, you might actually just go unconscious and then obviously die. So you have to take care of that when you're controlling the atmosphere yourself. And then we have carbon dioxide, which is the thing that you feel when you have the feeling of suffocation. You don't feel the absence of oxygen. You feel the overpresence of carbon dioxide, which your body excretes from cellular processes and so forth. That's what we breathe out in the game, and if you have too much of that in your real-world atmosphere, that's bad for you. Like 5-6% you get very tired already, and I think 10% is already deadly, or 15%, I'm not sure. And that's not just because it displaces oxygen, it itself is really just not tolerated by your body if there's too much of it. In the game though, sadly, this is not simulated, so you can have an atmosphere of 80% of that and 20% of this, and your plants will celebrate, they only need 1%. But, and you will also be fine. Then we have volatiles, and this is the only gas in the game that can burn. It burns together with oxygen, and so if you have fuel gas like I have in my welder or in the gas tank that I just showed you, then there will be a mixture. There will be 1/3 oxygen and 2/3 volatiles. If the mixture is different, it will still work. If the ratio is different, it will just... excuse my phone warning me that I can unplug the battery, unplug the charger. So if the mixture is different, it will still work as long as it's oxygen and volatiles. The game will just burn up 2/3 volatiles and 1/3 oxygen. And at some point then maybe only oxygen or only volatiles remain if the mixture wasn't even. So that always works. In other words, if you have a station that is full of oxygen and there's a tiny bit of volatiles, and then you start your 3D printer, which kind of sparks the air, then your entire station air will be on fire at least a little bit. It's not going to be fatal. But any burn process will produce, for example, carbon dioxide, which is fine, but it will also produce pollutant, a lot of it. This is kind of the catch-all gas that they implemented to express the final state, and you don't want it. Though actually you do want it, because if you let's look at water, for example. I mean, we have had enough frantic action explanations for now, right? Let's take a bit of time here for a moment. You can skip ahead. As being YouTube proficient, you know what to do. Wink, wink, nudge, nudge. So water. We know. Here's some blah blah up here. If you stumble upon an article, there's some text up here. You need to read that with a grain of salt, because these are human written, and since it's an early access game and the game doesn't pay for itself, it's financed with other projects of the team, but it's the love project. They will keep going with this, and I get daily updates, and you get monthly updates roughly. You could also have daily ones by switching to the beta channel on Steam. Right mouse button on the game, properties, betas, and then select beta from the drop down box. So they don't have the time they don't have time to waste, and so they don't rewrite these texts every time. So sometimes they fall out of favor. But the stuff down here, this technical stuff, that comes straight from the simulation, so it will always be correct. So let's try to scroll with the absence of a scroll bar. And here we see the phase change diagram. This is not something the game made up, except this phase change diagram is not realistic. In reality, it's more complex than this. In reality, we have the same thing. So let me switch this to something that you can probably more easily digest at first. So we're using a linear scale. This is the pressure, the vertical axis, and the horizontal axis is the temperature. We all know at 0 degrees it freezes. This is a solid state. And if it's warmer than that, it's liquid. And if it's more than 100 degrees, it's gas, right? It depends on pressure. Look here, we're at... Shut up, radio lady.
Exosphere on Soma FM.
So here at 100 degrees, it becomes a gas. Normally at 100 kilopascals pressure, you can see on the right the pressure. I guess the graphics here are not 100% precise, but the simulation itself tells you here 100 kilopascals. This comes from the simulation, so that's what counts. So let's go back to the logarithmic scale. So we have a lot of low pressure here, and then a bit of medium pressure here, and then it accelerates a lot. So this is more useful in practice. But I mean, whatever you want to use, Kelvin or Celsius scale, that's rather arbitrary. I use Celsius most of the time. The machines will tell you the values in Kelvin, and the only difference, and that's real world stuff, you know, you can learn this. If you haven't already, this is now the time. This game actually can teach you some real world stuff, like for example that higher pressure would keep the water liquid even at 100 degrees. So Kelvin and Celsius have the same step width, the same grid width. Plus 1 degree Celsius is plus 1 Kelvin. In the case of Kelvin, you don't say degrees. The lowest Kelvin temperature that there is 0. And the lowest Celsius temperature that there is minus 173.15. Because it's just the exact difference. If you have a Kelvin scale, which all your devices in the game will tell you, they have logic values that you can read out to control something. You can also automate things with chips. You can even program. There's an assembly language. It's super cool again, man. If you have 273.15 Kelvin, then you subtract that very number and you get 0, obviously. Because that's the very difference between Kelvin and Celsius. Then you have 0 degrees Celsius. Okay. So let's look at this here. The higher the pressure is, the longer it would stay liquid. And if you look at pollutant now, this is a pretty wicked chart, isn't it? Here we are at 150 degrees Celsius, and here we are at minus 100 degrees Celsius-ish. And you can see that across all this range, it will stay a gas. But if the pressure is higher, then across all this range, it will become a liquid. So that's very interesting for some phase change shenanigans that you might want to do in the game, because guess what? Just like in reality, in this game, if something goes from the liquid stage to the gaseous stage, it cools down. And when it turns back from gas to liquid, it will heat up. So you can use that to heat and cool things by using, like your fridge does, some phase change cycle. So let's look at the other gases for a second. Then we have water. Yes, we have polluted water. That's so far it's relatively new. It's when you take a shower, you can clean that in multiple ways by, for example, using a water purifier machine which needs charcoal, which is not too easily produced. But you can also invest some energy and just boil the water. Then you will get the gaseous stage of water. And you can then condense it again. You will have pure water. There will not be any pollutant remainder. I don't know why. Then we have nitrous oxide, which is a laughing gas, from which makes you unconscious if there's too much of that in your station. And as you observe, there's some oxygen in there. Does this mean we can also use this for burning? Yes, we can. Doesn't mean the same for CO2. I guess CO2 is very, very strongly bound, but I don't know. Anyway, so 1 part volatiles and 1 part nitrous oxide together also works, and that is the most powerful fuel and is very fickle to handle. You will use it, for example, when you build rockets, I think, because I haven't built any yet, even though I have played this for this long. So the game is really, really deep and expansive. Though I must admit I repeat many things. Anyway, so and then we have well, the same thing again in the liquid form, and you can ignore these entries basically. Many things in the Stationpedia are really just put in here from the simulation, from the logic, and so some entries kind of don't make sense. I mean, why is this entry here? Liquid volatiles. That's just volatiles but in liquid form. Yeah, exactly, same phase change diagram. So you can ignore those. Okay. Back to survival business then, I guess. Another thing, I'm just flying. Because you have a jetpack, you can activate that with J, but I did reconfigure my keys, which is more reasonable, I think. Here are the settings. Let's go to controls. These are the controls that exist. You can pause the video to read this. And so, for example, I changed my jetpack key to shift, since you can't run in the game, but you need the jetpack very often, or when you need it, sometimes it's an emergency, and then, yeah, that you want that easily available. Another thing, you can change the head-up display scale. Yeah, that's a bit big. I guess it would be more easily readable for you at 100, but I mean, I also need to be able to use it, and I've kind of settled for the compromise of 50, which is visible but usable. Okay. The sun will be back soon. You can already see that it's already day. Why is it so dark then? Well, that over there is Jupiter. In a way you could imagine that is down. That's where the ground is. Oh, there's the sun. Hello. That was fortunate. So, here we have some survival supplies. Here we have some hydroponic supplies. And here are some electrical supplies. I will need those now. I will take the wind turbine. And can turn off the light actually. I place that here. Now we're producing electricity. You cannot see it what I'm doing here, but I really have to push it a bit so that I don't die. Well, if you want to remove a cable, you use the wire cutters, and the tooltip actually tells you to use the wire cutters in some situations. For example, here, when you want to cross the cables or do something like that, you don't need to go through all the different variations that there are, and in addition to that also rotate them. That would be crazy. Instead, you can just use, for example, the curved cable, and the tooltip tells you if you have the wire cutters in your hand, in the other hand, during that time, then it will do all the logic for you. So, that's very convenient. You only need the straight and curved cables. I am about to build an airlock, and for that I need some power supply. You should always have a power supply in your airlock. How I discharge are these? 99%. Okay, the code is really getting to them. The area power controller is a power switch, which allows you to turn off whatever's connected to it. I want to turn this around. There are two variations here once again in the kit, and the difference is only cosmetic. I just, you know, wanted to have them like this. With the crowbar you can open them. It's pretty stupid that they are being closed automatically when you build them, but okay, that's just how it is. And when I put the batteries in there, they will be slowly charged from the tiny motions here of that wind turbine. And that's my only means of powering stuff so far, but I can print more of these. I can also print solar panels. So you should always have this guy in your airlock, always and always, somewhere, because when you come into your airlock and the airlock is without power, what will you do then? Crowbar open the windows and unleash the entire station's atmosphere? You will lose all that. Your plants will die. You don't want that. And so you want to be able to power your airlock with a battery buffer. But what if this one's empty? Well, then you swap that with your own battery for a moment, cycle the airlock, go inside, and then you get the battery back, for example. So you have to think on your feet sometimes. For example, when I'm out there and suddenly my battery is down, which would be pretty fatal because the life support system needs it, and then my suit would cool down rapidly and then my lungs would get damaged, what I can do is I can just open one of my tools and drag this small battery, which doesn't have that much power, but still it works. You can drag that up here, and then the two batteries will swap. This one will be empty, and that up there will then be whatever your tool had. You can live on that then for a moment. So, let me see, I have still 15 of these. I think I should weld a bit more so that the starter situation has a bit more room. Never forget to turn this guy off, because it has a limited supply. If I put this in here, it's still burning. But you can do this, for example, instead of holding it in your hand to turn it on and off. I hope I didn't forget any key things that I need to explain. Of course, there's more to be explained, but I mean, so far, you know. So, let's start building an airlock then. An airlock in the game is also, like many other things, not a crafting recipe, but it's emergent. I mean, what is an airlock? An airlock? Let's say we have our station atmosphere here, and it's warm and it's nice for the plants. If we leave this, if we go out of the station and we open the door, and the pressure out there is lower, then this gas in here will stream out. In any case, if the atmosphere out there is of a different mixture, or is, for example, colder like here, then we will get some of that in our station. And we don't want that. And so we need to protect the air. So what does the airlock do? It locks the air inside the station. How does it do that? You go into the airlock box, then you cycle the airlock, which will empty the airlock's content into your station, so the gas will not be lost. The airlock box is now evacuated. Now you open the outer door, and then the planet atmosphere will stream in, and you're fine. I mean, a proper airlock would also repressurize first. It would first fill the box with a bit of the gas from the other side, but you can ignore that in this game mostly, which I find a bit sad, but I mean, most people will soon configure their airlocks, at least at the beginning, so that they just have an explosive decompression, like I just described, because it's just faster and more convenient to build. And when you go back in, you need to do the same thing. You need to empty your airlock towards the planet, and then you open the inner door and see now the two atmospheres are separated from each other. The problem is when I start here with my lander, I will not have the tools for that. I will only have a simple airlock chip, which doesn't control two air pumps, it only controls one. So I can protect my air in the station from getting lost, but I cannot protect it from some planetary atmosphere streaming in once I re-enter the station. So you have to print that, and for that you need to make the 3D printer. And there are multiple 3D printers actually. Yeah, let's take a look at those for a second. Yeah, we have 6 of these. 7. Wait, what? That's 9 even. The terraforming manufactory? I didn't even see that yet. That's a new one. Hey man, I have to make one of my news episodes. Oh, it needs a rocket manufactory as a base ingredient. That's weird. I didn't even see that this thing exists. See, they are developing the terraforming expansion on the foundation of this game here, and so I have a video or two up where I'm showing plants on the planet. Okay. Yeah, a video and a screenshot. So what you need at the beginning, the autolathe, which you always need at the beginning of the game, that's why you have it. Without this guy, you would not be able to survive at all. Then you need to print the electronics printer, which allows you to make the advanced airlock chip, or allows you to print batteries, or the wind turbines, everything electric, you know, solar panels. And then you would need the hydraulic pipe bender, which is also called the atmospherics printer, for pipes, for air pumps, for all that kind of stuff, for example for the filters that you use in your suit. And finally you would probably also make the tool manufactory, which allows you to print a crowbar or something, which you already have, but you can, for example, print a better mining drill once you have upgraded this guy, or you can print another mining belt or a mining backpack, stuff like that. Yeah, the other ones are not so important. At least not at the beginning. 17% on this battery. I'm not sure if I should maybe expand the station a bit more. How many frames do I have left? 14. Yeah, I think we can make the station even bigger. I said not to overbuild, and this is still within reason, I think. Yeah, what's happening here is that gas atmosphere is streaming rather fervently from the spot where I welded, and when you do that on the moon, where everything is quiet because there's no air, no gas that would transport the sound, when you weld, then you would suddenly hear something muffled because there's a little bit of gas there excreted from your welding machine. I need my iron walls again. And yeah, let's place those. You can place them like this or like that, on the inside or on the outside. The difference is cables are being placed on the wall, and so if I go here and place a cable now, it will suddenly, by placing it, be on the outside. Then I can basically not access it with my wire cutters from the inside. Also, the decorated side of these guys, which looks a bit more nice, is on the outside, like this. So you usually want to place them like this. This is airtight. And also if you alternate the direction, that is, you know, like this, that's still airtight. The game is friendly. You don't have to worry about that. By the way, this fast day-night cycle, which I find completely annoying, can be altered with some trick, which I will just show you, since I'm trying to show you everything. If you press F1, you get help. If you press F2, you can turn on and off the head-up display for screenshots and such. And with F3, you get the console. If I press help here, if I enter that, we get all the commands here. They are not for you, basically. They are for debugging, for testing, and also maybe to get you out of a problem. There's, for example, the command here. Can you see the mouse? Yeah. Unstuck. I have never needed this, I believe. Yeah, I remember I got stuck at some point. I was standing on a manufactory or something inside my station, and my head got stuck in some pipes and I couldn't get out. Then I used unstuck and my suit was almost destroyed by that act because it placed me in a different location which was still so close by that. Anyway, so here we have the command orbit, because this game actually has Kepler, follows the Kepler laws and simulates the Sun, Mercury, Venus, Earth, Mars, Jupiter, Uranus, Neptune, Pluto, and Saturn. Yeah, I forgot Saturn after Jupiter. All of them are out there. You can't see them, but they're there. They're all there, and you can use a telescope, I believe, to see them. And here you can see some parameters of the world that we're on, and the key one here is time scale. And if I enter now orbit time scale and enter a value that is not the one that is shown here, which is the default one for this world, which gives us a 20-minute cycle, but enter this, for example, 1/10 of that, then it will run at 1/10 of that speed. So this would give me a 200-minute day-night cycle. This is something that I prefer and usually do, but I would stick with the normal stuff here. One of the reasons being that the plants, let me just talk a bit about plants. You can see here the parameters that this plant has. It seems super complicated, but it's rather complex. See, it's not complicated, it's complex. Ultimately, it's very easy to make plants grow. You have to just consider a few simple things, but the way the game implements this, well, requires all this information, this data. One key thing, absolutely super important for every beginner, for every person who plays Stationeers and wants to deal with plants. What you have to think of is the plants don't just need light to grow. They also need darkness. And so in a 20-minute cycle, which the plants always have, even if you change the orbital speed here, they will always stay on their day-night cycle of 20 minutes. They need at least some minutes of darkness per day. If they don't get that, they will get damaged and ultimately die. Then you will have where there's actually a plant analyzer cartridge that you can print and use in your tablet, and you should do that, absolutely, except if you're already proficient with plants. It will tell you everything about the plants, their state, what's going on, what atmosphere they're in, what the atmosphere should look like, and there will also be a value that is called illumination stress. And this illumination stress doesn't just mean there's too much light, it also means there's too little light. It just tells you that there's a problem related to light. And darkness is the topic of light. So if there's too little darkness, then the illumination stress goes up. If there's too little light, the illumination stress goes up. The higher that is, the less your plant will grow and eventually it would die. Okay, let's put up those walls. You can see here we can just build into cables, and cables can just be laid through walls. Okay, now let's make the ceiling. I will also do that on the outside because I will also have cables on my ceiling often, and I want to be able to access those easily. You can also place walls on the inside and on the outside, which sometimes makes sense. Wait, where is my building supplies? Oh, I have that already on me. Bit stupid now that I'm using this different stack here. I have to find the right type again and then use and have to redo the rotation. And that can actually be a little, well, not a problem. See, when I complete these walls, I have completed these here, then you can see there are stripes in there. And they're irrelevant. It's just cosmetic. That's just, you know, an expression of physicality without having any function. They can be vertical or horizontal, but you cannot tell when you look at the raw thing here, when you build it. So when you start with the next stack, you might actually accidentally rotate that differently. It's not important. So how should I do this with the airlock? If I do it like this, then I have access to the cables, and there will be some things that I have to build in the airlock. So it makes sense to build this on the outsides of the airlock. Also, I can make the airlock around the corner. I can do it like this, but I've chosen to do it straight. Okay, so much for the walls. I can now close those up. How do I close those up? Let's look at a tool again, and then at the tool tip it says we need one iron sheet to continue the construction. So let's do that. And then it tells us we need one glass sheet to continue construction. Okay, let's do that. You don't have to use the tool, I'm just showing you how you could find out the situation. Now this seems very tedious, right? But first of all, you can be a lot more efficient about this, and second of all, this game pulls you into the moment. It's a very zen game. Apart from the action engineering that you have to do. I mean, it's absolutely unique, this game. Particularly because of the mixture. It's survival, it's first person, it's creative because you can design your station any way you want, but it's also deeply functional, and it's emergent gameplay. You don't have missions. You have to, I mean, this will come eventually. For example, there will be, what they said is there will, for example, be the task to make a hotel-like situation so that researchers can survive there. So they would have to have their rooms, which can be lit and have the right atmospheric mixture. Some researchers might be of a different species, so they need a different atmospheric mixture. This is actually already in the game in the form that you can have traders that land, and then you can buy stuff from them and sell things to them. That's why we have this thing here. For many people, it will be dollars. For me, in Europa, in Europe, this will be euros. Doesn't make a difference, just the symbol. And those guys, many can just land on a platform and they don't need an atmosphere, but some need to land in a hangar, and some of them actually even need a landing strip, so you have to build all of that. Or you can just not have trading in your playthrough, and that's fine. You can play it how you want it, you just need to survive. Which means that at some point the game definitely plateaus. But see, as a beginner, you will experience the strong push of the survival. And when you're plateauing, when you are surviving, then you might be inclined to be more creative. I'm not much of a creative person when it comes to base building, really, sadly. So I cannot benefit from all the creative stuff that is in Minecraft. I always get my diamond suit and pickaxe and everything, and then I kind of start over. Though I don't play that these days. Now that I have this, haha. But if you're not so creative, then you might just want to play the same thing again with different starting conditions or on a different world. So now let's use the crowbar trick. I can just point here at the glass. Now it's gone. See, now it's no longer highlighted. So I can just quickly point at all the walls to find out if everything is closed up, because you definitely want to be sure of that. I have a cool Vulcan survival playthrough on hard mode even. I mean, it's not... okay, the real professional guys... okay, professional is not the term, we don't get paid to play this. And I am not professional, I'm just pretty much advanced. There are people who have stations here, I'm really envious of that. They're super advanced building and wow. But... I mean, there are people who can play on Venus, which is definitely the hardest world of the ones that you get with the game. Because you can also make your own with some tricks. The game is very, very moddable. You can also make your own difficulty settings. You can, for example, make a difficulty setting that is like the hard mode, but has the creative flag turned on. And it's very easy to do. There's a zip file in your installation tree. And there's a README file in there that's only like 5 or 6 lines, I don't know, it's not much. And if you follow those instructions, you will have modding set up, and then you can, for example, copy the difficulty settings over there, and then alter them and strip them down to the ones that you have changed, and then you can then you have your own difficulty settings in addition to the ones that are in the game already. I'm looking for the doors. Where are they? Oh, the airlock supplies, of course, which we haven't yet really looked at. Doors. Okay. So the doors, once again, they are a kit. I can rotate them, not vertically. The glass door cannot be built right now. Why? Because it is has very wide doors, and I have a cable there. This cable is in the way, so I cannot use the glass door here. But I can use the composite door. Both of them are electrified. You can see the 2 outlets down there. One is for data, one is for logic. If ever a device in the game only has one of these, this means that you have definitely the data there, or the data and the power. So whatever the device needs, it's combined then in that one port. And every device has these has this stuff. I mean, let's look, for example. The hangar door, by the way, can also be placed vertically, so you can have ceiling and floor hatches that can be electrified. So kit door, yeah, you see all the things that have the word door in them that are showing up here, and you can see, for example, the kit door, and there should also be the glass door somewhere. What's the difference? Well, if I click on the glass door, then I will get the description of this. But you can also see that it's constructed from a kit. I'll click here, hyperlinks, haha, now we are back at the kit. And here you can see how that is made. We need the autolathe printer that we get with our lander. We need some iron, some copper in the ingot form. So just drilling that from the planet is not enough. We need to shove it through the arc furnace, which also comes with the lander. If you are ever in a situation where you have nothing left, but you have the autolathe and the arc furnace, then you might be able to cope. And of course you need the mining drill and such. But if you start without the arc furnace or without the autolathe, which you never do, I'm just saying, then you're out of luck. You cannot play the game then, because the arc furnace is used to create ingots, and it's just one of 3 furnaces that the game has. The second one is the one that we have to build soon, which I will also abuse due to its extreme waste heat that it excretes as a radiator. I will build that thing in my station to heat up the room from minus 140 degrees to much higher. Actually, it will easily reach 100 and more degrees then, so I have to be careful. Anyway, and then there's the third furnace, which is the best one of all and actually easiest to use due to its built-in pumps, and it's a beast. Anyway, so now you can see the things that you can build. For example, we can go back to the glass door, and we see the other things too. So the glass door is a bit wider. The composite door, you can actually name that. I mean, you can name all the objects in the game, and that is sometimes even important when you program, for example. But here, the composite door will actually have the name that you give it written on the door. That is pretty cool. Then we have the manual hatch, which is like a door. If you... let's look at this. You can just click on the wheel, the door will open, and it's manual. It cannot be controlled by logic. You can also make airlocks with this, of course, because an airlock doesn't have to be... like I said, it's emergent. It's not a crafting recipe that you use. You can just have an air pump in there that you operate manually, and then you can have manual hatches in there. No problem. Then we have the same thing for the floor. This is placed on the ground or the ceiling. And then we have this thing, which is not a door at all. This is a closed wall, but this wall here is very flat. So if you have placed any microchips and such on the wall, you will see them fully. But then you can click here and close this like a roll cover, and then you will have a proper closed floor or closed wall. That's what this thing is good for. Okay, let's build that door then. Composite door. And on the inside, I could also build, a glass door, but I will build a composite door because then I have more options when it comes to cables. Now you know what to do to find out what's necessary to complete these. Just point at them with the tool. I will not do that because now you know how that works, and I will instead complete them. What you see here, these pixels that are flying about, that is an atmospheric, that's when gas moves. You can open and close these with a crowbar as long as they're not powered, so that's pretty convenient. So now I need to cable them up. And well, of course they need to be on this side here. Output. This is the output side of the area power controller. As long as the area power controller is not turned on, it will not waste any electricity. So currently oh, look at that, the battery was red. Now it's orange. Yes, our wind turbine is actually charging that. And it's charging both batteries at the same time. Now you will see something you should not do. I was just reaching through the glass, I can just click here. And that's something I very, very dearly hope that Rocketworks, the makers of Stationeers, will eventually fix. Because it really takes away from the believability of the simulation. Yeah, what am I doing? I can just use the scroll wheel, it makes it faster. You can build cables blindly, by the way. Here you can see the one of the two ends is a yellow plus, the other one is a green one because it doesn't have any contact. See? And you can change the field of view here. In the game, there are two hotkeys, and there's even one that resets that to the default that you have defined here. And mine is pretty wide because I'm using the 3D first-person interface as one of the few people on the planet that appears correctly, which means that my effective screen size is very big, and so I'm replacing most of my human first-person view with a 3D first-person view of the game. That's the idea. If you're doing it differently, you're doing it wrong. Okay. Now if I turn this on, the doors are powered, but every device has some base electricity that it uses. See, now I can no longer do that, but only because it is powered. Now it could do that again. Every device in the game uses some base electricity. These use 10 watts, for example. Glass door, composite door, same thing, 10 watts. And I'm not yet in the situation to waste, so I'm not gonna do that. Okay, let me just do another cheat. I will just look through the wall here. Okay, it doesn't really help me because I cannot measure there. See, now I'm flying and this still doesn't work because I'm still measuring my own room. But when I point at the thing, then it will nicely show me the content. We can see the degrees is 13.2. So that would be, I guess, the average temperature in that box. So the 4 candles were the right move. I guess 3 would not have been enough because I waited for so long. The gas was already that cold. I kind of caught it in free fall, you know. So now we have some power supply that charges our batteries. Oh, there's a battery charger which I could also throw into the mix. I will place that here. What I'm doing here is I am connecting all these things that need power to the one power source that I have so far. Because if there would be a lot of power coming in, then all of these 3 things would be charged. But imagine I would do this, would build this thing, and then would add that thing back here as a chain. That wouldn't make sense at all. Or this guy, that would make sense. That would kind of make sense. But then I couldn't benefit from the power that comes in. Actually, what am I saying? That would still work, I think. Actually, it would. But it wouldn't be a good thing. Because imagine, if I built this guy, connected to this guy, Then if I put some batteries in there and charge them, if I turn this on, it will consume 5 watts waste electricity, but the rest goes into the batteries. This guy charges the batteries without any waste electricity. Then, if need be, this guy would be sucked completely empty to fill those batteries. But if I want to power more things with this guy, then what will I do? I'm out of luck. So I will connect this here. Also, I will later have a power supply that will have much more output, and then I can boost all of these devices in parallel. Yeah, maybe that's a bit too in-depth as an explanation right now, but I'm gonna go there anyway. Has to be done at some point. There are 2 types of cables in the game. The heavy cables you can see here, which tolerate 100,000 watts, and that's the load. That's the actual throughput. So if you have a power supply of 20 kilowatts, and then you put a lot of load on that, like 10 million watts load on it, which you will never have except maybe with terraforming that's incoming, I don't know, then the cable will not die, because there's just not that much power going through it. It's just 20 kilowatts going through it, 20,000 watts, because that's the only power supply that I just described. So
You are listening
this is getting confusing.
on Soma FM.
But if, for example, you have a power supply that has 100,000 watts or more, then if you have a load that is also that high, then the cable will be under that much stress, and then then it will burst. Then one of the cables of the network will die, at least one. These ones, the small ones that I currently have, they only tolerate hey, where's that? Here, 5,000 watts. I wonder why that's not written here. Anyway, 5,000 watts. So later I will use my... Do I actually have that? Where's my electricity supply crate? Here. Oh, the solar fuel generator, I have it. Oh, that's cool. So we have basically no power problems at all. Because this guy, which I have to place outside because it excretes quite some pollutant, and weirdly even works on the moon, even though it's burning coal, however it's doing that. This guy puts out 20,000 watts. So you might think that's bad for these cables. No, it's not. As long as my load doesn't exceed 5,000 watts. But later I will put up some station battery, which can store a ton of electricity, not just a little bit that these batteries hold. And it can take in basically infinite electricity. I mean, these guys... Okay, let's see. We have 2 battery chargers in the game. This is the small one. It charges the batteries with 400 watts. Then there's the large one, which is kind of like this, which charges them with 500 watts. And this one charges the batteries with 1000 watts. Of course, only if that's available. But the station battery takes in electricity at infinite watts. And so if you have 20,000 watts available, it will take in 20,000 watts. And these cables will then die. So I need to print advanced ones. Once I have the station battery, I'm going to use the coal burner to supply power. Where will I place this guy, though? This should be my road for wind turbines. I'm not sure. I could maybe... Do I have another frame? Yep. It's not the best place, but okay. Need to weld that. When you play on normal mode, then you cannot eat or drink through your closed helmet. Here on easy mode, I can do that. And so I just took a water bottle, of which I have plenty. For example, here in the bag is some, and in my survival supplies there's more somewhere. I don't know where. Here, right? There's tons of stuff. And I can just right-click. You can see down here my water, and I just drank a little bit. If I hold the button for longer, then it will drink more. Then I will drink more through the closed helmet. But normally, on the normal mode or on hard mode, you have to open your helmet, and that would be pretty fatal in this environment. So, and you also, these counters here of your food and of your water, they tick down faster, even much more faster in hard mode. So, yeah, that is an extreme survival factor. This guy, well, how you rotate is kind of arbitrary, but I want to save on cables, and so I will do this, I guess. Can easily get into the station. Can get past here. There's the power output. Okay, ideally placed. I think you can even place the cables down. No, you can't? Okay. Blocked by composite door. But the manual hatches, they're completely tolerant. You can place cables through the wall here and on the ground here, no problem. And you can even build them in a circle, basically. Manual hatch, manual hatch, manual hatch, manual hatch, that works. And you can actually weld them, you know, once the thing is built, you can use your welder on this thing with a slow progress bar, and then this thing will be frozen in its open or closed state. So you could build a labyrinth for someone else to traverse, because you cannot see where that's welded, I think. Except by trying. So now we have that power supply, and since the sun is now out, I think I should actually go mine some stuff. Let's get some resources, and for that I will go to the survival supplies, which has, for example, the mining stuff, and so I unpack that, right mouse button, and the box will then be gone. I will leave all the building materials here in the room. So I already have a mining belt, but when I have two, I can transport more stuff. I want to go dig some now. Then we have the flare gun, which I don't quite need. Can show you what it does. See, that would fall from the sky then, and has quite some light indeed, and falls very slowly. And this now heats up the room. The temperature is minus 140. Wait. But I guess it exchanges too fast with the rest of the station. Okay, mining charges, very useful, very effective way of mining. We'll use mostly the drill though. 54, 60. Why is this so discharged already? Must be the cold, I guess. Okay, let's go mine some stuff. What we need definitely is iron, copper, and gold to print the other manufacturers. Here's some iron, and I will just bluntly place down a mining charge. No. And if I click this guy, it will be picked up. You heard that sound. That was deactivated. So these guys are really harmless. They're even so harmless that when you... I mean, supposedly, I've never... What? Oh. Oh, I thought it fell through the planet, which is something that can happen sometimes. God damn it, what just happened? I think I just wasted one of these. Okay. Normally I build a little, dig a little hole so that I benefit from that more. Even when you stand right next to them, that should not damage you. You just go unconscious and then you wake up again, is what I've been told. I don't know if it's true. So now we have all these thingies here. 4 iron, 6 iron. It's like when you dig them up, you know, it's always a different size. Depending on material, you will get more or less, and depending on world, that's also all differently configured. And using the mining drill, I can dig like this, it will fall to the ground. But if I instead use the mining belt down here as my actual current belt, and I can still open the tool belt, so I have not lost nothing, then I can just dig stuff and it will go... Oh, you can't see that. Then it will go straight into my belt. And furthermore, I can also click on these guys and they will be picked up. That's also pretty useful. So now I have almost one full stack of iron, because a stack is 50, and that's good. But overall you will need so much iron, and there's coal here. Coal I could also use a lot. There's gold. Very good. Gold is something you should definitely mine if you can with the explosive charges, because the rocky ground is very hard around coal, so it's harder to dig. These mining charges can actually be printed by yourself with this security printer. Oh, that wasn't much. They're actually cheap. That's surprising how cheap they are. And I hope they stay that cheap because they're really fun to use. Because drilling is really boring. Now I'm doing something you shouldn't do. I'm going away from my station without having any way of finding back. Well, I know it's over there. During the day you can see it, during the night not so much, and during a storm you can see like 3 meters, that's all. And you can move very slowly only, depending on direction. You can also move with the wind and then just jump and fly very quickly. So quickly, in fact, that if you don't take care you might take suit damage if you impact with something. Okay, we have more than 1 stack of gold. That's very good for the start. Not enough iron for my taste, in my opinion, and definitely not enough copper because we have none whatsoever. So let's find some copper while the sun is still up. And use the field of view trick to see a bit further. There's more gold. Only gold and silver glitter. You can see the glittering effect here, yes? So that's how you can identify those materials. Except you can't know whether it's gold or silver until you get close enough. I don't see any copper, man. I need copper though. Urgently. That is nickel, very important stuff later. When you want to upgrade your manufactories. Well, maybe you have noticed there's a compass down here. So if I would go back to 7 degrees now, I would find my station. Ah, copper, very good. Yeah, my belt is full. I will just drag the full stacks into the other one. Could also drag them in here, that also works. Even the gases, which if I hold them in my hand, while the sun is shining on me, would melt. They should. Oh, right, of course. It's very cold. Yeah, I forgot that. So where did I find the copper?
Power low.
Damn, oh, there it is. Too bad the other mining charge was wasted. Oh, it even lit the landscape up. That's cool, I never noticed. Yeah, the lighting in this game is pretty cool, except in some situations it's too harsh. That's why you're running around with a flashlight the whole time, even during the day. It's pretty annoying. I hope they change that. I mean, why not have a Minecraft approach? In Minecraft, every grid block is calculated, what the amount of light exposure it has, and then they use some kind of averaging to make that smooth, and then you have nice lighting. That was actually a mod that someone created, and I use it all the time because it was so much better than the original. And then the developers thought, yeah, okay, let's put that in. It's very popular and it does look better. And they could use something like that here too, I believe. Just calculate the average light that would go into one of these blocks, and then use that to calculate some kind of ambient base darkness, like they also do when the day and night changes. I mean, on the moon, for example, which is pretty bright even during the night, when you're in a crater, during the day it's brighter and during the night it's darker, even when the sun is not shining there. And so they could adjust this simple rendering variable based upon this smoothed grid approach, and then we would have a more realistic, almost global illumination-like lighting in here, is my opinion. But see, it's too dark, I can't see the station. Where do I have to go? I don't know, 7 degrees supposedly. But I'm not sure if I have moved laterally too much, so maybe I just lost the game. That's possible. Oh, there it is. Huh, so look at that. Not dead. Good. But instead of that, you get a beacon in your landing gear, and you have seen already we have a tracking chip for a tracking cartridge for our tablet. And if you turn on that beacon, which runs about almost an entire hour on a small battery, then you can use the tablet to find your way. What stupidly is not shown as a tooltip yet is that you can use the mouse wheel while using the tablet to select a different target. Because, for example, when you play in multiplayer, which this game has, which is sadly still deeply buggy in the form of synchronization problems, where suddenly you find yourself in a different location than your friends see you, but you can also have very cool multiplayer sessions with 7 or 8 people easily and build a station. I have done that. Really cool. But I mean, it still has some strong synchronization problems, and this game is even supposed to be primarily a multiplayer game. It is supposed to be the first-person version, or deeply inspired by Space Station 13, which is, I believe, a free multi-user dungeon top-down view game with very deep Stationeers-like simulation, where you can take on different roles and also play enemies, saboteurs and such, I believe. Very cool, I believe, but I have never played it because I'm not a multiplayer guy. Nope. And well, Stationeers, I've played that almost only in single player, and it's super fun in single player. So okay, now we need to melt that. Do we have an arc furnace? Yes, we do. Where do I put this? I want to use this here as the power supply for my station. So I would need to put that somewhere here. You can see that I can build that through the wall. I will just pretend as if I can't and go out here. You can place the arc furnace actually so close to the window that will toss its stuff through the window, which is kind of a cheat, I would say, but... Oh, I think I done goofed. Oh yeah, I can't build there. This wasn't good. I need to build it a bit further away. Hey, what's happening? Oh, sometimes the user interface craps out a bit. That's really rare. And I could no longer use the right mouse button teleportation thing. See, this field is now dead. I can no longer teleport from here. That's stupid. But anyway, I mean, the game is still early access, and but I see I have lots of playthrough and advisory videos up. Some of these last almost 8 hours. 8 hours of playing an early access game, and even the beta version of it, of which they release a new one every day automatically, an automatic build, but changes are basically only every weekday, sometimes multiple times a day, and then they will actually do a custom, they will trigger another build, so you don't have to wait until that one time of the day. Let's turn that on, and turn on the arc furnace. And melt some iron. And now we don't just have oxygen here, but also some CO2, which is in the process of freezing. You can see that here. And some pollutant, which is also in the process of freezing. There's also droplets, which would show that it's condensing, and there would also be some squiggly lines, which shows that it's in the process of evaporating. So, I mean, this is not even released, this game, and it will be, my opinion and actually hope is that it will be many years until this game actually is released, because what does a 1.0 give you? I have a better gameplay experience than you if you wait for a 1.0 for this game, because this game will keep mutating, will keep changing. For the price that I paid, I get this game, and a year later I get a somewhat different game, and I see, and you only get that one game with a 1.0 release. I mean, they will probably keep changing it then still, but I mean, why hope for a 1.0 in a game like this, whose early access version is already this super stable and super feature rich? Okay, so that is happening. Now let's build the 3D printer. Where is it? There. My construction supplies. There's the auto lathe. So where will I print that printer? Its backside is free, so I could print another printer on its backside, which I will actually do. And it just tossed this through the glass into the station. We can also build chutes, which are pipes for materials. And I can also build them through windows and through walls, which is intended and meaningful and makes sense. So if I would place 2 of these here, suddenly this would no longer feel like a cheat. So this is really a minor cheat. Excuse me. Okay, Where do I put this? Here, for example. Ah, it's too close. You shouldn't build things too close. If there's no space between me and the wall, the game might sometimes actually bounce you back and forth. You don't see that, but your suit might get damaged, and that you do see. Wrench. No, wrench. Alright, that field. I guess you can fix that field by just reloading. I've never observed this bug this clearly. Maybe I should just try that then. By the way, sometimes the windows also, these inventory windows which stack naturally, you know, and I can return that to its default position. Sometimes they kind of wander about, so there will be a gap down here, and this gap might get larger over time as you handle them, and you can fix that by reloading. I will just reload. Here we go again, let's see if that's fixed. Okay. See, so if you have a problem like that, just reload the game. But that's rare enough that it ever gets in the way. So here we have an iron ingot. Let's keep smelting stuff. For example, copper, very much needed. Oh, I don't have too much of that. Not good. I think first I will make the electronics printer to make more of these guys to get more power. Though I could also just use the coal burner. Pop. And now if I turn this on, it will pump 20 kilowatts into this cable, which will not have a problem with that, because the load will only be 1000 watts, 2000 watts, and whatever I have in here. You know, so that's not too much. We'll just swap this out. 75. It was already in red state earlier, you know, and the wind turbine slowly charged it up. I find that very serene that we just can place these things and we will get more power over time. Gold. Yeah. Building materials. So first I need this. Then this. It's quite a tango to build these guys, but they are super capable, and so that makes sense. And see, already done. I mean, when you know what you're doing, it's not that much. You can put the copper in there, the iron is somewhere here also. And I can actually interrupt the melting process here. You can see a countdown here. It was 50, now it's only 43, and soon it will be 42. I will wait that long, and yeah, okay, interrupt this, and start it again. So I can use that ingot already, and then I can start printing something. You have to make sure, though, that you have enough power, because while no resources will be wasted when you use your 3D printer, if the printing process aborts, the power itself, of course, will be used from moment to moment. So this thing has been turned on. Here you can actually excrete all the materials if you wish for other printing machines. Here you can start the printing process, and it will print endlessly if it has the resource to do so. And so if you're in the process of printing something, you can just click here or here to change the recipe. It will keep printing the current one, and then it will stop. So I need to print the electronics printer, and go. And I only need one of these. But let's look first. We have 20 iron, we have 50 iron, 20 are needed. We have 8 gold, 2 are needed. We have 13 copper, 10 are needed. So if I would have 7 more copper, then this guy could actually print 2 electronics printers. So it's definitely you want to change the recipe, because that would be a waste. So you can change these batteries actually on the fly without the power being interrupted with a drag and drop process. So if you discover in time that this guy is almost empty and you desperately need to put some power in so that your current long printing process is not aborted, you can just do that. How about the water? Why is it actually not cooling down? Well, it is, only very slowly, because it has such incredible thermal mass. It's not just some fluffy gas, it's a liquid. So there's something to keep in mind when you do some, when you, for example, have some pipes throughout my entire station which have hot water in them with the purpose of heating my station. That's something you can do if you wish. Actually, I just want to show you a station that I built on Europa in hard mode, and here I'm actually using this approach with heating pipes and cooling pipes and such. in this pipe we have oxygen mostly, and it's at 648 Kelvin. So very hot. 375 degrees. Here I have my landing pad for traders, some manufactories. Here I planted some plants. Currently they're dead because this was... Okay, let's not go into the details. And here I have my indoor furnace, which I shielded into a room so I could always open that arbitrarily. Oh, look at that. It's a bit cold in here. That's what it's indicating here. And it is now heating the room. You can see that here. The temperature is 19 degrees. Where do I have my tablet? Is it a normal tablet? Tracker. Nope. That is now 22.5 degrees. When I click here, this will turn on and off. Why? Because this is logic controlled. I have a program somewhere here where I have the computer and program some stuff, and we have different devices here where where programs can run. I can select all of these and then load the source code and edit it. Here in the editor, there's actually a built-in source code editor with tooltips and everything. Yep, that's what RocketWorks did. They are crazy. And my actual indoor heating works also in a crazy way, fittingly, by setting a room on fire. And this heats these pipes, and so the oxygen in there heats up. And whenever I need that, these are insulated pipes. That's why they look this funny. Whenever I need that, I will just open this digital valve here, which is logic controlled, and this will then unleash this super hot oxygen into this pipe, which will then give it to the room. But since the room is now too hot, the detector says, oh, we need to cool, and so this is now on, which just lets in the Europa atmosphere into this pipe, which will cool down the room again. Yep, also it's something you can do. So, back on Europa, our furnace is still doing its thing. Our electronics printer is done, so let's put that here, back to back. And also I would like to have the atmospherics printer, the hydraulic pipe bender. Oh, we need some more copper for that, which I don't have. That's a problem, because copper I absolutely need. Good thing the sun is out, so... So let's turn off everything that could consume electricity. For example, this guy consumes, I believe, 10 watts or something. Oh, yeah, of course I just turned off the arc furnace. But that's not too stupid, because I should rather conserve electricity. Turn off the light. Then the mining drill, which comes with the small battery, I can also put a large one in later. I can just print a large one. There are also nuclear ones. Is already pretty empty, but I can just use one of the other batteries if need be, which also need to be recharged, of course, at some point. But I need materials now. Ideally, I would go home now with a lot of iron and coal also, but first, of course, I will look for copper. And I'm not lucky. I found lead. Oh, that's not too easily found. I think the direction of the station is something along 130 degrees. So I will dig that up now, even though I don't need it right now, because I want to go into programming also, for which I need some solder, for example, to make the materials, you know, the chip and such. So I will just gather that now. Hey, wait a minute. Oh, I have copper. Right, I forgot my other mining belt. Good. That's fine.
Power low.
If ever your waste tank here reaches 4 megapascals, and currently it's at almost 1 megapascal, you need to quickly empty it, or see, you can just click here, can open it. you need to quickly empty it or swap it out with an empty one, which is the preferred solution, so you don't lose those gases. Because maybe you want to keep the CO2 around, right? I mean, you need something for your plants. Whenever that happens, you need to quickly do that here on Europa, or for example when you play on Vulcan, because it is your airstream from your oxygen canister into the waste canister is used to cool you or to heat you, to warm you, you know, and so the source temperature would very quickly reach extreme levels, and then your lungs take damage, and once those are damaged, you have a problem. Of course, I can run back and take the pill, or just keep it on me, but then it's gone. One of the things they had planned supposedly is surgery, even like it is in Space Station 13, I heard. I don't know any details. I don't know if they actually will do that. The next things on the menu are the new terrain, which is really soon, I think. They're really far with that already. And then they're working on the terraforming expansion in parallel, which of course I will get, absolutely. This is a no-brainer purchase. Then they will work on nuclear power. That is also firmly planned to happen. And for nuclear power would lend itself, of course, to have some kind of reactor vessel, for example. There's a game on Steam that is called Nucleares. Nuclearis, I don't know how to pronounce it. There you operate a pretty deeply simulated nuclear reactor on your own. Lots of knobs to twiddle, lots of machines involved, and there's also the reactor vessel, an open water container. That's very cool, and I haven't yet gotten far into that yet because it's really hard to get into. Anyway, so they will have such a thing in here, I think, and for that we of course would need something like a liquid container to have some kind of reactor vessel, yes?
Hydration critical.
So they would have to implement that also then at some point before they can make nuclear power, and then they can get to nuclear power. But they already did. That's something that they put in about 2-ish months ago, that you can have liquids in the world, and they implemented that really well. You can have liquids of all sorts. I mean, all the gases can become liquids also. And then they would have different colors. And then they would mix their colors accordingly when they are mixed as liquids, and so forth and so on. It's very cool and beautiful to have that in your worlds. So nuclear power is really not that far away, even though I think they don't have any any particulars yet hammered out how that will be, other than it will work like building rockets, as in it will have its own parts specific to the task, which can then be placed on the small grid, you know, like I placed the area power controller, as opposed to the large grid where you place the room boxes and the walls. And it will require all your atmospherics understanding and knowledge that you have learned over time in Stationeers to make these nuclear reactors happen, is what they said. So, exciting stuff ahead on the horizon. And well, the new terrain system which is incoming is also something to talk about, because that terrain will be finite, so you won't have these infinite worlds where you can get lost completely. The finite worlds will have probably something around, but this will not be nailed down. You can still have different ones when you make your own worlds. 8 times 8 kilometers, which is not little. Oh, the battery is empty. And you can still get lost there, I believe. And these worlds will not be procedurally made, they will be handcrafted, so they will be much more meaningful. You will have, for example, maybe a patch of gold over there, so you have to travel there, possibly even build a small survival outpost to get there. And, I mean, this is a stupid example. I mean, gold is not the best example for this, because you need gold so early on. You might say, okay, handcrafted, this means there will not be so many different worlds then. Well, one thing is, maybe your starting location will be randomized within an area, so that's a thing. Then the ores will possibly be somewhat randomized, and so forth and so forth. And then also, this is just the first stage. See, when they make these new worlds, they introduce something very awesome into the gameplay. When they have these worlds where you then need to travel, Where's the station? I think it's over here somewhere. That's awkward. Where is it? Ah, damn, I completely lost track. That's a problem. Wasn't it 300 something? Don't let yourself fall too quickly, else you might get suit damage. Yeah, I might actually be out of luck here. Lead. Oh, that's not good. One thing led to another, huh? And then I lost you. The station. Damn! But this would mean basically that the game ends now, because when I die and get reborn here... Well, okay, I would start in my spacesuit, and I would possibly spawn near my station. So, yeah, and the astronaut suit where you die is not lost. It will stay there. I'm usually pretty good at eventually finding the station again, but of course sometimes that really doesn't work out. If I had not destroyed my landing capsule, not the lander, the landing capsule, that would have an orange glow that you can see from afar if you're looking from the right direction. So that would be helpful now, but I have destroyed it. And there's nothing yet in the station that is powered. I don't know if the power switch of the coal burner would be lit green when it's turned on now. I think so. But, yeah. I might actually have lost the plot here. But since I am so occupied explaining stuff to you in parallel, I think that can be forgiven if I just reload the game. Or use a cheat to find the station. Because, I mean, I can just look in the save file where I am, and then where something that I associate with the station is, and then I can, with a few attempts, then possibly find that direction again. And I will do that because, I mean, it doesn't count really. I'm not demonstrating, hey, behold, I can play this, but I'm explaining to you how this works, so... Alright. There we go again. Use the cheat to find the station. Yep, I just cheated. The only way to survive for me, so... Normally I don't, obviously. So let's melt some stuff. First thing I needed was copper. So let's just swap that out. As a beginner, you can have the luxury of drinking through your closed helmet. And also eating. And when your health, when this is down at 0, then you will take damage, and another entry will show up here, like a red cross showing your health. It will tick down from 100%. And what you can do then, if for example your drinking stuff is only at 0, then you can just press the right mouse button for a short time when you have that here, the water bottle in your hand. Then you will drink only a very tiny sip, which will get you above 0%. And in that moment, the damaging will stop and the healing will already set in. So that's something that you want to keep in mind. Uh-oh. Ah, shit. I can't even place the wind turbine here. Not a problem. So, let's print the hydraulic pipe bender. With what little electric energy we have here. It's not too much, really. We have a lot of stuff here. Where would I put all that? There's a locker here somewhere in the survival supplies. Not sure where actually. Electrical supplies. Here, okay. The so-called residential supplies. Let's unpack that. There we have the container mounts that I can use to mount these containers on a dedicated location. There was the locker. We need 2 of them to make one big locker. Table and the microwave and what is this? Some eggs. Where will I build the locker? Not sure. I'm trying to build it in a way that it doesn't... that's not a problem. This is for placing a fire extinguisher on the wall. This is actually for a gas mask. That's a new thing we have now for a week or so. It's basically a spacesuit helmet, except it's not a spacesuit. You can use that in your station when there's some pollutant as such. Then you have two filters that you can put in there, and if you put in a pollutant filter, then you will be protected from pollutant. Then we have the small locker, but I'm looking for the big one, which requires 2 kids locker to build. Okay, that's not too much in the way, and also not too time wasty. Okay, let's burn the next stuff. Gold. And then we can put some stuff in the locker. I will later make electrum. Oh, by the way, electrum. Just as an example, here we have an ingot. And when I look here at the home page, I also find the ingots directly after the ores, of course. You can see the things that you can dig up. For example, uranium, which will of course become relevant once we have nuclear power. Currently, it's not so relevant. It has a lot of pollutant. If you're hunting for that, the uranium can come in handy. Not that you need it, there are other sources for that. Pollutant is basically rather available in abundance. Then we have silicon, which I need for plastic stuffs like windows and such. Silver, which is a special ingredient for some things, and it can be used together with gold to make electrum. Then we have the reagent mix, which is not something you dig up. It is basically a waste product. I will get into that at a different time. When you botched your smelt, for example, then you have your smelt in there and you can treat that with the centrifuge. Nickel we already saw in the world. That will also be relevant to make the stuff necessary to upgrading the manufactories. At least I think it needs nickel. Then, of course, iron, very, very important. You need it all the time. Lead together with iron makes solder, so I will need that later. Gold is needed for many recipes. Copper is needed for many recipes. Then we have cobalt, which is not needed at all for a recipe for a long time until you're in the later game. When you have the advanced furnace, see, we have here the ingots. Where you can see the basic ones I can make with the arc furnace. These ones I can not make with the arc furnace. I need the standard furnace for that. And these ones I can also make with the standard furnace. And in the same way, the advanced furnace can make all 3 of these. And once I'm in the advanced stage, cobalt comes in handy for recipes. Before that, it can also be used together with silver and some fern, if you have that plant, to create new pills in the chemical station. Yep. It's a thing that you affix on a table. It's not a room or something. Copper, then coal, of course. There's charcoal, which is very, very related to that. Doesn't carry that much energy as coal. And there's biomass, which you get, for example, from which you can get from plants. Not directly, but in principle. It has a lot of volatiles in case you need that from a different source than just digging it up. Because we have the frozen stuff here also. Volatiles, that's just pure volatile gas. And then we have oxide, useful on the moon, for example. If you toss that down in your station when the sun is up, it will melt, and then you will get an oxygen atmosphere with a little bit of nitrogen. So that's, I hope the warning that I gave at the beginning of this explanation video comes back to mind. If you use that for your spacesuit, you need to consider that there's nitrogen, which will build up in your suit, so you need to flush, or you need the filters for that. Or you can use a filtration machine. You can basically have a station atmosphere that consists of this stuff or of more other gases, who cares, and then you can pump from that station atmosphere through a filtration unit, and then you put just an oxygen filter into that unit, and then one of its outputs will have only oxygen, the other output will have everything else. And there's nitrides, which I basically never need. It has nitrous oxide and nitrogen. And then there's water, which is also pretty much important. You don't get anything back. I mean, it's not like your pee can be recycled. Sadly, that's not in the game. Likewise, you don't have anything else to recycle there. So you have to keep creating new water or get it. You can dig it up here and get water and a little bit of nitrogen, or you can also create water with the respective device where you combine then fuel gas, oxygen and volatiles. 2 parts volatiles, 1 part oxygen through the respective device gives super hot steam and some pollutant and so forth, and then you can filter that out and cool it down, and then you have water again. So you can produce that too. Pretty cool game, huh? Lots of things to learn. Yeah, you don't have to know all of that stuff. I mean, I have played for so long, no wonder I know all these things, but many of these things you don't need to build your basic station, as you will see if you stick around. Oh, I need iron sheets. Cables can be printed with the electronics printer, also the advanced cables, the heavy ones, the only other type of cable there is. But you can also... Do I really not have any more cables left? You can also just use the auto lathe, another cable coil, which can print some basic things that otherwise other printers are dedicated to print. And now I should not close this, because the electricity grid calculation is a bit iffy. This could have interrupted the printing process, and then I would have lost these 99% of production, as in I would have lost the time, which is very important at the beginning, not to not lose too much time, and I would have lost the the electricity that was invested from the batteries. So I have almost no electricity left. That's a problem, but we have our coal burner, so let's just charge up all the batteries when we're at it, huh? Oh, yeah, okay. Let's charge those batteries. You can see here 32, 33, 34. It's charging all of them in parallel, and since the 20,000 watts would normally be wasted, it's a good thing that I have these in parallel. 1,000 watts, 2,000 watts, and then 2 times 400 watts. And if I would now produce something in parallel, that would be even more productive. What is it that I could produce? How about the security printer? Can I make this? Gold, copper, steel. Nope. Not right now. Or did I choose the wrong recipe in the haste? Security printer. Nope. Okay, let's swap that battery. Mining drill is ready. Tablet. And of course my Zeus battery. There we have some CO2 that came in through the door from this guy here, and since it's so cold it actually, yeah, it froze. That is carbon dioxide, pure carbon dioxide, frozen. I will keep that around since we can use that for the plants, though it's only very little. Okay, that's nice battery-wise. Let's put up the hydraulic pipe bender, and then we are ready to build a proper airlock, not just the limited one that we could build now. I will show you all that, if I have the time, because I also need to kind of survive here. I have not played the creative mode much in my first couple of 100 hours, because I thought it would take away from the experience of the depth of the simulation, and I think that's true, but still I also have learned to appreciate it. You can certainly build more wildly, more freely there, and you would then build things that in survival you would possibly never decide to build because of, well, you want to be efficient and you need to survive, or later you don't want to waste too much time on making the materials and such. Yeah, all the coal has been used up, but I can leave this guy on, and that's also pretty useful from a distance. even though it doesn't have any electricity to really show us that. It's not using the power that comes in here from the wind turbine, I can tell you that much. Huh, what happened here? So let's try to print another wind turbine, because I like to no longer bother with the power. So let's let more power come in. Yeah, you can throw stuff with Q, but I guess you can have already seen the tooltip keys down there. Do we have gold in here already? Yes. So we'll put that then in the pipe bender. And what do we need to make an upright wind turbine? We need some iron. Do I have some iron? I do not. Well, let's put it in then. Huh? That should have worked. Okay. Yeah, I put up the locker, so let's put some things into the locker. I can already plan my first steel smelt. You can tell I need some more coal here, because that's what I need for steel. Let's see, here we have the advanced ingots, which are of course used in the manufactories. The simple ones, arc furnace. These ones, for that I need the furnace. Steel weirdly looks like this, even though it's an advanced, well, it's an alloy, it's not just a basic material. And if I click on this, we see some blah 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 here, which is actually helpful. It also tells you what kind of fuel gas you can use. We can make this with the advanced furnace or with the simple furnace. I would prefer this to be printed up here, so that you don't think, oh man, I need the advanced furnace for that. No, let's move on to something else. That's not a good way to present that information. Anyway, and then we need iron and hydrocarbon. And that means we need coal. That's what that is, hydrocarbon. So we need 3 parts iron and 1 part coal. Yeah, that's what that is. How many can we make? We can make 2 actually. Let's make all 2 of them. If we have the power. Oh, we do. So then let's see, what else do I have on me? I see the shadows are a bit harsh. There should be some kind of global illumination effect here. It's hard to calculate, I know, but I just talked about this potential hack that they possibly could use. I don't know if that's a thing. But it's not like they're looking for things to do, you know, these developers are super focused. It's a small developer team, and they have to really think about what they do at which time. Which is also pretty annoying to some players who think, hey, why did you remove the rovers? They're in all the advertisement materials. And arguably they could remove them from those for the time being, so that those complaints go away. But once they have the new terrain, which would then be compatible, I guess, with the vehicles, which the current one quite isn't, then they could put them up again. So, if you want to see the rovers in action, I have a video about those. Now you see where I'm going with this, huh? Yes, I told you that you can use the 6 keys above the arrow keys to rotate stuff. What I have forgotten to say is that this other rotate key, which in my case is R, the auto rotate key, is very useful. Here it doesn't do much. The noodle will be oriented any which way because there's no logical reason for it to be in any orientation. But here you see only the meaningful ones, so that can save a lot of annoyance. Yeah. Okay, let's turn the thing off because it has a base power use of 100 watts, like all the other manufactories too. I just changed the station. So now we have more power coming in. And you can measure how much power is coming in if you print the respective materials, but I'm not yet in the mood to go into those rather playful things. First we need to get an airlock going, we need to heat the station. So let's work on the airlock then. I will now print the advanced airlock chip. But I will first show you how to make a simple airlock, which uses the simple basic materials that you land with. Okay, where is... my god, it's so much stuff lying around here. So first clean up a little, this else this is not really manageable. That shouldn't go here because, okay, doing this while the station is still cold, not a problem, but otherwise it would melt. Not a good thing. Okay, that stays here. That is no longer needed right now. And now I will use the drill to delete all of these crates, except the green one, which is something which has materials that I will need much later, and that are also well combined, as in the chest is pretty self-contained. So let's put the feeding materials. You can see here we can click up here to get a water bottle bag, or get a water bottle from the bag, or down here to pick it up. Here we have the 2 cartridges. I want to put those away since they could otherwise so easily get lost. But I don't quite need them. I could also just print them again later. Something was just tossed in by the arc furnace. Do I have something more to melt? No. So let's close that. Or should I melt one of these? Yes, of course, copper. That wouldn't be stupid to have some reserve copper. Portable generator. Yeah, let's unpack that so you can look at this. Here we have the portable generator, another thing that you can unfold with the right mouse button. And this guy can charge a battery if you put a gas container in there, a fuel container. There's one in here and it's an insulating package. I'm not gonna unpack this because you don't get the insulated package in your hand or something. It's just for delivery. And this guy I also don't need right now, so I can deconstruct it again. And it also comes with a power connector that you can also print, of course, everything can be printed. And then you can carry this guy once it's built onto this, and then you wrench it up to connect it, and then you can actually use this as a power supply for your station. And you land with that, so you land with plenty of supplies right now. The passive vent, well, that's basically an opening to your pipes. Because pipes, which we also have here, and they're built exactly like cables, except the supplementary tool is the wrench, not the wire cutters. They are closed. So you need a pipe cowl, or this thing, which is a passive vent, to open them. So now this pipe is open. This means that now the pipe is no longer a vacuum. Let me just show you that with the tablet, which can just look into things. Here we see this pipe network, which gets an arbitrary number, just like this room I'm in, 3, and here 4, and out here we have world, gets an arbitrary number from the game engine. So this pipe has nothing in it. And this pipe has, well, the room atmosphere in it, because it's streaming in there and is landing in there. So now things get more interesting, don't they? And here I will have an active pump called the active vent. There are 2 more of these in the game, 2 different ones, bigger ones, more powerful ones, but this one is sufficient, and also I don't have anything else yet. And now I need to cable it up. So this thing would now have power if I turn the area power controller on. And then I could, well, let's just do this then. So you can see what it does. Now I'm pumping from here into this box. I will just close the door. Now I'm evacuating the station. slowly, because the station's atmosphere, you see here, is streaming into that guy there very slowly. The opposite direction is this. Now it sucks directly from the room. It's very powerful when it does that, and so it's very powerfully pushing the gas in there. So now I need to put up a console. The kit console is very important. Not only is it like the tablet, that it has its own cartridge kind of things, motherboards, and which have various different functions. But also it has the LEDs, here the LEDs, that this thing can display a number. That thing can also display a number. It's red now because just like the big locker that I wanted to build, this bigger LED needs 2 of the kits, and this one needs 3 even. Then we have this basic console here, which has 1 connector, so that's for data and power. Here we have the same thing with 2 outlets in case you want to like separate power networks and want to connect them to 2 of them. It's the same thing otherwise. This is just a diagonal screen. It's still the same thing, it's just a design choice basically. And then we have the LEDs. I will just use the basic panel. What's happening over here? I keep hearing this sound. Maybe I'm just as the threshold between these delivering enough power for this guy to charge up and not charge up so that it is discharged by the doors. Because as you can hear, this Tweety bird sound, high means it is currently charging the battery. Low means the power coming in is lower than the power that's being consumed, and so it has to supplement that with the battery. Okay, now if I go to our airlock supplies, we find, for example, the airlock chip. And we find the kit sensors, which I also want to explain. We have the daylight sensor here. And you can even see here, is it exposed to sunlight? No. What's the solar angle? Well, vertically it's 138, horizontally it's minus 40. And for historic reasons, there's also the value solar angle, which some people might still use in their programming. And there's solar irradiance and mode default. I'm not sure about that. Let's look that up. Day sense. Well, down here for every device, oh, that's something I wanted to show with the doors, right? And I skipped that part. You can see the logic values that it has. The door, for example, has an open value, which you can read and write. And so you can find out whether the door is open, and you can also open and close it. And, well, I don't know what the mode actually... Ah, yeah, okay, that's irrelevant. Let's not talk about this now. So this guy, depending on where you place it, will give you different angles, so I always place it on the ground, so I don't have to rethink things so much. The sun is currently at vertical 142, and noon is 0 degrees. Midnight is 180 degrees. It doesn't mean it has to go up to 0 degrees and down to 180 degrees, the full cycle depends on which moon you're on and so forth. But I'm saying that's the general concept. So the horizon is 90 degrees. This also means that by just looking at the angle, then you hear 10 degrees, for example, you cannot tell whether it's before noon or after noon, because the sign is still the same, it's still a positive sign. Okay, that's the daylight sensor. Very useful for automatically pointing your solar panels, of which there are various kinds, automatically at the sun. Let's just go over these quickly. The basic solar panel is what you get on the moon in your lander. You can place it horizontally and vertically on walls, but it also has a second build variant, which is a diagonal, which is exactly 45 degrees. Obviously, the sun, once it's a bit out of angle here, once it's not shining onto this thing perpendicularly, will not deliver so much energy to the sky. And when the sun is still well shining on this thing, or on the other ones for that matter, but the angle is very off, then they will get 0 voltage, they will get no watts. Also depends on which world you're on. If you play on Mimas, for example, which is moon-like, then you will get very, very little energy from the sun. And the sun will also look very distant. But the majesty of Saturn in the sky, very close, because Mimas is a moon of that, makes up for it. Yup. Also, you play there for a challenge, not just for the sights. Then we have the solar panel. This one can be oriented with the wrench horizontally and vertically, but also using logic, and you have to tell it though which direction it should face, and that you do with logic chips, or which I prefer with programming. I prefer the programming thing because it's just omnipotent. You can just type down what the fuck you want and that will happen then. And you have several build variants here. You have, well, two of them. This one has its power and data combined, and this one has them separate. And in this case, you would probably want to build the separate one. Why? Because, well, the solar panel and your wind turbines and so forth, they are on a power network that comes into your station. That is not the power network on which you probably have your computer running and your logic chips. Because, I mean, those need power too, right? So you would have that inside your station, cable-wise. But then you cannot attach to the logic of the solar panel. Except if you combine, if you're using this here where both are combined, then obviously, well, what am I saying? You need to connect to the logic of these guys to control them. And if you use this solar panel, then this would mean that you're also connecting with their power. But this means they would have a power loop, and that's always very unfriendly for your power systems. Cables could burn out and such. Therefore, you would use the dual solar panel. And the other ones, well, there's also the difference of storm hardened. Also, here we can see kits, and here we can see the things that are built with that. So no wonder there are so many. In principle, it's really not that many.
Power low.
So then we have the proximity sensor, which turns green when you get closer, and you can also check out whether it's activating with logic. So you can, for example, turn on the computer when you get close to it automatically, which consumes 200 watts, I believe, so you want to turn that off when you're leaving it. And you can also turn on and off your station lights, for example. And I abused it once to find out how far I am from the station, and my advanced tablet, not the simple one, was telling me that then in spoken numbers. Then we have the motion sensor, which triggers when something is in the same world box. So if I would place that here on the side, on outside the station, and I would walk past in this grid slot area here, then it would actually also fire. Then similarly, we have the occupancy sensor, which finds out whether you're in the same room. Since I'm outside now, this thing never fires. But if I place that here, for example, and then I'm standing over here, it still counts as me being in that same area, and so that is useful for turning on your lights, your station lights. Yeah, actually that's better for the station lights. Then we have the gas sensor, motion sensor. Yeah, we had all of them. We need the gas sensor now. The gas sensor allows us to read what gases are in a room, how hot the room is, what pressure the room has. And this also allows the logic chip here, which also uses the same values in the programming of those doors, to find out whether the
Hydration critical.
whether the airlock is empty. And that's something it of course needs to know, so it knows what the next step is. This thing needs to be closed with a glass panel, and you can know that as always by pointing at it with a tool. And now we need the disk. Very important. It is basically only like a switch, like a toggle. It doesn't have any data on it. It does not. But up here we can see that guy, and even when we cannot really point at it, we can still hit the hitbox, so that's very friendly. If I turn on my airlock controller here, error in config. But if I stick the disk in, then I can see the configuration. And what can I do here? Well, I can select the components that belong to the airlock. The gas sensor, for example, then the composite door. Hey, wait, which one? Exactly. You can see here, this word here changes from exterior to interior, because maybe you have observed that my filters of the spacesuit are obviously not off, my air is obviously not off, my AC is also working. So why is it saying off here? Well, because when I click here, I turn it off. Now they are off, and I will soon...
Temperature low. Temperature critical.
I will soon have trouble.
Temperature low.
Very aggressive on this world. And in the same way, when I click here, this door will be assigned as the exterior door. Now let's see, what if I click on this one? then this one can still be operated by me. And this one cannot be, because it's currently disabled. It is, it's locked. It's under control of this guy. Okay, so I selected the wrong door, because this is the internal door. I need to select the exterior door first. So this is one way you can find out. Another one is to use the labeler, which I believe we have. Yep, there's another battery to charge. Oh, right, this guy needs to be turned off, as I'm wasting battery. The three guys are actually doing it. I mean, all batteries are full. 99% is full enough, and mine that I just swapped was also full, so that's all cool. By the way, this guy consumes 50 watts, and when the airlock is fully configured, you can just turn it off and toggle the airlock with the buttons instead of the on-screen interface. So let me just change the door's name to outer, for example. Oops. And now you can see it is saying outer. But that's a stupid name for the door, so let's just call that Station 1. And wait, Station 1, and close it, and then you can see Station 1. Stupidly, the same name is printed on both sides. So yeah, it's not. This is not the way to the airlock. This is the way out of the airlock. But I mean, the logic problem there is clear, right? There's a mod for that. There's like a mod for everything in this game, but I don't play with mods. I don't like that. I want to play the vanilla experience. So Station 1, and the active vent. Now it is trying to repressurize this room to 100 kilopascals. We can remove the disk. I can stick it up there. This disk, whether it's in there, can be checked via the logic values, but it has no other meaning. This is historic. So, and then I can cancel the repressurization, which takes too long. I already told you that the station air streams into this very slowly, so it's a very slow cycle. So let's open the airlock and go through the airlock. This is closing, this is pumping this room empty, and then is opening the door. We have an airlock, yeah, but it's not a full airlock, since now it's just repressurizing this room to 100 kilopascals. It's not evacuating it first, and so if I would already have meaningful atmosphere in here, that would be bad. Therefore, let's make the advanced airlock instead. Wait, can I open and close this now that it is not powered? No, because it is locked. The bolts are locked. So, something to consider. If your airlock is not functional, you are kind of out of luck. And so it's advisable always to have not just one, but multiple airlocks. But primarily, you should have an area power controller in your airlock. So, the advanced airlock gives us two advantages. Oh, the door is still locked. I should have unassigned it first from the airlock chip. By the way, the airlock chip here still has data on it. And if you're ever in a situation where it seems to have gone insane, which can happen if you, for example, disassemble this guy when it's assigned and then reassemble it, you will see in the list there's a red entry. It doesn't, I mean, this guy will probably also show up, but the red entry doesn't go away, and that's a problem. And what you can do then, you toss it to the ground and you stab it with the screwdriver. Now this thing is reset, but this doesn't mean that the airlock is now magically no longer locked. It is? God damn it, I just found a cheat, basically. I didn't know this at all. That's weird. Wait, let me just take a screenie so I can later bring that up in the forum. Okay. That should not be. Okay. The advanced airlock is in there, but we need also a second area. We need another active vent for that, obviously, because we need to pump in the opposite direction. That's the electroprinter, and this is the hydraulic pipe bender. So now we print the active vent. I need some iron and some copper for that. Do I have that? I have copper, but I don't have iron. Well, I could just toss this stuff out still 10 grams of iron, okay. The frame rate is kind of tanking, huh? I will, for the sake of the video recording, just turn down the landscape rendering to minimum distance, then we have super frame rate again. Superior frame rate. And then I will make another passive vent. You have to know that devices cannot be connected to each other. So if I, for example, have a pump that is kind of like a piece of pipe, except that is a device then. If I have a pump that I put basically here or whatever, I cannot attach another pump straight next to it. So this means I can, for example, not attach an active vent directly to this active vent. But the passive vent is a different beast, because the passive vent is not a device. It is just a pipe that is open, just like the pipe cowl. And if I place this here now, my airlock is complete. Now I need to assign the devices, and then we're fine. And now you will see the second advantage. Did I forget to put the chip in? I did not. Oh, there's no power. Of course. So where's the disk? Here. So the second advantage is that you can define the repressurization value, which most people would then set to 0. So we skip that entire cycle. Now I have to select two active vents, one for the exterior side. Which one is that? This one is not locked. This one is currently locked. Okay, that's the one then. The other one would have to be the other one. I could also just name them with a labeler, but you know. Station 1, airlock, gas sensor, and that's it. My airlock is now functional. And it will now separate the two atmospheres properly. Which means that at this point I could actually begin to make sure that my station isn't that cold. One way to do that is I could toss down the road flares. Maybe I should even do that instead of building the furnace indoors. But you know, I want to show you that stuff too, so why not Zoldberg? Can I make the advanced furnace now? I will disable the airlock again so I can go in and out quicker. Because currently I don't need it yet. The atmosphere is not yet special to me. The furnace can be printed with this guy. You can look that up in the Stationpedia with F1. I need 30 iron and some copper. Yeah, where do I find the iron? I have to melt some then. Or I have to mine some then. The sun is out, let's do that. I turn off everything that could consume power. Swap this guy. Take another sip. Through the closed helmet. Which is not so unrealistic. I mean, astronauts on the moon are actually doing that too. And in space. So, there's that. Yeah, but this looks a bit off-putting, doesn't it? Let me just turn that up again. And here we go. It could be advisable that you don't dig up the stuff that's directly visible to you immediately, so that you can later find that patch again and continue digging, but that's usually not necessary. Most of the time you will be able to take... what's happening? You will be able to take all that you can take from the sky, and if you leave out one or two, I mean, who cares? You have an entire infinite world here. Oh right, I was still talking about that terrain system. The new terrain system, 8 by 8 kilometers, constant defined worlds. Supposedly all the worlds that we currently have will be in there from the start when they release this, but maybe there will be a few weeks between that. They would certainly focus on that then, and this will certainly begin a new era in the development of Stationeers, because I mean, pretty clearly, then we will have reason to travel, because the worlds will be more diverse. There will not be like the universe uniform when you zoom out far enough that everything is just a blur. And so this will then begin the idea of missions. And when that comes in, the developers will be basically triggered and to think more in the terms of missions and purpose. I think that psychological effect might kick in, and then we will get some development on that front, I could imagine. I mean, it's not like they don't have a game plan, but still they do keep morphing this whole product around in ways that they find optimal. I think they have now kind of settled for a direction that was quite different in the early days, I heard. But I started about 1.5 years ago. Not exactly, a little bit less, 1.3 years ago maybe. I started with Stationeers. So there's enough iron for now. Oh, right. Doody-doo. So we need a lot of iron to make the furnace, and I would like to get some coal so that we can make a bunch of steel, because I remember that often when I was let's just say 100 stack, or actually, okay, if I have 3 iron and 1 coal, that will give me a stack of 200 steel, that ingot of 200 steel. The maximum ingot size is 500, by the way. And you can also just build a stacker with the auto lathe, which allows you to separate those into smaller stacks, which will also allow you to stack everything that the manufacturer tosses out instead of it falling to the ground. So I often noticed that eventually I was running out of steel rather quickly, and so I want to make a lot of steel from the get-go. This stuff is pretty valuable, so I want to take all of it. Valuable as in, well, when you need it, have fun finding it on this planet. On the moon, I think the finding of resources is usually pretty easy, but that might also just be RNGesus who just helped me there, I don't know. So, once I have enough materials, I will build the furnace, I will then create steel, and this will also make our station pretty warm, which means that I should also already print a door that would allow me to cool down the station, because, I mean, the outside atmosphere is oxygen. If I need to cool down the station, I can just open the door, as long as I don't do it open too long, you know? And I can even automate that once I can program, which we want to do, don't we? I mean, programming isn't that hard. I mean, I have been doing it for 40 years, so I don't really have a relationship to a mind that cannot program anymore. It's kind of impossible for me to fathom. But in principle, it is pretty easy. I mean, let's say we wanna automate the station cooling by opening and closing the door. This is what we would have to do. We would have to read from the gas sensor that we then have to install in the room, an additional one. We can't use the one in the airlock. Then, I mean, what if the airlock is cycled? The room will just keep heating up because it thinks it is minus 140 degrees and will never open the door. You need a gas sensor indoors then. Would like to get some coal also. See how tedious this is with a drill? It's good to use explosives. Station is that way, 200-ish degrees. But you can make a better mining drill soon, once we have the furnace up and running and the right materials. Then we can upgrade the manufactories, then we can make the heavy mining drills, the fastest mining drill the game has. And this will then be pretty much butter that I dig through. Additionally, later, when we have the advanced furnace, we can make ourselves glasses that allows us to look through the planet and we see everything inside, because what I'm digging out here is not just on the surface from which I keep digging it, because it's the only place where I can look, but it's also underground until we hit bedrock, which on Vulcan, by the way, is actually liquid lava. I think we can make the furnace now. And only one, please, Vasily. So. And then you can just dig like a hedgehog. Is that the term, hedgehog? Down there, right to that place. And you can also have a deep miner, which digs for you. But now it gets complicated again in two ways. One thing is the deep miner, it keeps spitting out dirty ore, I think is the name. Shouldn't that be here in the ore list somewhere? Dirty ore, yep, that's what it spits out. And we have to put that into the centrifuge or combustion centrifuge. This one is easy, electric, easy to operate, but it is not very performant. This one is very performant, but it is much more complex to use.
To exosphere, the dark side of Syntheria.
I guess I will keep digging during the day, if that makes more sense. Alright, so where do we stand? Can I prepare another batch of steel? No, I don't have the coal for that. But I have the iron for that, at least. Then we can already prepare another very interesting alloy. Too bad I didn't find more of the nickel, but maybe I will find more later. I should do that too. Oh, it's off. Okay. Office. If it is your job to turn off the lights, you have an office job. So gold here, which I want to combine with silver to make electrum. Then I have lead here. Didn't I have more lead? Yes, of course there is. Which I can combine with iron to make solder. I definitely need more gold, which is easy to find but hard to dig. Would be nice to have the electronics printer, for which I need steel. If this would be the hard mode, I would have died a lot already, because I definitely need to make sure that the station is ready for use much earlier. I will make another locker. 2 actually. And now the furnace. Quite the beast. And normally you want to place it a bit away from your station in case you mishandle it and things explode, but I will not mishandle it and so things won't explode. And here I can need it for heating. So it has an outlet, I will just put it up, then you can see it. The rotation of the skies. Ah yeah, okay, now I have it. Okay, looking good. Bit close to the wall for my taste. Let's move it then. Yeah, that's better. Let's complete it. We need iron sheets, and we need more iron sheets. And now I don't have any anymore, but any material that you need, walls, steel walls, etc., is printed with your auto lathe, and we can just print more then. Okay, so that's the furnace. Let me just give you a short explanation. That is where you toss in your materials. For example, the fuel ice that you can then spark here so that it combines, and then it will have its own heat and melt the rest, and this thing will heat up a lot and will also build a lot of pressure. But in principle it doesn't operate on fuel gas, it operates on heat. So you can use this input pipe to just pipe in some fuel gas and ignite that in there, or you can just pipe in anything like, for example, nitrogen, as long as it's hot enough. That will work too, yes. So you can also basically just make a room that is very hot, in which the furnace then will be heated by the room. That's also a possibility. But your spacesuit will have fun then. The simple spacesuit will not keep up, I guess. You need the hard suit then. And we need the output also. Where are my pipes? Ah yes, I have them here. So that we can relieve the pressure. That is not something we need right at the beginning for the first smelt, but soon enough. And so let me just print a valve. Iron. There are some really important things in the game, like the kit valve, for example, the sensor kit, the kit drain, for example. Where will I put this guy? I basically placed this wrong. That's where my ore is,
Hydration critical.
and that is where the furnace will be, or is. Oh, yeah, the beacon. Which we could use next time we go out, I guess. So don't lose my way again, huh? We've seen what that's like. And that's deadly, you don't want that. Don't die. And if you play in hard mode, then you will not spawn with your spacesuit. You will spawn naked. Yep. I mean, not with your dick hanging out or something, but you will have some underwear. So let's how I put this is my choice. This is just the simple valve. You open it, it has no direction, basically. This is the same thing, but it has one direction. You can still open and close it. Here we have the condensation valve, which if there's something that is condensing from gas to liquid, and you want to get liquids out of your gas pipes, because, well, we have two kinds of pipes too. The standard pipes, they are for gas, but liquid will damage them. Not every little bit of liquid, they have some tolerance, but then eventually the stress builds up, and once that reaches 100%, the pipe will take damage, and once that reaches 100%, the pipe will burst, and everything will be unleashed into the room. So in case you ever need a passive vent or a pipe cowl, and you don't have the materials, maybe you can use a trick or something. So these guys can take 60 megapascals. For comparison, the suit pressure that we have here is set to 101 kilopascals, and 1000 kilopascals would be 1 megapascals. So 60 megapascals are 600 times this. And this, by the way, is the pressure that we have on Earth at sea level. Yeah, the pipes. Then we have the liquid pipes. Which can take only 1/10. They can only take 6 kilopascals, but they can take gas and liquids. That's so the low pressure tolerance is why we don't use them for everything. So this is a game balancing choice, and it's also a lot of fun. It's annoying if you don't know how to deal with it, but I mean, it contributes to the gameplay fun, I must say. So this is what it does then. It would pipe something that would condense into... You can see this drop up there, right? It would pipe the liquids up there into that pipe, into that liquid pipe. You can only connect a liquid pipe there. I mean, you can place a gas pipe, but it will not actually be connected. And your build blueprint, your build ghost will also indicate that with its colors. The expansion valve, which I often call the evaporation valve, stupidly, there's never been an evaporation valve in the game, I think. This is for the opposite. If there's something that turns from liquid to gas in a liquid pipe, this would then take it over to the gas section. And then finally we have the valve gas that I want to use here. Which direction you use that doesn't matter. I like to use it like this with the handle pointing upwards, because then it expresses also the direction that the gas will flow into. It doesn't really matter, but it's something to consider. And now I did something relatively stupid, almost. Wait, I'm not done yet doing the stupid thing. The pipe is still closed. cowl, zack, bop. The furnace was already ready for use before I installed these pipes, but then I could not have emptied it. And now I could empty it. So the thing that I did here, relatively stupid, is now the outside atmosphere is here in that pipe. And once the room is warm, there will be worms from... Lady, please shut up, okay? The room's thermal energy will bleed into the pipe. You can find that by looking here at the pipe, then you would see convected negative, and so it would not lose, the pipe would not lose energy by convection, by touching gas.
Hunger caution.
But it would gain energy from that warm gas around here that bleeds into this then, at least the thermal energy does. And radiation is also a thing on the moon, for example, that's very relevant when you want to cool your rooms, because you can just radiate away your heat into the vacuum. Many people think, I bring that up basically in every video, that you indeed freeze to an ice popsicle when you exit into outer space. That's complete bullshit that Hollywood keeps perpetuating stupidly in basically every show and every film, and that's just wrong. What actually happens is as follows. Well, first of all, you will experience explosive decompression, but only from room pressure, or however low the pressure was in your space station. I mean, you can also live off like 40 kilopascals, not a problem, as long as the mixture is fine. But this will not really destroy your body. You will only have possibly some I don't know if this is actually damaging, but what is damaging is that there's gases in your blood, in your cells and so forth, and that gas will then, due to the low pressure, stream outwards. So you will have ebulism, which is when some parts of your biology are basically ripped apart by the gas escaping, but this is not necessarily deadly. I mean, this is only damaging and you can survive that. What will happen to you then also is, since you're in outer space, you will begin to radiate your heat away. See, space is not cold, it is also not hot. So before someone pipes up with a comment saying that space is cold, no, it's not cold. Space doesn't have temperature. When you have a thermos can where you keep your coffee in, which has this quicksilver mists on its outside, obviously not on the side that the coffee touches. This has a vacuum chamber, and this vacuum serves to insulate. So vacuum is something that insulates. It's not cold. Space is not cold. Space is just there's nothing. So you're not touching anything there. It would probably feel a little cool because currently my hands are touching this room gas, which has 22.3 degrees, and in space I'm touching, well, nothing. I don't know actually what that would feel like. I guess it would possibly even feel... Well, the thing is, in space you radiate your heat away, while here in this room, the room is radiating heat towards me. Have you ever wondered why when you have your room at like 23 degrees maybe in the winter, that feels colder than when you have that in the summer? My opinion is that's because the walls are colder in winter, and so you get less radiation heat from the walls. But I don't know that. Anyway, but what also happens is, let's look at oxygen here. The phase change diagram of it, which is not realistic, it's only realistic-ish. In reality it's a bit different, but when the pressure is very low, oxygen will evaporate. So the liquids that you have in your nostrils and in your lungs, that when you are suddenly in vacuum, you absolutely have to open your breathways as well as you can so that the gas can escape freely. The moment you take control of that, or it even close up your breathways, the high pressure will rupture them. They will take hard damage. That must not happen. You must release the gas. Not that you will ever be in that situation, but then again, who knows? Maybe you will be a space traveler at some point. So from your nostrils and from your lungs, the liquids will then evaporate, and evaporation means that it will cool down. And this means that it will be much colder, it will even freeze. So you will have ice crystals in your lung, which will damage your cells, and you will have ice crystals at your nostrils and even around your eyes. So that's freezing that takes place when you exit into space. But otherwise you will not freeze solid. You will only slowly radiate your heat away. Yep. Fuck Hollywood, huh? I mean, I love them for their entertainment, but seriously, why do they keep misinforming people like that? I don't get it, man. How hard would it be to just not do that? Where was I? I have no clue. So the furnace is now ready. We could now make steel, but I need some more coal. Well, good thing then that that the sun is out. .300-ish degrees. You can fall into these holes, there's no problem, but if you push yourself too hard into them, which can easily happen on Venus, for example, where you have violent stormy events when you dig out the Earth, because the simulation of the game in this regard is plain simply just dumb, because it will then, instead of spawning some planet-like gas in that place, somehow it will just spawn vacuum, and so suddenly you will be exposed to vacuum, and the pressure on Venus is very high, and so the surrounding high pressure gas will then toss you around. So if you run into this with pressure, maybe on this world even, I don't know, if a corridor is too tight that you dig, if you push too hard into that, it might actually damage your suit. I have not experienced that for a long time in that situation. I'm just saying that's something you should keep in mind. It's always good to have some duct tape on you, because if you hold the duct tape in your right or left hand, and then if that hand is active, press the right mouse button, you will wrap yourself in that stuff. That will not be visible, it will just be a progress bar, and then the visible damage, I mean there will be some red markings on your helmet and your suit. When you use the duct tape, those markings will go away, but there will be a progress bar here which will have lowered, because then your suit is no longer 100%. It will still work, but I think then it insulates less well, and I'm not sure if it actually leaks gases. I'm not entirely sure about that. Because I have had the problem, for example, that I was standing in my airlock and then it would not cycle completely because it was trying to evacuate the room, but since I was excreting gases from my spacesuit, but that was when it wasn't yet patched up with the duct tape, I think, then the airlock cycle would not complete. Of course, you can just abort that by clicking on the console, which you can otherwise leave off, like I said, then you turn it on for a moment, click on the button, turn it off again, then you will just skip to the next step. You can also, of course, program your own custom airlocks, which is pretty cool even, because then you can make very fast ones. Here we are on one of my first moon worlds, and I made an automatic airlock here that is programmed. The chip is here underground. You just walk in, it opens. Very convenient. Very fast, you can just walk through. Or you can even make a very advanced one like this one on this Europa world that I showed you earlier, which not only separates the atmospheres properly, but it has even 4 sides. So 4 different atmospheres are supported. Here we have volatiles, here we have, I don't know, whatever gas I put in there for demonstration purposes, and so forth. All that with one vent, actually. This is the biggest one, and it is super fast. Takes some programming, of course, to make that happen, and takes some extra building. But you can do it. Cool game. Some more coal, please. Looking good. Would also be cool if I could get some more of the nickel that I already have a lot of, so I can make 2 full stacks of the 2 materials that I can make with this stuff. I will go into that later when we go to actual furnacing. See, all this extra stuff that I'm doing here is something you would normally not do. I'm just trying to be efficient, which means that I'm developing on a broad front, And later we will have some accumulated events. I can do this, I can do that, I can do many things at once, because I have prepared so much. And this is really off-putting. This might take a while now to load, since I just reloaded the world. Yep, here we go. Where did I see the nickel? I'm sure I saw some near the station, which is there. About your jetpack, you can use any gas you want. It will just be excreted. It's kind of a magical device, which I hope they will eventually change to something better, something more realistic. But of course, when you use a gas that is possibly bad for you, then that's not something you should then not fly around in your station, for example. Lots of coal, that's good. Iron. Did I not see some nickel here somewhere? I thought so. Guess I thought wrong. Oh. Yeah, maybe I should get some plastic while we're at it. Station should be in that direction. Okay, let's go back. Oh, if you fly high enough, you can still see the sun beyond the horizon. And over there's the station. I kind of estimated its distance. 40 degrees. Let's see what we find on the way there. Copper, okay. Always welcome. So, I said there are two complicated things about deep miners. One is you have to pipe the dirty ore through a centrifuge, else it will just be useless to you. And the other is, if you look here at the ores, for example iron, if we scroll down we see gases and liquids. Oh, what's this? Yeah, if I toss this in the furnace and smelt it, this will unleash some carbon dioxide and some pollutant. And if they do that, for example, with the arc furnace, and the arc furnace is standing indoors, then this will be unleashed into my station. And pollutant is something you really don't want to breathe. But these are is only for hand mined ore. If this comes from the deep miner, then it will not have any gases. And yes, it doesn't have any gases even already before the centrifuge step. That is a certainty, it has been tested thoroughly. What you could do, I think, is you could centrifuge iron ore that you dig yourself, and then I guess this would also unleash the gases, and you can build a box around the centrifuge, which you can then use to capture the gases. Like you can also do the same thing with the arc furnace. which is advisable, for example, on Vulcan, because as soon as you smelt gold, which also has some oxygen, well, the atmosphere of Vulcan has a lot of volatiles, and it is so hot that as soon as some oxygen comes in there, it will auto-ignite. So that's what happens when you empty your waste canister, in case it is ever too full. And you have to fucking empty it. I mean, you have to absolutely have your thing here working. You will get a warning, by the way, if your waste canister is almost full, and then when it's actually full, you get another. But when it's actually full, on Vulcan or here on this world, things get fatal pretty quickly, because your suit will quickly reach illegal temperatures. A temperature that's fine for you is 0 degrees up to 50 degrees. As soon as you're below 0, your lungs will already take damage a little, but it will be not very much when it's only a little bit below 0. And that's a bit ridiculous. I mean, 0 degrees is really not too cold to breathe. I think that should be expanded. Anyway, so, what did I say, 20-ish degrees? Ah, we can see the light on the horizon there. Not to be confused with the star. And what is that there? I think it is the power switch of the coal burner. And what's that thing there? Oh, it's not. Huh. Interesting. So, how are we looking? Maybe I should... Oh, I don't have the tool manufactory yet. Okay, now we have kind of an emergency situation. I need to drink, but like I already showed you, that is something we can do through the helmet. But you know what? Let's pretend as if we can't. Let's play this emergency mode to get a little feel of what that's like when you're in that frantic situation. So now my body is taking damage. Now I am actually printing another door so that I can relieve the station temperature by opening this, because I will soon heat the station using the furnace. Where will I make that door? Here, maybe. It could be an automatic door, it could be a manual door. It is pretty much doesn't matter, except the automatic door needs electricity, of course. I think I will make an automatic door, an electrified door, so that I have the option to automate that. Of course, I could make two doors, one automated, one not. That's also an option. So let's remove this wall. Good idea to do that early, before the station has actual meaningful atmosphere, huh? Oh, I don't have batteries. I will use a glass door here. Luxurious, glorious glass door, so that it's just like the windows. Then I need plastic sheets. And I think I need 2 glass sheets, don't I? Yep, 2. You can later get a better spacesuit that has more slots, and I could also take a backpack within a backpack, for example, or I could have another mining belt or even a mining backpack that you can also carry in your normal backpack. The mining backpack works like the mining belt, that it will automatically pick up the ores, and I think it even has priority over the mining belt, but I'm not sure. So, well, let's close this door then. Why did I open it? And electrify it.
Power low.
See, you can easily get overwhelmed by messages like power low, pressure low, and all of these messages that come when you're not yet experienced. But the thing is, the idea is to ideally not even rely on those messages, but know yourself what flow situation you're in. Must take care once the temperature is much higher, because the pressure will effectively then also be higher, because hot gas expands. Yes, that is simulated. Okay, now let's turn on the airlock for real and leave it on for good. Locked. Okay, that was the right one. Wait, that's wrong. That's the external door and gas sensor and done. Alrighty, now let's fire up the furnace, so you see what that's like. The room is currently very cold, so... Oh wait, do I have enough volatiles? I do. But I don't have any oxide. Okay, I need... Okay, I'm sorry, I need to go out and get some oxide. Else that doesn't work.
Health low.
Did I not have... Oh, right, there. Health low is at 75%. Once my food is also at 0, the health will decline much quicker. Something to keep in mind. And yes, I have fallen over dead quite a few times in this game. Oh, something I forgot. You can actually print a spawn with the auto lathe and put it in your station, and then the tooltip will tell you click here with the left mouse button to assign your spawn location, and when you die, even in hard mode where you spawn kinda naked, you can... Oh, lead, that's cool. Okay, I guess I will drink something, the timing will not work out. Then you will spawn in station, so that's something you can do. And it's a nice thing to do to have reserves, like when you have a catastrophe on your station, to keep going instead of reloading the game. I usually reload the game, but that's something you should avoid if possible, because it takes away from the fun. But what if your station is too destroyed for you to survive? Well, normally your station would not just be one room, but multiple. With airlocks separating them, you would possibly have a little outpost somewhere that has an auto lathe and an arc furnace and a spacesuit and a spawn in it. So you could always... There's a tool. See, that is not a tool, so I cannot put it in a tool slot. But this is a tool, so I can get one other multi-purpose slot. So that you can survive them, and then you can rebuild from there, not from scratch. I mean, there was a world that's called Lulan back in the day that had actual structures, destroyed stations, where you could then go and dismantle them and use that material for your own station, or maybe just rebuild them. And you can still play that kinda if you now roll back to the oldest version, or is that... have they turned that off? I'm not sure, actually. I would toss out that CO2 is not so important. The lead is more important to me, because it's not so easily found. I mean, it's ridiculous. The video is already 2 hours long and I haven't yet heated up my station. But that's easy mode for you. That's where you can afford that. In hard mode, forget it. In hard mode, you have to struggle with the electricity first and then heat it up, and then see to that you get some plants growing. Not very early, you have the same resources as you have here. You will just blow through your liquid supply and your food supply more quickly, but still you have enough time. I mean, it's still relatively lazy once you know what you're doing. But like 2 hours without a heated up station, out of the question. And what you do then when you are in hard mode and you have not yet heated up your station, when you need to eat something, you go into your little airlock box and you toss down some road flares, 3 of them. You wait for like 2-3 minutes and then it will be warm enough for you to eat. God damn it, where's the station? The sun is already up, so if need be we could just wait for it. Oh no, it's... Okay, I'm not sure actually. More lead, great. Are you kidding me? Did I lose the station twice in this explanation playthrough? That would be ridiculous. I thought it was over here. Let's see if we can see it somewhere. Oh, okay, never mind. Should really have used the beacon, huh? Then you can't lose. It doesn't matter your distance, you will always find your station. As long as the beacon has power, but like I said, a small battery lasts almost an hour. And you can put a large one in. And what you can also do, you can actually print a stationary beacon which you install in your station. That one's pretty expensive energy-wise. It uses 300 watts. And then you can have it turn, I mean, if you leave your station, the lights turn off, but you can have it turn on the beacon, why not? Automatically. That would make sense. So let's turn this guy off, because once we have the furnace going, we will just use that for smelting. Okay, where are we? I needed some... Actually, I forgot. So let's... Oxide! Ah, damn, I still don't have oxide. I have to go out again. I have to go out again. Now I need the lockers that I made. Place them here. Yep, the doors are now on the left side, so that would be placed correctly. Yeah, well placed. Man, it's too dark in here. This one's full. That I don't need. Part of my confused activity is also decision making. So please don't be annoyed by that too much.
Hydration critical.
I'm preparing my smelt. I could do that in a mining backpack which has a lot of slots, and that's very convenient. I mean, your screen is even more full than it is than it is now. But I mean, you don't have to play it the way I do. You can also close many of the panels. Just it's more convenient this way. So I will make a lot of electrum, it seems, because we have the gold for that, the gold reserves, and other stuff I will leave here, or won't I? That is for Constantin, and then I also want to make some Invar.
Power critical.
But do I have the materials for that? Solar, eager to be made here. Some more coal here for the, oh, what just happened? For the steel. Okay, let's make steel and heat up the station. Is the door ready? Yes, it is. It's just not automated. I could basically show you... Yeah, that's a thing. I could... Okay, before we do this, before I actually go into this, I want to program the door to automatically open, and I program that with logic chips now. Because it's a very simple program, I can... I think I can do that. Something you would normally not do on this world, because just you need a warm station, man. Right mouse button to drop that, or you could have clicked on it to have the inventory. Let's get some fresh already. Cereal bar. I have more cereal bars lying around somewhere. Alrighty, I don't know what exactly I need, except of course for the sensor to find out how hot it is in here. These manufactories can be upgraded one step, not two. There's only the manufactories and the upgraded manufactories, and not sure where I want to place the gas sensor. And the advanced ones, they can produce more things, and they are also faster, but they need more electricity. So the cooling will come from here. If I place the gas sensor here that decides whether the room is cold enough, it will quickly close the door even though the room is still quite too hot. If I place it here, it will open the door when the heat here, which is much higher than over here, because there will be a gradient in the room, is much... I mean, it will basically cool the room before it is time to cool it. And if I place it here, it will cool the room not enough. So I should find some middle ground. Since I will eventually have some lights up, I could basically place it here on the ceiling, but then I would have to place a lot of cables, and I'm not yet ready for that. So I will just, I guess, place that here as some kind of temporary solution. So the next thing that we need is we need to read a value from this gas sensor. So let's go here to the electronics printer, look for logic stuffs, and then we have the kit logic IO, which has multiple very important and interesting things. I will explain those quickly. No!
Critical.
Wrong key, ouch. I press I, which opens the helmet. Okay, so here we have... Do we have a better place to watch this? Sure, here maybe. Okay, here... Well, maybe I should have prepared this. This is not an edited and cut video, it's all live, so yeah. Anyway. Here is the logic reader. This is the thing that we will now use for the gas sensor. On the left side you see a screw in. I use the screwdriver to select from which device I want to read. On the right side, the var variable screw selects which value I'm going to read, and from the gas sensor... oh, that was not the best term to look for in an atmospheric simulation game. Sensor lenses. Yeah, these are the lenses where you can look through the planet. You can see here the celestial objects out there, at least as some graphics overlaid over the planet surface. You can see the sun and all that. And here we can see through the station. We can see pipes and such through the walls. So here we have the kit sensor. From here we get to the gas sensor, or vice versa, doesn't matter. And these are the logic values it has, and what I want now, of course, is the temperature. So I would use the variable and turn that to temperature. And then this logic reader will hold the value of that gas sensor, or temperature. So then we have the logic writer, and on the inside, or the in screw, I select from which value to read. And it can this device can only read from a certain kind of devices. For example, it can read from logic readers, so it would read, for example, the temperature, which we could then write, for example, to an LED display. And then I would use the screwdriver to select the out screw at the top. I would select the LED display, and at the bottom I would select the variable setting, which is kind of the go-to standard default variable for a device if it doesn't have one that would be explicitly more speaking. You know, I mean, it's not like the LED device has a variable that is called number. And the IC housing, for example, where you place the programming chip, it has a debug value. If you point at that, you will see that value in your tooltip. And that value can be written to. And that value's name is also setting. And then there's the value mode that also many devices have. The doors, for example. Currently they're in manual mode, but I can switch them to logic mode, then they work differently. That's the mode. The active vent, whether it pumps inside or outside, that's also the mode variable. Anyway, that's the logic writer. Then we have the batch writer. So with this thing I could basically say one light, it shall turn on or off. And with this I could say all the devices on the local cable network of a certain light type will now turn on, because they're different light types. And the out variable concept is the same. I'm just writing to many devices then. Conversely, there's also the batch reader. Somewhere, let's find it, batch reader. On the left side you select from which type you want to read. For example, let's say you want to read from the doors. from all doors of a certain type. You would have to select the glass door or the composite door. Only from that type on the cable network you would then read. And I keep saying the word cable network. What do I mean with that? Here we have a cable network. Here we have a cable network, and here we have another cable network. This guy, the switch, separates cable networks, and transformers also separate cable networks. Transformers don't change the voltage, they're just used to define how much load can go through a cable. So if I have 20 kilowatts coming in there, and here we have a station battery, and I want to protect the cables, the thin cables, which I shouldn't use then, from overloading, because then I'm wasting, I can use a transformer which then set to 5 kilowatts, and so the cables will never be loaded with more than 5 kilowatts going through that. Yeah, that's cable networks. So if I use a network analyzer and the cartridge, I will see a list of the devices on this cable network, including also, of course, this area power controller, because it is on this cable network. And when I measure this cable network, which is coming in from my wind turbines, then I will measure also this area power controller, since it is on both cable networks, and also that one, and also the wind turbines.
Power low.
Oh, that was the wrong way, huh? Okay, let's continue. So that's the batch. We have the batch reader, where I can select to read from the doors, and then can read, for example, whether the doors are open by selecting on the variable screw with the screwdriver, the open value, and up there we see the method that is to be applied. Why is this different than the batch writer? Because if I want to tell all doors to be open, when I then write a 1 to the open value, so that is open equals 1, so that they are open, then that's easy. But what if I read the open value? I mean, one door could be open, one door could be closed. The method up there decides what happens with the potential multiple values. For example, there are 4 methods: minimum, maximum, average, and sum. So you can add them up, you can get the average, and if there are 4 open doors, and the 5th one is closed, which is then open 0, and you use the value minimum, then you will get a 0, because one of them is closed. And if you use maximum, then you will get 1, because at least one of them, in this case 4, is open. And average, of course, yeah. And by the way, so later when we program stuff, we will run into the same command. We will have a command that batch writes to devices, and then one of the parameters of that command will also be the method to apply. I mean reading, of course, yes. Reagent reader is, I don't know exactly what that's for. It's for, see, if you toss an iron ingot into one of the printers, then what the printer uses of that iron ingot is not the ingot, it uses the reagent that is in there, because that is also simulated. The ingot contains, for example, silver as a reagent. Like the ore also has silver as a reagent, but the device needs that in ingot form, but ultimately it only cares about the reagent. So this is what this is about. This is not about reading about iron ore or iron ingots. This is about reading the stuff therein. So then we have the batch slot reader, which is like the batch reader, but here, for example, we have the arc furnace, which has 2 slots, the output slot and, more relevant, the input slot. We can, for example, read if there's something in there and then turn it on, activate it automatically, so I don't have to push the activate button. That's very useful if you have some chutes here, you know, these pipes for materials, which I can use to toss it into the station legitimately, but also can use that to toss stuff from in the station into the arc furnace while I'm standing in here, and then this thing would automatically activate. So the batch slot reader has another thing. You can use the screwdriver to select which slot you want to read from. Conversely, we also have the slot reader, which is for a particular device and not for a device type. Reads from a slot, and I think we also have a slot writer. I don't know if we have that, probably not. Logic mirror is to bridge cable networks. You can select the device that you want to mirror, and then on the right side you can then attach to this thing, and you will see that the logic mirror will then be that device for all intents and purposes. Slot reader, yeah, we already kind of had that. Batch reader, reagent reader, batch slot reader. This is just a switch. You can select one individual light, for example, and then turn it on and off, or you can select a door and open and close it. Logic reader, logic writer, batch writer, logic mirror. Yeah, I think we had all of them. So, let's make sure that the station will keep itself cool once I have this thing turned on. These chips take a lot of space. One of the reasons that you normally don't want to use them if you can program. And program is kind of omnipotent. You can do everything with that. Everything that the logic chips can do, programming can do, and better, and more compact. I mean, the logic reader, which I need now, that's basically one statement in a program. But the program itself will be on a chip that will be placed on such a similar-ish device, which will take one place in the world, but you can write multiple programs on one chip. So how do we cable these guys up? Well, normally you would just connect everything with everything. First of all, it does need power, and it needs 10 watts constantly when it's turned on. You turn it on and off with this button. It flashes an error because it's not yet connected to anything. So this is the input value. I could now use the screw to select to read from the gas sensor. You can see here in the tooltip a cycle to gas sensor. You always see the next device that you could select here. And on the left you see the selected device. This can be a bit confusing. And I can also go backwards by pressing down R, which in your case is probably C. You always have to read the tooltips. So now we have selected the gas sensor, and the next one will be the glass door. You can kind of look on the right side and then break yourself in time, and then you will get what you wanted. And if you overshoot, well, just go back by one. Now we have the gas sensor. What do I want to read? I want to read the temperature. Okay, and what do we do then?
Power low.
We need to read that value from this chip, and we do that on this side. I could now connect the chip on this side, or I could connect all the cables with this guy or with this side also. It doesn't really matter. Let's keep it pure. I mean, more pure would be to separate that too, but it doesn't matter really. It's don't think about it so much. When you run into those cable network troubles, you will remember, oh, we have these different connectors. I can use that to solve that problem. Exactly. Currently, let's not think about it. So now I have this value here. Now I need to compare the value to a threshold, and depending on whether that threshold has been reached, I need to decide that the doors are open or closed. So one thing I already know is I need a logic writer, but let's not get to that. Let's first compare. I don't know really if we have a compare chip here. I don't think so. I think that would be one of the math chips. Can I find that just by typing logic? So we have logic IO, I just explained that, and with the logic memory. That is a kit. It has a memory chip that can just hold a value that you can even set by using the screwdriver. The second item of the kit is a hash generator. When you click on the screw of that device, you will get a list of basically all the things that the game has. I mean, like even broken debris and such. But I will not go into hashes and that stuff, because you know, when you have the logic chips, then you don't need to bother with that kind of knowledge, and so I want to bring that up when it becomes relevant during programming. So, a logic processor, I guess that's the one for comparison and such. Then we have the logic transmitter, which can even be used to send values. For example, you can use the advanced tablet when you're out there mining to control things here in your station. Then the logic switch, that's a kit of switches and dials just to hold a value or to define an on-off state, and you can read that value. Then we have the logic processor, which is, I guess, what I need now. Let's make one. The Stationpedia would, of course, have explained what this has. By the way, look here, our atmosphere, our oxygen is down from 7.5 megapascals, which we had at the beginning once I had dunked this into the tank. Otherwise we would have had 5 or 4.5 or something. So it's a good idea at the beginning to dunk that in there before the tank could possibly go out of range, 0 to 50 degrees. Anyway, this has now dived down to this value. You can see that we have quite some time left still, but we need to get this station heated up. Else, I mean, how do I get more oxygen? I'd have to dunk that into the tank. The tank is currently happily in a sealed little box room there with its 13-ish degrees. So I could open that now and dunk this in there, and then I would get a load, but then the tank would begin to slowly shift out of the range from 0 to 50. It will cool down too much. So you could only drink one more time, basically. So that's something we have to keep in mind. And the this canister also fills faster when this empties faster on harder difficulties. So let's look at the chip that I just printed. Unary math unit. This is, I guess, to for example, select minimum or maximum or something. Then we have the gate unit. I guess I have to read up on these. Huh. Compare unit. That's the one we want. So let's look this up then. Compare. What items do we have in the kit? We have the logic math thing, which obviously is for multiplication and so forth. We can also use some trigonometry functions, and pow as in raise to the power of. That's something that always comes up when I do my usual rant about all broken volume sliders. Yeah. Logic compare, the one we will need now. We select where the yeah, we can select greater, equals or less, or not equals. Then logic select, what's that good for? I think you can, it has two inputs. Let's say both of these are, for example, temperature values from gas sensors in different places. And then you can select here which of the two should be piped through to the other side. I think that is what the select unit does. So what does the min-max unit does then? Well, I guess greater and less defines whether it's a min or a max unit, and then it will let through that value. Which begs the question, what does this then do again? Huh, I actually don't know. I don't know. I mean, select unit, maybe that's also... Okay, I don't know. Maybe it's for selecting devices, not just their values. Okay, so then we have the unary thing, which floor, round, can round a value to integer, cosinus, and logic gate. Yeah, that's for Boolean operations. Are both true? Is at least one of them true? And so forth. Okay, we need the compare unit. And the compare unit needs to compare two values. I guess that's why it has two connectors. This is input and this is power. Let's give it power first. It doesn't matter in which order, I just want to do it like this. And then here we have output, and here we have another input. So that's fortunate. One input value will be this logic chip. I will just click here. Now we have the logic reader selected, which I can also label. See, this thing is a logic reader, but its name is also logic reader. I can use the labeler to rename it to, I don't know, a gas canister oxygen. It doesn't matter. I can also rename my oxygen canister here, which is not an oxygen canister. It's just a canister that happens to have oxygen, but the name is arbitrary. You know, it's all arbitrary. You can rename it. Okay, output. So the compare unit gives me a logic statement. Now I need a memory chip and a logic writer, because I need to compare with a certain value. That's what the memory chip is for. And I need a logic writer to tell the door to open. I can already select that recipe. Oh, copper. So I place here already the logic writer. Which value shall it write? This is the input connection. Never let your essential tools, leave them lying around. Essential tools, of course, the wrench and the wire cutter, the stuff you start with, you know, screwdriver, crowbar, wrench, wire cutter, hand drill, angle grinder, welding torch, or alternatively the arc welder, which is battery based. If you use the welding torch indoors, which I've done aplenty, and this would have been sealed up the whole time, then there would be some pollutant in here. That at some point that becomes relevant. Even if you use spray paint. A good thing these guys only have three connectors, not 4, so I can place them neatly like this. So I want to read here the value of the compare unit. Okay. And as out value, I cannot just select anything, no other writable devices or network, because this out connection here, well, it's not yet made. I don't have a connection there. This is the power connection. Now I should be able to select glass door. And which glass door is that? Well, first of all, these are composite doors, and second of all, these are on a different cable network, so I cannot select them. Hydraulic pipe bender.
Hydration critical.
Logic reader. Glass door. Now the glass door is selected. What do I control off the glass door? I want to control the open value. So this logic writer is now completely set up. The logic reader also, it reads from the, not from the glass door, it reads from the gas sensor. Don't confuse the tooltip with the, you know. And it reads the temperature. And this one reads the logic, wait, what? The compare unit should read from the logic reader, which it does. And the other thing is not yet connected, that would be this connector. And, you know, I can connect all these cables together, then I will just have more things to choose here. This is not necessarily bad, not necessarily good, it's just, you know, a matter of choice. And will allow you also more freedom when it comes to cable networks, dealing with cable networks. This seems like meaningful placement. No, actually not. This. Okay, now I want to set the right value here. The thing is, the value that I'm getting from a gas sensor is in Kelvin.
Power critical.
In Kelvin. I could, of course, just go and convert that. I could add a math unit here and subtract 273.15, so I would need a memory chip that has the value 273.15, and the math unit would then change that value, and then the changed value is piped into the compare unit, and then I have my memory unit here, which I set to, like, I don't know, 25 degrees. But that's quite a lot of overhead, right? So now we have to work in Kelvin. So you see, the game makes it hard on you and complex, but not complicated in my opinion, because it's just the right level of complexity that it is not complicated. Then again, I've been playing this for such a long time, but I think they have really found a good... I mean, it's like there are waves and they settle into a flat pond. And once it has settled to a flat pond, there's no mountain of waves left somewhere out of place. It is really behaving like water. That's how I look at the balancing of this game. There's nothing out of place. It's also all in the right level of, relatively speaking. So 273.15 is the value of 0 degrees. 293.15 would then be 20 degrees Celsius. So let's do this. 270, no. 290. Oops, no. I have to click on this without holding the modifier key. 293.15. Why not? Come on, let's go there. Oh, that doesn't work. Okay, that's not done. 293, that would be 20 degrees. Which is a bit cold, I think. Let's make it a bit warmer. That would be 22 degrees, actually 21 something. 297. 297 is fine. Or, you know, let's set it to 300. 300, because that's easy to memorize for you. So now that we have this value and we have it connected, we can now select this. Now the logic memory is connected, and this is it. This is our cooling system. This chip doesn't need power. So this door will be automatically opened. Did I forget something? Right, something very important. The logic chips, they don't repeat their write activity. So if the logic writer for whatever reason needs to write the value 0, then it will do that and then it will be done. And then eventually if the value 1 or something else needs to be written, it will write that value. But as long as the value doesn't change, it will not write anything. If, however, I would use the program, where I have a main loop where it just repeats and repeats and repeats, if I would use programming, this value would now be overwritten. So I will just, I don't know what I will do to trigger this guy again. How can I refresh this logic here? This clickety-click that you're hearing is measuring the room temperature. We have 128 Kelvin in here. Yeah, I would somehow have to change the logic value that goes in here. Maybe I can change the compare unit. Oh, equals. I've chosen equals. That's dumb anyway. Let's say greater. Okay, greater is what I need. If the temperature is greater than 300 Kelvin, then open will be 1. So let's choose less then. Why did I not close the door? I have done something wrong somewhere. The door is definitely cabled up. That's the first thing you should check. Usually you just forgot a cable somewhere. For example, arc furnace automation. Power is connected, yeah, but is logic also connected? It's not, so that doesn't work. Why does this not work now with the door? Why is this guy writing a value of 1? Why is the compare unit producing a value of 1? I'm saying greater. So is the gas temperature here greater than 300? No, it's not, obviously. I guess I just confused my wires in my head. I have to use less than here. Yeah, see, it just triggered. And now it's not changing anything because the value that would then arrive here on this side is the same, and so this guy doesn't feel inclined to rewrite. So that's one of the things to keep in mind. Also, I am not sure that if you reload your game, your logic chips are all instantiated in the right order and with the right value. So, I mean, if you want to be safe, you use programming. These chips are kind of a crutch, really. So now that we have theoretically our station cooling, gas sensor value. What? I cannot see what value this is set to? This is dumb, man. If the gas sensor value is greater than 300, a 1 will be produced and so the door will be open. Let me just take a screen here of this so I bring this up in the forum. Okay. Now we can finally start furnacing. The room is very cold and so we can just take... Oh god damn it, I still don't have any oxide. This is getting old, isn't it? But, you know. Oh, the storm. I took too many days. Well, our batteries will definitely be full now. Look at that. 44, 45, 46. What's coming in now is 2,400 watts. So in other words, if I placed... let's look at this. The upright wind turbines. They produce 800 watts during a storm. And otherwise they produce up to 200 watts during normal wind situations. There's more wind turbines in this game. There's the... There's the turbine generator. This one is not moved by wind, I think, but it's definitely moved by gases that move in your room. The upright wind turbines, however, they are not moved by wind that you create yourself. I think if you stack up enough of these in a corridor, you can even generate electricity, so that's a bit not so nice. So then we have the wind turbine, which looks like this. It's a really tall dude. You can't see that here how tall it really is and how much space it needs. And it produces 10,000 watts during storms, but only up to 500 outside of storms. So this tells you that it's a strategic choice whether to place these, which are also pretty hard to come by because you need some advanced materials for this. Yeah, electrum and steel. Okay. It's at least not as easy to print as the upright wind turbines. Because, I mean, they need more space when you place them, and they are harder to print. And so the advantage really lies in that during a storm they produce 10,000 watts instead of only 800 watts. So you want to have a lot of batteries there that you can charge during a storm, and then you live off mostly the storm electricity during the 5, 7 or whatever days between storms. And the storm, by the way, only comes after 7 or more days, so you have some time in the beginning. But as you can see down here, day 8, yeah, it's the time for the storm. If you now had the station battery, we would delightfully be able to fill that entirely just with these wind turbines. Okay, but I need to go out and get some oxide, so let's finally use... Where do I have the tracker chip? There's the tracker. And where is the... Oh, I need to put a fresh battery in this one. By the way, this is a good opportunity to charge up the batteries. Later I will of course have big batteries in there. Is any of these still on? No, right? These are constantly using 10, 20, 30 watts overall. While the IC housing, where the programmed chip only uses 50 watts, so that's more energy efficient, since you can put more programs on there and you're more free. You can just click on the computer and change a value, while here you use a screwdriver, and it's really much more powerful. Okay, battery is charged. Look, here's the thing, and it doesn't show you the direction. Why? You need to use the mouse wheel. And then you can look at where other people are. You can select individual people with which you're multiplaying, or you can select multiple beacons, or even yourself. And funny enough, if I pick up the beacon now, in my right hand... Oh. It was... I thought it would now show me 0.4, which I had measured at some point, so you would see how wide the body is. But I guess they changed that. Alright. Oh right, of course, that was stupid. I need to look at the beacon. Beacon, pick up, and 40 centimeters.
Power low.
That's how wide away it is. How far away. Hey look, we can also play in third person, but you can't really play like this. You can only walk around. but it's cool how you can see everything. I mean, the entire character is there. You can see the tablet with its display, you can see the beacon. One thing that's really sorely missing from the game is that you can place a tablet on the wall so that you can see all those atmospheric data of the room. But what you can do is you can place a table and place a tablet holder, and then you can do that. Then you have that information. But the wall holder is still missing. I keep bringing that up. The developers haven't yet seen that, I guess, because I think it's really something that absolutely belongs. I mean, how can there be any questions? Oh, I didn't charge this battery. Because then you have it like in every space film and show where you have these information on the wall, and in this game it makes sense. Here you get real values, real pressure, real state of the situation, temperature, great stuff. You can even put that in the sky from here somewhere, right? Yeah. Pop. So let's find some oxide. On an exciting adventure. Where's the station? Can anyone tell? No, right? Good thing we have this. So I can now walk in an arbitrary direction for an arbitrary amount of time. It's not a problem as long as I can get back in time depending on my resources, because I cannot lose my way. And of course at some point the battery is down. Also keep in mind that the station is currently still very cold, so the battery is also discharged by that somewhat. Mining during a storm is so completely bonkers. Maybe I should just jump and let the storm carry me with it to make more distance. And when the storm is over, of course, I have to walk in the opposite direction, but then the storm is not resisting me. Hopefully it doesn't last too long, huh? Okay, that was very, very far. Oxide, which you find easily, it's pretty abundant. The storm will of course blow anything that falls to the ground away. And if your lander would still be here, and we had dismantled it already, then it would also be blown away. But you can find it, if you're lucky, in the direction where the storm has blown. But it will also be damaged by the storm, and once it's damaged in full, then everything that was on the lander will be gone. Your crates will also be blown about, but I think they will not be damaged. The landing pod will also be blown around, and solar panels will get damaged by storms, but that's why we have so many variations of the solar panels. They are hardened solar panels, which need quite some overhead to build. In my opinion, you don't need those. Just make a glass box around them, they'll be fine. Oh, a cave. There's only a small one, there's nothing exciting here. Yep, and they get damaged in storms, and then you have to repair them with duct tape. Something the game stupidly doesn't yet have. If I dismantle the solar panel when it's heavily damaged, I will get the item again from which I can build the solar panel. And items can also get damaged by fire and such. But the item that I get will be at 100% quality. Why have they not done this as a default thing for every situation? When you dismantle something that's damaged, then you get the damaged item. They don't have that for whatever reason. I don't understand why. It seems like a simple thing to implement. And then if you build from a damaged item, you will get a fully functional solar panel instead of a damaged solar panel. That, in the same way, would be, in my opinion, easy to implement. But they haven't done that. Okay. I hope they do that. And I hope they also implement CO2 toxicity, because the game is super fun, but I want it more realistic, and it is a very primary thing that everybody knows about, basically, that too much CO2 is bad for your breathing. Supposedly also bad for the greenhouse, you know? for the planet, as in it's getting too hot. The mechanism is as follows: light, visible light from the sun. We get visible light, and we can also get light in different radio frequencies. I mean, radios. Okay, when you turn on your radio and get a radio transmission, that is light. What you're getting there is just not visible light. It's electromagnetic radiation. Just the same stuff. Just like gamma rays from space or X-rays from the doctor, they are light. Just like radio waves. Radio waves have a lower frequency than visible light, and oh, there's the station. And I want some more while we're out here. And X-rays have a higher frequency than visible light, and gamma rays have an even higher frequency. And since light is quantized, you can only have this and this much minimum of light. If you have the minimum possible amount of light when it is gamma rays, then it is implicitly still more energetic than when you have the minimum amount of radio waves. Anyway, so light in all frequencies is coming down from the sun to Earth, and whenever something is hit mechanically, for example, if I punch the wall, or if something is pressed against the wall, or something along those lines, then the molecules and atoms in the material will be swinging around in their force grid where they are in that place, and this will then make the other ones also swing around, if not even lastingly displaced, depending on impact and so forth. And this chaotic motion that emerges there, that is heat. That's what heat is. And the problem with heat is that it's chaotic. If it would just be moving in one direction, then it would be momentum. I mean, that's when you throw the brake, right? But when you have the chaotic motion, which you easily have, because I mean, one atom swings in one direction, the next atom swings in a slightly different direction, pushed by the first atom. It quickly dissolves into just pure chaos. That's so-called Brownian motion, and that's what heat is. And so when the light rays of whatever frequency hit the ground, they will excite those molecules and atoms, and so then we will have this chaotic motion, and this chaotic motion in turn excretes also light, but of a different frequency, and the primary frequency that is excreted there is infrared radiation. In other words, the ground, all physical, all hard material that we have on the Earth, is a converter from different frequencies of light to infrared radiation. And now is the problem with the greenhouse effect, with the greenhouse gases. CO2 is not transparent to infrared radiation, and so it is like a membrane. It lets in all the radiation from the sun, but all that stuff that has been converted to infrared, it will stay down here mostly. That is why more CO2 in the atmosphere implicitly means that we will have a hotter atmosphere. But I am not one of the climate well, let's just say I don't know where I stand on the issue of human-made climate change, because I don't know how much CO2 would really be a problem and how much and so forth and so forth. I don't have a position on that. But the mechanism I explained and understand of what the CO2 is doing there. And now you know it too, and that's good. Always good to know some stuff. And particularly physics. I mean, learning about politics and so is often not so useful, because ultimately it comes down to arbitrary decision by humans, and humans are stupid, you know, so why would you learn too much about that? So I have some oxide now. Do I have enough oxide? Yes, I have enough oxide. Do I have enough volatiles? Also, we can go smelt. We can go smelting. Would be cool if I would find some more nickel on the way, because then I get 2 full stacks of... Oh no, again? Lead? How is the planet tossing that much lead at me? Unbelievable. It's a moon, not a planet. Like the moon, this moon is a moon. So when you run down mountains, you might at some point get too fast. This was not too fast, but you don't want your suit to get damaged. So you should catch yourself with shift. With J. See, that's why I move that to shift. You often have emergency needs, and then you just want to push that button and be safe. I have more safety in my little finger than you have in your index finger, basically. Alrighty. Time to furnace. And this can be turned off. And how empty is that once full battery? 84%. So yeah, we're fine. So the room is very cold. This means that I can now put into my hands, let me just swap this for later, the ice that I want to put in there. And you know that the fuel gas that we have to put in there should ideally be 2 parts volatiles and 1 part oxide. I'm a bit confused, where is that? Up there, oh, god damn it. Yeah, things can get a bit chaotic. But now that I'm holding these in my hands, if the room is hot, it will melt, and then it will melt into the room. That's not too bad for the oxide, though. I mean, I just ran out and got some. Therefore, I don't want this to melt in my hand. I don't want to risk that. And the volatiles, I definitely don't want that in my room atmosphere, and therefore I need to use a trick. I need to get that stuff from my hands directly into the furnace. And can that be done? Yeah, it can be done. If I put something...
Temperature low. Temperature critical.
Battery. That's usually the battery.
Temperature low.
Whew. If I have my hands full, and if I split something, then that will not fall into my hands, but it will fall into the world. And this is a very, very grabby thing. It will instantly grab that. So now we have volatiles in there. Now I have to click this to melt what is in the input slot. Then oxide. And I melt that again. And now it's already burning. And you can see that there's gas moving. This is not heat moving, this is gas moving. The gas here is heating up. The pressure is increasing. We have minus 134, let's see, the temperature is increasing. Okay, I want more in there. This guy should really be going. Also, I want 2 volatiles in there per 1 oxide. So 1, 2, 3. 1, 2, 3. And as I do this guy will start to rumble. There's no content in there because the gases don't count. But here we can see we have a pressure of 6 megapascals already. It keeps rising because the burning process is still going on. I can show you that. We can see here that we have some volatiles in there and some oxide. It's basically half and half, oxygen. And so, yeah, that's a good mixture relationship. 2 volatiles are being removed for 1 oxygen. Wait, I have to get rid of an annoying reminder thing here. See, so that figures. This will not be a perfect mixture, but it's close enough. For normal purposes, it's close enough. So now let's swap that back. I don't want to accidentally toss my tablet in there because then it will just vanish into nothing. What I want to do now is I want to put in the ingredients for steel. Like I already established, we need 3 parts iron, and we need 1 part carbon dioxide. Wait, what? Hydrocarbon. Maybe you saw that it was telling us that we would get an iron ingot out of there, and this is because this thing can just be used like the arc furnace, except it's much faster. But now that the mixture in there is not pure, we don't get any recipe that is being shown there as the potential outcome. But now we get one. We see we will produce steel now, and the button has turned green. Let's pause the game. Let's look at the ingots again. So now we're producing with the furnace some of these guys. I also want to make electrum and solder and invar and constantan. All of them. Steel we will use primarily for the station battery, which is important at the beginning. But turning on the furnaces makes sense also because it heats up the room. So what I need here is 3 parts iron and 1 part hydrocarbon. What I also need is 900 Kelvin or more, and when you point at the furnace it will tell you its temperature in Kelvin, so that's convenient. And you need a pressure of 1 megapascal or more, and you usually have that. The pressure in there is usually rather higher than the temperature. It's easier to have a high pressure in there than a high temperature. And this thing cannot get too hot, but it can get too high pressurized. Once the needle is here at 60 megapascals, you better are far away and have some reserves, because most of your station will be gone when this explosion has happened. Now I can open this valve here. I'm not going to do this now because I don't want to lose anything. To get rid of the gas in there, will slowly escape, very slowly. So the advanced furnace is more fun, which has pumps built into the melting chamber, which can pump into the chamber and out of the chamber. So let's get that steel. 200 grams of steel. Now I want to make... well, good question. What's the next thing I want to make? Electrum? How hot is the furnace? Well, the pressure in there is much too high for electrum. Okay, let me just toss in some things that need a high temperature. These 900 Kelvin, which you can also see if you look at the simple ingot, of course. And this would have taken quite some time and electricity to smelt, but now it just takes heat. So this is basically atmospherics, thermodynamics at play here. And by tossing this in, the ingots, the materials, they unleash their gases. That is why the furnace will cool down, because the more gases we have in there, the more stuff needs to, the more the thermal energy is spread out. That is why the furnace has now gone pretty cold already. And if I keep doing this, let's see, 800 should still be enough for copper, I think. Yep. Then we get that copper smelted too. By the way, this is now degassed. There's no way to tell, but it is. This no longer has any gases, which they are now in there. Which gases? You can look that up in the Stationpedia. What you smelt in here and what you smelt in your arc furnace can be a strategic choice. Normally I just use the arc furnace, period, because firing up these guys is so much overhead and so many things to consider, because we're not done yet. This thing will eventually cool down, and if the room would be too cold, I mean, if I place this thing out there in the planet atmosphere, or on the moon for example, the material in here will eventually cool down to minus temperatures, to negative temperatures, and then for example the CO2 in there would liquefy. Not a problem for this sturdy device, but here the pipe would have liquid, and then the pipe would eventually burst. Then everything would escape. Do I want that? Maybe not, and then I don't want the pipe to burst. Also, what if we have connected this pipe through the window into our station, into a filtration unit, which we use to extract the plentiful CO2 from this, which we could use for the plants, right? What if we have this? What if that pipe bursts that goes through the window, which I have had happening, and then you will have all the pollutant in there also in your station. Yep, that's bad, man. So you need to be in control of this device. So what you toss in here and what instead you toss in your arc furnace can be a strategic choice. Why? Because iron has a melting point of, I believe, 800 Kelvin. But gold has a relatively low melting point, and so has copper. So if I want to quickly smelt some copper, which is very slow to smelt in the arc furnace in comparison, then I can better use this furnace here. I guess this will be too cold. Oh, still? Oh, cool. Gold also is very slowly smelted. And it has also a very low melting point. So that makes sense. If your furnace here gets really much too cold, it can be that things even get stuck on the input slot. If its temperature goes below, I don't know, 100 degrees Celsius, or was it 300 degrees Celsius? Yeah, I believe it was 300 degrees Celsius. That it would no longer melt stuff into its chamber. And then you're kind of out of luck. but you can use this input slot here to connect, for example, your gas canister via a kit pipe utility, which has an inline tank which increases a pipe network's volume. That is sometimes very useful. It is not superfluous, not just decorative, it's cool and useful. But also it has the tank storage. And then you could use, this also exists for the liquid variant as a second kit. Then you can just connect your, and I know I sound very German. Get in the chopper! I will eventually get rid of that, hopefully. Anyway, you can connect your fuel gas here, and then if that thing is no longer running, then you can just click here and the fuel gas will then ignite, and then you get more heat and this will melt free. And if you have no more fuel gas, then you can just dunk your tank in here, because that is your fuel gas reserve. And so forth. It's basically a real-time action survival engineering puzzle game. That's kind of a good summary. Maybe I should call the video that. Anyway, so how cold is it now? 650 Kelvin. Now I want to make solder, which I normally make together with electrum, because that works so nicely hand in hand. But since the furnace is already this cold, it is reasonable, because to make solder you need equal parts iron and lead, and you need a furnace that has a temperature of 550 Kelvin or less. And so, since I toss this in and it produces more gas here in the furnace, more pressure, the furnace cools down by me tossing this in. So I'm making use of this. And look at that! We can open the helmet. We have now plus degrees in here, positive degrees. Yeah, we have beat the code of Europa. Just by one smelting process here. And that is why I put this thing indoors. Yep. To have this thing in its own separate room and then only open that room every once in a while with a manual hatch is also a meaningful way to heat your room. I have done that. I showed you that earlier on my Europa base. It doesn't produce anything yet because it's still too hot. Let's look at solder. We can see here it can be made with the furnace, 350 to 550 Kelvin and 1 megapascal or more. Well, the pressure we definitely have, 17 megapascals, dude. And but it's not cold enough. So one way we can make that colder is by tossing in ice. We can even toss in volatiles, which is the stuff that burns, because as long as it doesn't find any oxygen to burn with, it doesn't matter. But normally I would not do that. I would just toss in some goddammit. For example, I would toss in nitrous oxide. I would toss in nitrice. That's the kind of greenish ice that you can also find and that I never mind. Never mind because I never need it. And so if I accidentally mine some of that, I can just toss it in. So is there still some oxygen in there? Yes. So I shouldn't toss a volatile in there, else I would increase the heat instead of decreasing it. We can toss in some oxide, or we can just wait a little. Apparently that's meaningful. Oh. How about the room? Temperature 294. I have set 300 is the limit, so that would be 27 degrees Celsius. The plants are fine from 20 to 30 degrees, even from 10 to 40 degrees, but they will not grow that well. They will still be survivable, I guess, from 0 to 50 degrees, but I'm not sure about that. So I have to take some measures here. The room pressure is now 100 kilopascals. The reason is that the room has heated up a lot. So do we have any loose items here in the vicinity of the door? No, we don't. Good. Because that would be fatal. We would lose those. Hey, what's happening? We have 300... this is not working. 300? Compare. State 0. I don't understand. Why is this not working? It is writing to the glass door. That's the only glass door. That's a composite door. It is reading from the logic compare. It is writing the open value of the door. The value that it writes is 0. What logic situation do we have? We have more than 300, and here we have 300. This is... Oh, it is set to less. Ah. Of course. Oh, I guess we just lost the fire extinguisher, which is now somewhere out there. And it automatically closed. Ha ha ha, okay. So, see, that's why... yeah, it has to balance that out. This guy is measuring the temperature. The air is wafting about. And then this happens again. I wonder if I can get that extinguisher again.
Temperature low.
Oh.
Temperature critical.
Of course.
Temperature low.
I don't need it, but... I guess it's gone. The game also cleans up things that are too far out of bounds, but I think this should not yet count as such. I bet it is somewhere here.
Power low.
Come on, you know you want to. Huh. Asshole. Ah, ha ha ha, just this moment. Okay, so our station cannot overheat, and we have beaten the cold. So, what about this then? Ah, look at that, solder. Temperature is below. Now we have 200 grams of solder here. So, let's make... Now I need to get rid of some of the gas in here, but then again, let's see. I wanted to make... well, first, let's increase the frame rate. Electrum. Not electrum. I meant Invar. Invar needs 18 to 20 megapascals and 1.2 to 1.5 Kelvin, kilokelvin, so very hot. That's the problem. We cannot really heat up our current furnace to that degree, because if I toss enough fuel to make that hot enough, the stuff in there will, I mean, not only will this add a lot of gas, but the gas in there will, by heating, also expand so much the furnace will just be too full and then it explodes. We don't want that. But I can make Constantan, I believe, which I always do together with Invar, so I'm not doing my normal thing here, because it needs arbitrary high pressure basically and 1000 Kelvin. So that's something we can now meaningfully do. What does it need? It needs copper and nickel to equal parts. Nickel, and more nickel. The thing is, I don't know which I need more, Invar or Constantan. I really don't remember. I just make both of them, and when I need more, I add more, you know. That's why I want to reserve one for one and the other for the other. And so let's just make it half-half, you know. What's happening? Oh, I could have used that. Stupid! 50, 15. 50, 15. So let's toss in the stuff that we need here. That's copper and nickel. First a little bit of nickel. And well, maybe I should first heat it up again, as it will get too cold and then we have this problem that I described. I don't want that. This thing will now kick into gear again, and therefore, in consequence, the door will open more often. So let's melt the rest. Copper. And then I need 15 more copper, which I should have somewhere. I think I actually have it on me. Wait, why am I splitting up the copper? That doesn't make sense. Okay, what do we have in here? 65 grams copper, 65 grams nickel, and the temperature is not hot enough. Okay. We need 1000. What do we need? 1000 Kelvin. How high is the pressure? It's getting iffy. It's getting iffy. Unleash that, I would say. Now it will slowly decrease. Oh yeah, I should print another waste tank so I can keep that CO2 around. See, now we have this problem down here. So I will just reload. Okay, problem solved. Maybe we should print a bunch of cables, huh? I mean, we have the resources. Here's the electronics printer. But I think I should print heavy cables, because I will soon print the station battery, and like I said, it takes an infinite load, and one of our power sources is that guy with 20 kilowatts output, so yeah. The heavy cables. And where do I need to put them? Between that guy and the battery? No, I need to put them on the entire cable network, because the simulation of Stationeers is not entirely realistic. They have to take some shortcuts here and there. God damn it, do I sound German? I'm beginning to notice this. Shortcuts! Helicopter! Anyway, yeah, I have to work on it. I mean, the thing is, to work on such a thing, you have to become aware of it. And, well, the first step has been made, I guess. Well, it will just burn out a random lower capacity cable on that network, if one exists, if the cable network is using high voltage anywhere. Basically, the cable network to you, it looks like a system of cables, but to the game, it is only... I mean, of course, it has physical locations, yes, but internally it's just a list of objects that are connected to each other. You know, the same goes here for the pipe networks. You can basically pipe gas from here to 5 kilometers away in an instant, because this thing is just considered to be a container. And if I have a long pipe with lots of gas in it and I deconstruct one of those, then the gas will not be pushed into the rest of them, though effectively that's the case. No, practically it's just you took one of the container away, so the container is now smaller. How many of these do I need then? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's say 24-ish. And then there's no more gold in there. Do I have gold? I do, not too much though. I do have some gold somewhere. Oh, there's more gold over here. 4 grams of gold. What am I doing? I need I want to make normal cables also. Should always have some cables in reserve. Also get in the chopper! I'm sorry about that. I've been born in this flesh. I have to alter it slowly. Maybe you see it only takes 0.5 copper. So if I empty this now, I will get 1 ingot of 67 copper. But if I empty this now, I will get an ingot of 66 copper, so 1/2 copper is lost. That's not much, but something to know. Alrighty, let's swap out the cables out there, so we are ready for the... By the way, where will I place that battery? It would have to be between what comes into the station and... I mean, batteries should be indoors since they suffer the cold. Weirdly though, the game is a bit stupid in its simulation in this regard still. If a battery is in a very cold room, it will suffer, the station battery will be discharged. But if it's a very cold atmosphere out there, it won't be discharged, and that's just ridiculous. So I could just place them out there here, because it seems like the ideal place to put them. But I'm not sure I want that. Yeah, it's a bit done goofed situation, huh? I didn't prepare for this. Where could I put those batteries? And then I would of course need more heavy cables. Not easy. Well, since there's not a problem I don't want to spend too much time on, because this is an explanation playthrough, I will just place them out here, where you basically should not place them if you want to play realistically. So let's make a station battery. Kit battery. Need more gold and need steel. Gold and steel, both over here. From the materials that we have here, we could even make 2, but I don't want to be too wasteful on the gold, as we would have to run out and mine again. Alright, so now let's make electrum. If the furnace is cold enough, is depressurized enough now, it's not. Look at that, it's still at 800k after all this time. Still hot enough to melt gold and copper. God damn it. Yeah, that's for the electrum, that's for solder, which I already made, lots of. That is for steel. Oh god damn it, I only made 1 steel. Wait. I want to make more steel. Hello? The chutes that I talked about, these material pipes, you can also use them here to build an input stack, and then you just toss stuff in and don't bother with the time that the furnace takes to really swallow that. So we have to get that to 900k again. We have that at that temperature, and now I need to... You know what? I'm gonna try... Maybe enough gas has already been lost. 24 megapascals. No. If I want to make Invar, I need to empty this thing out. I mean, if I increase the temperature now to 1500, I would have way too much pressure. I mean, if I now manage to cool it down by the lever being open, I mean depressurize it, enough to like 17 or so, this would be good. From 18 to 20 is the range that I need now. But the temperature would also decrease, and maybe I can then raise the temperature again, but this would also increase the pressure. This will be a back and forth that will never get me to where I need to go. Oh, the station battery is done. Did I make steel? I did. So I can now... I can now make... What's its face? Steel sheets. I need steel sheets, 2 of them to make the battery. Good thing this automatism of the door, huh? That would have been annoying to keep balanced. But now I can just walk around, la la la, helmet open, no problem. Okay, I've basically never topped up the battery with this guy. Heavy cables. Okay, let's go out and fix that. The lever is open of the furnace. If this isn't the coolest game you ever played, then please tell me about it in the comments. Tell me about the games that you think are on par with this one or better. Because yes, I'm eager to learn that. Okay, turn on the battery. Now it's starting to blink because it's taking in electricity, and even with the slightest bit it will show that here.
Power critical.
And yeah, but the coal burner is now still going directly into the station, not into the battery. You might think that's a good thing, then we don't need heavy cables on this side, but this is still wasteful. This guy puts out 20 kilowatts. Don't we want all of those in the battery? Yes, we do. So I need to, well, maybe I just place the coal burner in a different location. For example, maybe here instead of a wind turbine. Nah, that's not fine. That's not nice. Change of channel. Uh-oh.
Temperature low. Temperature critical. Temperature low.
God damn it, this should have caused some lung damage. You can see up here the waste damaged warning, the waste tank warning, because we are at over 3 megapascals. So let's see. Wait, what's happening? Oh right, the battery is of course instantly discharged because this guy is very hungry. But you know what? We can do this, and then we get tons of electricity. Very soon this should even show the solid state, because it's full more than half. Oh, okay, I don't know exactly how the step from here to here works. Tons of electricity. That's plenty. And if we still get more from the wind turbines, then we consume, then this thing will soon be full. Okay, so much for the station battery. That will keep us plentifully supplied. Yeah, then I wanted to print other things. Let's print the computer while we're at it. So we can see what it would be like to do the thing we already did with the cooling in the form of program. Do I not have any smelted iron? Despicable. Huh. Well, I guess I have to go out again. Oh, great change of channel. The player I'm using, listening to Soma FM, which have many channels, and they have a Windows player, Windows 10 player, so one of these crappy apps. I'm not saying that their app is crap, I just find the entire concept of the Windows 10 apps crappy. But I think the goal there was to also use them without any change on the Windows phone. Anyway, what you're seeing on screen with the song title and such is just put there by the recording software that I'm using, Op Studio. I'm just grabbing that off the screen of the player and rotating it, shifting around. That's what it is. Okay, how are we looking on this front? Still very high pressure, but I think it's low enough now that I can start making Invar. One thing, what about the electronics printer mod? See, when you upgrade the manufactories, you need to print mods for them, and then you screw them on there and done. And you print them with the electronics printer mod. But first you have to mod the electronics printer. For that, you need to print the electronics printer mod, which you can do with the standard electronics printer. Constantin. I think that's the one I already made. So we should be able to print that already. That is very cool. Constantin. Solder. Helm open. Where is the electrum? And I do need to clean up, I know that. I knew I had electrum, please don't tell me that that's gone with the wind, which is a possibility. I mean, every time the door opens there's some wind stream here, and it might have actually rolled out there. Or do I have the electrum in one of the devices, possibly? No. No. Where's the fucking electrum? Did I actually lose that? No, I did not make any yet. I was just imagining that. Okay, not a problem then. Let's make Invar then. And here I can already print the motherboard editor, because the computer... because the computer too has its different motherboards, just like the console and just like the tablet. So IC editor motherboard is what I need to edit the IC. For the IC itself, I believe I need Electrum. Yep, I don't have that yet. Let's make it. But first I make Invar, which is tricky to make. So first I will load myself with all the things I need. And Invar is a combination of nickel and iron, actually. So I need 15 iron, else I will not have the right mixture. And when I don't have the right mixture, I can just toss all of that out of the centrifuge, out of the furnace. Not a problem. But then, of course, I need to... well, I can just fix the mixture later, you know? Can put it back in the furnace. Do I not have iron somewhere? There, I have iron. Yeah, for this stuff. I need 15 iron. I have 50 iron here, that's already smelted. Well, maybe that's time for me to introduce the stacker. Okay, we need 10 iron for that. And some copper. Yeah. Where do I place this? Here I want to build another manufactory later, the tool manufactory, which by the way I could start printing already. If I had the materials, which I do have, okay. And the stacker, where does that one go? Where would I put the security printer? Maybe here on the wall to the outside. So I would have room here for the stacker. Let's put it here. I mean, this looks like a tangled mess, but once I have the solution via programming, I will of course no longer have the chips here. So this mess will go away. So I wanted to show you, here we have the stacker, you just saw that. Then we have the stacker in an inverted form. Inverted means the direction where it shoves stuff. Of course you can just rotate that, but then the components, the controls will be on the other side. And then we have the unloader. When you toss, for example, your backpack in there, it will toss out everything that is in your backpack and then your backpack. That can be useful. Uh-oh. The printing process was aborted. Well, good thing that you see that now. What can happen? To manufacturing. See, the entire electricity wasted, but it's not a problem because we have tons of that. We are fine now. Which means that soon I should put up some lights, actually. Really no iron here? That's ridiculous. Here's some iron. And now I want 15 of this. So I go here to my stacker, I select on the wheel here, 15. And then I quickly push the lever, else it will toss out 15, 15, 15, 15. I need 15 only once. Thank you. Oh, that's where the fire extinguisher went. It was sucked from the door past this place, and this guy was so greedy that he saved the fire extinguisher from getting lost. Pretty cool. I have to consider that in the future as a feature. In the station, I mean. Okay, time to do the thing. We want to make Invar. Is the lever closed? It is closed. Maybe I should save every once in a while. The game has autosave, and it even has a save game rotation. So when you load the game, you will not just be greeted with a list of the save games that you have, but also with a list of the save games of that save game. I don't know how long that list grows. And whenever I do manual save, like I just did, by pressing F5, alternatively, just go here. Oh, by the way, and if you exit, and then it asks you, hey, do you want to save? That doesn't work, and they haven't fixed that to this day. I don't know why. It's weird. As you can tell, we have no burning process going on in there. Now we do. Whoa, jump start. Now let's put in the ingredients for 15 iron. See, it's about the
Temperature high.
what's its face? Yeah, this corner is pretty hot. It's about the reagent. It is not about the iron ingot or the iron ore. It's about the reagent therein. So, pressure 22 megapascals. Yeah, fine. We're pretty fine. Let's open this now. This will reduce the pressure. So, let's not get this out of control. Invar. Invar allows 1.2 to 1.5, so it has to cool down also. 18 to 20 megapascals. Maybe I should actually leave this closed, because it could happen that now the pressure decreases faster than the temperature. Let's just let this naturally descend. We have 65 in there. I just have to remember to go here. So we have two lights. Maybe I can actually add one. Where would I put this? First I need to establish some kind of cable network on the ceiling, because that's where I want the lights. Or on the walls? I'm not sure. Yeah, we have different lights here. This one, for example, even has a battery buffer and works kind of like the area power controller. So the battery charges if there's power, and the light is lit if it's turned on simultaneously. But if the light doesn't have power, but there's a battery in there, then the light will still be running. Round light, angled light that shines diagonally like a spot, small light, wall light. Then we have the LED, which you can even set the color of, but you can also set the colors of the others by using spray paint on them. But here you can change the color digitally, and you only have like 8 or so colors to choose from. Then we have the wall light long, and the wall light long angled, and the wall light long wide, and the diode slide, and the wall light battery. We already had those, so the diode slide is very cool. It is not lighting up anything, it's only bright itself when you turn it on, but it shows a progress bar. You have a value in there, once again the value setting from 0 to 1, and you can use that as a progress bar. For example, to show the average ratio is another value that exists, ratio of your station batteries. This ratio is maybe 0.1, the next battery might be full, so that would be the ratio 1. The average of that would then be 0.55, I think. And this you give as the setting to this guy, and then you see, aha, my overall station battery reserves are 55%. And then we have the wall light long wide, which I prefer to use. It is not brighter than the others, and it doesn't use more or less electricity than the others. The LED uses 50 watts, 25 watts. The diode slide, I don't know what it uses, but all lights otherwise use 50 watts. And so why do I use this one? Because it doesn't just light up the room, it is also entirely white, like this. So it gives the same amount of light than a smaller lamp, I think, But this feels brighter also because it has this large white surface. Feels better. That looks pretty cool, doesn't it? Very moody. Now we need more of these. Another reminder. Okay, what's the next step? One more light, I would say. We have to, after all. Maybe over at the opposite side. Maybe let's go good old symmetry. When you don't know what to do, you make it symmetric. You know, that's what God thought, I guess. Can already turn this on, but nothing will happen.
Deep. Cinematic. Space. Exosphere. On Soma FM.
Yeah, welcome to your own personal space station. Hey, wait, I can use this as trailer material at the beginning of the video. I don't know. Okay, welcome to your own personal space station, where everything is simulated. The pressure, the temperature, the gas matter state, and so forth, blah, blah, blah. How cold is it? What's the pressure? Pressure is too low, temperature is too low, so I done goofed. But it's not fatal. Oh, good thing that worked. And here we go, Invar. Thank you, Furnace. You're welcome. Okay, then we can now print everything that we want. Oh, right, I forgot the, that stuff. Well, that's a bit annoying, because guess what? This needs pretty low pressure. So we have to release that again. And you can also cool this down by tossing in ice, you know. But the problem now is, first of all, it would have been a ton of ice, would have to be a ton of ice, and second of all, the problem now is pressure. Too much pressure. The temperature, let's see, electron. So we can print everything that we really need right now. 600K and a pressure not exceeding 2.4 megapascals. The pressure really is the key here, because the 600 Kelvin, we will easily have that. Would be cool if I could program something now to measure, wait, where is the outlet? Here, to measure the state of the furnace, and then that a light goes on and tells me, hey, wait a minute, I've never ever automated this furnace. Let me see, furnace. Can I also automatically open it? As in, I'm waiting for that pressure and then you toss it out? Okay, we have a lot of stuff here, all the measured values, total moles and so forth. A name, We can open it, read write, okay. Mode, I don't know what that does. Great, mode 0, mode 1. Now I know more. Pressure, temperature, activate. Yeah, that's when you push that button. I wonder if whether the button is green can also be read out. That would be cool. I guess not. Well, let's just print the upgrade then. Upgrade the machines here. Electronics printer more. Ah, we need electron for that too, damn it. Okay, then I will put up the tool printer. Definitely need to clean up this mess. it's mild by now. Okay. Okay, next step. This guy should have these things, and so over there I could place some things that I will probably not need. This also not. Network analyzer, I don't know. This definitely not. This probably at some point. Airlock definitely not. The flags, which you can put out there in the landscape. Also definitely not. Probably. Building materials. This goes over yonder. And I make it a habit to only put full stacks into the lockers, normally. God damn it, what's with music today? Oh, it just changed? Or didn't it? It didn't. So, some stuff goes into the locker. Construction materials. Stuff we can eat. Maybe... oh, well, not the tables. No, not yet. How are we looking? Aha. Okay, 600 Kelvin was the goal and 2.4 megapascals was the goal. Must not fall below 600 K, and the pressure must not exceed 2.4 mega. I think we will manage. Already full. Need another locker. Hey, wait, we have to solve the temperature problem, have we not? So, what's the temperature of my gas? 14. Very good. Okay, now we can stock up
Airtime critical.
on oxygen. By the way, when you're running around at your station and your helmet is open, the suit will still use a bit of your oxygen here, depending on circumstances. So if you really want to make sure that nothing's used, you have to turn off your things. And then when you leave your station and then, oh, I have to close the helmet, then you're out there and then soon you will begin to suffocate and then you will be panicking. Check these guys. They all need to show the value off. Or maybe you should just toggle them and then think, hey, they need to be on. Yeah, this on and this one is already correct. That kind of thinking. So, are we looking? Uh-oh, fuck. That is too low. Why does it suddenly descend into nothing at that speed? Okay, we have to stock up a bit. And there it is. Electrum. Alright. So, let's make the tool printer mod. Oh no, this takes a long time. Let's first make the IC10, which also takes some time, but then we can start doing stuff. And while we're at it, I should also print an atmospherics device, because those are major, and I need to explain them. Gold and copper. And they also have a socket
Temperature low.
for your ship.
Temperature
Man,
critical.
I'm an astronaut and my computer was just trying to kill me. Yeah. Hydroponic supplies. Yeah, we will get to the plant stuff soon enough, I hope. How long is this video, by the way? 2 hours, and then the other bit that I had to cut off. 4-ish hours. The atmospherics kit. Let's take a look. Okay, the first thing you always get in your hands when you start building this guy is the air conditioner. Wait, I have to move something here. And the music is shit again. I am not a lucky man. So here we have the air conditioner. Up there you can already see. Oh, you can't point with the mouse. Okay, where my finger is pointing right now, that's where there's a chip slot, and there are 2 screws next to it. You will also see the chip housing soon. Wait, do we have that already? Yes, okay, let's make the motor then. Or do I... Yeah, I should make the housing, of course. Where you can place a chip if you so wish, and then you can program that chip, and that chip can control that device. But you can control any device from anywhere, basically. It's just very simple to control the device where the chip is housed in. Also, this guy is relatively cheap to print in comparison to the chip housing. Let's see, the housing. What does it take to print that? 10 copper, 4 steel, 2 solder. And the atmospherics unit? $10 iron, 5 gold, 20 copper. So that's not necessarily cheaper, but we don't need steel and we don't need electrum for that. Yet we can place a chip in this dude. This is the AC. On the right side you would pipe in your room's air. On the left side you would pipe it out again. So basically you could just place a passive vent on the right side and on the left side. But the arrow that is pointing
Hydration critical.
towards us, that is not where gas will go. That is only where thermal energy exchange will take place. So you would put some gas there in a closed pipe, and if you want to cool your room, the heat would be put into that pipe. So that pipe itself will then get hot. So you should maybe put that pipe on the outside where it can cool down, stuff like that, you know. If you want to make this thing more efficient, you would pump in the gas from the right side with an active vent, and then you would of course need an extra pipe, because the active vent is a device, this thing is a device, so you cannot place devices right next to each other. But the color while placing them would tell you that. Then we have the filtration unit, also one of the most used things really in the game, like the active vent. On the right side you pump in your, for example, room atmosphere. On the left side you would pump out, for example, only the oxygen, and you would put only 1 or maybe 2 if you wish oxygen filters into the 2 slots. Up there you can also see we still have a chip slot, and the arrow that is pointing towards us at the bottom, that is the rest of the gas. Everything that's not oxygen comes out there then. Then we have the electrolyzer. You pump in some gas on the left side, and out comes you pump in some water on the left side. On the right side you get pure fuel gas, pure 2/3 volatiles and 1/3 oxygen. That's what comes out there then. And there's also the opposite device, which is the H2 combustor. You would pump in a fuel gas on the right side, and then the arrow that points towards us would be like 2000 degrees hot steam and some pollutant and such, so you would have to filter that and also cool it down, and then you would have water. And then finally we have the nitrolyzer, which it can be used to create nitrous oxide. You would put in, on the right side, you would put in nitrogen and oxygen, and out comes nitrous oxide. Yep, and I printed this guy now because it has a chip slot. Just wanted to show you that. But normally we would use this here, which you see is also a housing for a chip, and it's the only thing it does, but it also has this debug value that I talked about, that you can write to the guy's setting value, you know. Then you point there, you see that number, and it has 6 screws instead of 2. And what do you do with those screws? Well, it's the same as here, you will select the device. But you don't need to select the device to program it. There are other ways, 2 other ways in fact, and I will show you them. Now we need the mod. So where will I place that computer? Maybe here next to the light, that's cozy. You can build this computer. Or that one. They're the same. It's just the visuals that are different then. I might actually use this one, which is now in the wall, but let's ignore that. So the motherboard can be put in now or later, doesn't matter, and then I have to screw this thing with a screwdriver, and then we want to connect its power, but of course we also want to connect its logic, else it cannot control anything. By the way, aside from the computer, there's also a portable computer, the laptop. Isn't that then the better computer? Well, let's see. We need gold, copper, steel, electrum, solder to print it. For the computer, we only needed iron, gold, copper, very basic stuff. And also, the laptop has a chip slot here. There you can place the chip. So then you can export the program that you wrote onto the chip, and then it's on the chip. And then you have to take that chip and place it, for example, in an atmospherics unit. Does this one have a chip too? Yeah. Or you have to place it in a housing, and then it run the program. But if you want to change the program often, then it's more useful to just have the computer, because it can access that housing or this guy's chip slot and so forth directly with a drop-down menu. So it's more easy then. On the other side, sometimes you're confused which entry is in the drop-down menu just because you don't look at it. I mean, you loaded the game and then the entry it's selected might be a different one. Or you change something about the cabling or put up another atmospherics device, and then the selection will be a different one. And then you might actually lose track. You might lose your way, basically. Of course, if you're just attentive, then nothing bad will happen. Just saying that's a point to consider. But I prefer the computer because of its... I mean, if I want to do a tutorial like this one, I will have to change the program often, so that I can explain that to you better. And this would then be very unwieldy to use the laptop for that. The upside of the laptop, of course, is you can carry it anywhere you want. And if there's a chip running here somewhere under the wall, I mean, this wall, it can be... basically, this transparent thing can also be intransparent. And I showed that at the beginning, the different variants, you know? And I can place that on the floor.
Temperature low.
Motherfucker.
Temperature critical.
And this would then cover up the cables and would also cover up the chips. Okay, now we get our modded electronics printer. Booting. So let's make the tool printer mod, because that will be a game changer. First, let me complete the tool printer in the first place.
Temperature high.
Oh, I need more cables. I need 4. I will put up more lights eventually. By the way, how are we doing? Uh-huh. Oh, look at that. So we're living a bit large here. All the things we're doing, not a surprise. So I need to print some more upright wind turbines, I guess. Or toss some more coal in there. Or maybe some solar panels that we then control with a logic chip. Because doing that with these guys, possible, yes, but then you need, well, some more of these, and it's pretty annoying.
Temperature high.
Okay, so this is the tool manufactory. And I need more cables, I realize. I will print those soon with a real printer. And this guy can give us a tool belt for tools that is advanced once we have the modded version. Otherwise we can only print the basic one. And this one has room for 2 more tools and for 2 standard slots. That will be very much a game changer, because we are kind of at the threshold exactly with our tools here. And then I can manage things better. And we can also print the heavy mining drill, which will then make the hunt for ores much more convenient. So, what do you need for the tool that I want to make? Here you can see the colors that exist. There's all the colors. And that sound that you just heard is actually tool belt mark 2, iron constantan. Am I still doing something here? No. No, this is yeah, thank you, that's enough. A stacker would have been convenient here, huh? Invar, where's my constantan? It's in here, isn't it? Yep. Yeah, the sound you just heard is when something enters these slots but cannot be used. Solder, okay. Constant, okay. When I empty these, I'm trying to train myself to leave the lever open, not now, but when they're really empty, so that I know there's nothing in there. And then we need iron. Do we have some iron, please? Is this thing still hot enough? Nope. Nope, nope. Yeah, battery's pretty empty. How much coal is left? 40. Maybe I put in 50. So these 10 got us from nowhere to 2.5-ish, I guess. More wind turbines are definitely desired. If you really want to get the most out of the sky, you want to leave it on and just toss in the coal that you really want to burn. Because when I turn this off, it's off instantly, and whatever coal was currently in the burning process will be gone. But if you put in like 10 or so and let it run, and it will burn through all those 10 completely instead of wasting something. Hey, look at the filters. Where were we? Iron, of course. And the heavy mining drill, which needs yet again hard stuff, steel, electrum, invar, solder. That's really high level stuff. Damn it. What did I just say? Invar, that would be here. I mean, of course, it's not advanced alloys, it's just standard alloys, but I'm just saying. Steel, electrum, invar, solar, all of those are alloys. All of them. I want to make some large batteries, please. Because the tools, if all of them have large batteries, then I can swap each tool's battery with my main battery without having to swap them back or something. Also, then I have much more electricity that I'm carrying around with me. That is very desirable. Copper, steel. What is happening? Oh! Okay, I did right. The mining drill was swallowed by this guy, and I thought, I have to print the mining drill still. So what do I need? Copper and steel. More copper, please. And steel, yeah. The last stuff will remain. How many can we make? With this, 2. Maybe I should also make the large battery charger, which charges the battery with 500 instead of 400 watts. Of course, when I now make the large battery charger and put some large batteries in there, this battery will be sucked dry by that, obviously. I mean, the electricity has to come from somewhere. Oh, I need iron and gold for that. Okay, whatever. Next step. What is the next step? So the big mining drill, that one will be fun. Should charge up the battery, station battery a bit more. And I can show you how fast this guy is. Yeah, why not? That's fast, isn't it? Like butter. And that's how we will drill henceforth. And this guy, no longer needed. Yeah, I wanted to charge up the battery some more. How much do we have? 36. And I wanted to smelt some more. Do I have something on me? I don't.
Hunger, caution.
Unfortunate. Yeah, well, if your station atmosphere is ever polluted, there's the scrubber. The portable scrubber allows you to put some filters in. It even comes with some filters. And then you put the battery in and you run it. And then it will pump itself full of whatever you didn't want in your station. You can see there's now some pollutant in there. So I guess I had some pollutant in my station. Yeah, from welding, of course. It's just a little bit, you know. Doesn't matter much, and now it's decreasing because it's all going into the sky. But if you remember that phase change diagram of pollutant, you can build a scrubber for that stuff at least yourself. You just have to have an active vent on the floor somewhere, on the wall, doesn't matter, with which you pump into a pipe. This will increase the pressure of the pipe, and so eventually you will be at a pressure where the temperature of the pollutant, where the pollutant will turn liquid. And what you don't know yet, we have the kit drain, very important thing, because you can make the passive liquid inlet. So if you have liquid in the room, it can just flow into the sky, into a liquid pipe. The active liquid outlet, which needs power and can be turned on and off and has a logic connector also, which allows you to pump liquids from a pipe into the room, or into the world in either case. And there's a passive liquid drain, which is used for gas pipes. That's why it's yellow. If you slap that on a gas pipe and there's liquid in the pipe, it will come out here immediately. If there's lots of liquid buildup quickly, then this guy might not be able to keep up. Then you might have to put on multiple of these. But anyway, so if you have a pipe on the floor somewhere and an active vent that pumps into that pipe, and that pipe also reaches outside your station, and you plaster this thing outside the station on the pipe, then the liquid, the pollutant that will have liquefied in that pipe will bleed out of this station. But the problem is the pipe will eventually just be full. Of course, the active vent will pump in more gas until it reaches its maximum pressure. I have to talk about that pressure control stuff later, I guess. But then it will pump a little bit more and then it's full again as it bleeds out the pollutant, and then it can pump no more. But for that we have the pressure regulator. The liquid volume regulator is the same thing for the liquid side, and for the gas side we have the pressure regulator and the back pressure regulator. Let's look at the kit pressure regulator. Where is it? Here. It has 4 things. Let's first look at the back pressure regulator, which is the one we would need for this contraption. Uses 100 watts while on, and you can... Shut up! And you can define here with the wheel, which by the way you can also program or control with the labeler. Where is it? I should have the labeler on me actually. Here. You can just give this guy a name. 100 is your name. Haha. And now, yeah. The value has now been set to 100. This is giving this guy a name, and this is setting the value. The thing also works for the memory chip, I think. Rename and set value. And the same works then also for this guy. So here you can define what the pressure should be on the input side. And if I define then like 50 or 40 or 30 megapascals or whatever, then if that pressure is exceeded, the excessive pressure will come out here. And then I can just let that back into the room with a passive vent. And so there will be a constant flow of gas through that pipe. And so the pollutant will keep liquefying and bleeding out of the station until there's no pollutant left. And so there's one way you can scrub your station, if you don't have the scrubber. You can also abuse the scrubber by, for example, putting in an oxygen filter and using this on this oxygen world to just pump empty your airlock. But you know what? You can just put in no filter and then it will just take in any and all gas that it can get its hand on. But let's first use this game changer thing here. Now we have the advanced tool belt. Hey, wait, that was wrong. What? Where is my tool belt? Somehow I managed to put the tool belt away and I don't know where it is. Where's that simple tool belt? I don't know. Oh, right, it's just inside the new tool belt. Ha ha. Very funny. Could it be the room is getting relatively cold? I mean, the limiter here was 25 degrees or 27 even. The room is at 21 degrees. What's happening? Well, I guess that what's happening is that thermal energy is bleeding through the wall by this guy being placed on the wall, because this guy also exists in an insulated form. The same goes for the pipe, which is also inside the wall, and for that guy too. Do we have more thermal energy bleeding somewhere? Yeah, here of course. This is possibly the strongest one. Well, we can work on that, or we can add room heating later, or we can just rely on the furnace, which we will keep using throughout the gameplay again and again. Okay, what's the next step? This tool belt, I don't need it. So, normally I would put it in the shredder, but I really don't want that thing around anymore. Maybe it's time to deal with programming. Finally. So those who want to get to the hydroponics, or should I do the hydroponics first? Because programming is kind of optional for many players, and they, I don't want to program.
Power low.
But plants you definitely need. I think so, huh? Okay, let's do the hydroponics first. This video will probably not have chapters, YouTube chapters, because I'm so doing everything at the same time-ish, you know. Do we have a liquid? Do we have a water tank? Yes, we do. And here we have a portables connector. You already saw the electronics connector, or what's this called? The power connector. This one is very similar. No, I don't want to place it outside. And we have two of these. Why? Because we also have that guy with which we could fuel the advanced furnace, or the normal furnace actually, why not? So I put that back. Then we have some liquid pipes. Then we have the pipe utility liquid with the two inline tanks that I already showed you in the gas.
Hydration critical.
And the gas variant, and it also has the liquid bottle holder, which is probably why they put that in here. Then we have the grow light, which has special light just like the sun. Because your plants don't react to other lights that you have, to nothing. Then we have potato seeds here, wheat seeds, and soybean seeds. Soybean can be used to produce oil, which can be used to make cans of food.
Filter low.
Filter's still fine. Okay, now we put this thing here. There's a lot of water in there. Yeah, it's really hard to handle. You should try that yourself instead of pointing and laughing. So now this is open here, but these are effectively pipes, and so these are not open unless you put some pipes here. Here you can see something typical for liquid pipes. They are kind of designed like this, while gas pipes are just plain pipe connectors. Okay, now I want to put the drinking bottle filler on the wall. There are two variants of this, cosmetically different. This one has the water connector at the bottom. Now we need cables. The water bottle filler is now ready for action, and the liquid pipe is also filled with liquid. Here we have 79 liters of a capacity of 790 liters, and here we have 10 liters. The pipes have a certain capacity. You can look that up in the Stationpedia. The gas pipes have a different capacity, and the more pipes you connect together, the more capacity you have. And if you add an inline tank, then you will have even more capacity still on that same pipe network. Because if I put a pump here, for example, that would be a device. And devices separate pipe networks, and they separate cable networks. Okay, we have 2 empty bottles here. Let's listen to the best sound in the universe. I wanted to print upright wind turbines, if I have the resources for that. Do we have some extra gold, maybe? I think not. But with the advanced mining drill we can just go out and get some. Damn. Eisen. Wo ist denn wohl das Eisen hin? This makes iron-wise 4, gold-wise 3, copper-wise multiple. Oh, 3 is a limiting factor. Okay. So then I can add... I just want to make 2. Not to exceed our resource capacity. This I will need to weld these boxes down out there. Let's make some iron sheets. Once you have reached steel, you should pretty much change to steel boxes and steel sheets to weld them, because that is much more efficient. So you're wasting much fewer materials, much mining time basically, but it's steel, so you have to make that still. Okay, that was the water here. Oh, that was wrong. Now I want to make the drinking fountain, which is just another way to get something into you, you know? Some water. Silicon. Oh, do we have some melted silicon so far? I think so, yep. We will certainly need silicon for glass and such a lot in here. So I already did that. And how do you use the drinking fountain? Super easy. Slap it on the wall, connect the water pipe, connect the electricity, and push the button. So I want to print a few cable analyzers. How many cable networks do we have? The big one, heavy. This one? Oh, like this can actually be turned off. This is wasting 50 watts every moment. And this one, this 3 cable networks of relevance. So let's print 3 cable analyzers. Cable analyzer, silicon. Okay, I have that. C is important. So let's join a pipe network. This will... Oh, I did this wrong. This will also constantly leak thermal energy out of the station, so it's not ideal the way I'm doing it here. Alrighty. Power connection. Oh. Is not powered? Oh, right. Yeah, I'm already full. Okay, but you just saw that there for a flash moment, huh? So as my drinking fountain, I will turn both of these off for the moment because I don't have too much electricity to waste. So, what does that look like then? Where will I place this is the first question I want to answer. Okay, I have an idea. Pretty wild. So what's coming in from the wind turbines currently is, you can see here, 130 watts, 150 watts, 170 watts. What we're consuming in here currently is 145 watts. Let's place the wind turbines and also a cable analyzer here. This is using 20 watts, 10 and 10. Yep. Oh, first I have to weld. And I should print the arc welder. Which is battery based and doesn't leak any pollutant. Also, I think it cannot set the air on fire if it is burnable, but this guy does. Which can also be something desired, so it's not necessarily better, the arc welder. Not unconditionally. So what's coming in now? 600 watts. And what are we using? Yeah, now we're getting more watts than we're using up. Great. And now for hydroponics. Right, this is not yet the time actually, because first I need to make sure that we have a stable station temperature. There are various ways of cooling your station. I guess I have to first show the simple ones, since that's the purpose of this video, though I would pretty much really love to just print the counterflow heat exchanger, which I hereby do, just so that I have it already. Oh, I haven't yet upgraded the Atmos printer. I need to print the upgrade. I need to print 2 more upgrades. Autolathe printer mod? No, I first want to make the mod for the pipe bender. Electrum constant and solder. How would I normally go about this? Well, do I have some steel extra? Some steel left? I think so. I split something that should be lying around somewhere here. Oh no, I think I tossed that in some place. Not in here, sadly. Maybe I should decorate the room a little, huh? It's not quite the time yet. And now I will print something that is very interesting, so listen up. Pipe radiator, the kit pipe radiator, which needs gold and steel. I have already shown you that a pipe will leak. You can see here it's convecting 17 degrees, 17.5 joules per game tick. A game tick is half a second. It's convecting that, so it is losing that thermal energy, probably out there to the planet. And if I slap a pipe radiator on that, that would be much more, extremely much more. And that is why I'm printing these now, so that I can create a cooling system. I guess we didn't have enough gold, huh? Need some more gold. Gold sievers. Do we have to go mining? Looks like it. I dislike this. Or maybe I should make this security printer as soon as I can. And now the autolathe printer mod. I need steel for that. Good thing I made extra steel. Pipe bender mod. There are various heat exchangers that you can print. They are pretty much, I mean, you have one pipe network and another pipe network, and they meet intimately without actually exchanging their gases. And the counterflow heat exchanger is probably the most effective of them, but you need to lean into it. You need to pump actively gas through it. While the other heat exchangers, you can just connect passively some gas pipes and a liquid pipe, and then that will work. So I will devise a very powerful cooling solution. Let's place that here. I have to see how I place this, because one side has some kind of well, some indicator, so to speak.
Power critical.
How are we doing power-wise? Using 250 watt, producing 300. Okay. Next step. I forgot it. I wanted to do a certain thing. Oh, let's do a different thing then. Need some steel here. What? Yes, I wanted to print the security printer. That's what it was. And that takes gold and steel. Great, I have neither. Or do I? A little bit of gold left here. Well, the tool manufactory stupidly doesn't show you the information unless you turn it on. Then again, maybe that's just more realistic, you know? How much gold do we have? 9 grams. So I don't have enough gold to pull this off. I need to go mining before I can print the thing with which I can print the mining charges, which would make mining much easier. Yeah, ridiculous. Or should I do the programming first? Oh, okay, let's go mining first, since the sun is out.
Hunger critical.
And the hydroponics, yeah, I need to write the right atmosphere first. As long as that door is the way by which the station is cooled, the station will not have enough CO2 for the plants. So I cannot do that. I have to first make sure that we have a proper cooling solution, instead of just opening the door on a foreign moon, you know? Well, this could also be placed on there, and then I could pump something into this thing so I can refill it. And then I can just dump my canister in there. Convenient, convenient. Of course,
Air tank critical.
usually I would just place a canister holder somewhere and a filtration machine and some logic, and then it would detect, oh, that is an oxygen canister, let me just fill that thing with oxygen then, or something like this. All of that can be done. Mining, yep. It should be a blast with the new drill. primarily we need gold. Oh, and we need to see something. 260-ish degrees. Oh, I thought I saw gold here. Apparently I didn't. Oh, but iron. We don't have too much of that stuff. Let's take some iron. Now some gold. Sideways motion reveals the glitter. Ah, there it is. Straight ahead. And the station would then be at 300 degrees. That's a game changer, right? Once you have these advanced, once you have these alloys and can print your advanced toolkit, can you print the advanced tool belt and have the heavy mining drill? That's a lot different now. Mining. Okay, no more gold here. But let's get some more gold while we're here. 300 is the station. Is it? Is it? Is it? Oh. Oh yeah, okay, it is. It is. It is. Three two three is the station. I think after this we have enough gold for a while. Okay, let's go back. Stationeers. I suspect that the reason that the station got a bit colder, I mean we have now 22 degrees and not 21, so I think it's getting warmer again. The reason that it got colder than 27 degrees was possibly my placement of the gas sensor. I mean, the station cools down here and the sensor is here. Maybe the placement is not optimal. But doesn't matter. Currently it doesn't. That was a good run. And the battery is still 79%. The capacity of this large battery versus the small battery, by the way, is exactly 8 times. 8 times the capacity. Oh, what happened to the music? And why did I not notice this earlier? Yeah, I wanted to start with the hydroponics. For that I need temperature control. For that I need some gold so we can print more of these radiators. Because I just want to make a simple radiation cooling assembly. I will have some pipes out there, some pipes in here, and then I will just fill this pipe with oxygen or with atmosphere, whatever. This will then exchange the thermal energy between the outside and the inside, and that should do some damage. And I actually want to make that pretty powerful, that thing, because the furnace is a beast. Then again, once I have the counterflow heat exchanger solution running, I don't need that anymore. Oh great. I forgot to take gold with me. Stupid! Okay, now that we have some gold, we can continue printing these nice... Wait, that's the wrong one. Radiators. Steel.
Critical.
Oh, look at that. Okay. Yeah, I wanted to take a look at our waste tank. What does it look like? What's in there? 10 degrees, that's fine. Almost all of it is CO2, that's also good. That is valuable. Of course, we could just pump some atmosphere from this dude into the room. Then we have CO2. There's a lot of CO2 in there, right? So maybe I want to do that. So we would need a filtration unit coming from this direction. Oh, well, it's not perfect. I mean, it wastes little space like this. Okay, where are the pipes? Which we can print, of course, with the hydraulic pipe bender, if need be. Is this the filtration unit thing? Yes. I did not accidentally make, yet again, the AC. Power. Oh, I guess it just interrupted the smelting process. That's why the rest is still in there waiting. Well. I will talk about this later. Yeah, and that's what I talked about earlier. If something doesn't work, it's probably because you forgot to connect the logic. Nanu? Still not. What am I doing wrong? I wonder. Has the source code not been written to the chip? Oh, then I did something wrong. Right batch. Hair structure arc furnace. Activate 1. No, this should be working. Oh, filtration. Ah, reingelegt. Of course I need
Power low.
to choose the IC housing. Here we go. Now it keeps pushing that activate button the whole time. So it didn't have to go out. Haha, typical computer thinking, right? Instead of getting off my ass, I'm inventing something. Okay. Wanted to do something with the atmosphere. Let's print 3 CO2 filters. Not with the toolmaker, but with the hydraulic pipe bender. I print carbon dioxide filters, 3 of them. This one is garbage. They will always be used up from the left side. That's why I am doing it like this. Okay, I want to print another one, but that's not so important. Just to fill this up, you know, it doesn't matter. Okay, I can now filter this into the room. We have to consider several things. One is, how hot is this stuff still? The furnace is at 22 degrees. That's perfect. We just have room temperature. And another thing is the gases that I want in the room. For that I need the passive vent. And I also need a pipe cowl, because the waste gases also need to go somewhere. Or just some pipes. Or maybe the pipes would be enough. But should be insulated pipes then, huh? Let's just not do with the insulated. I want to see what happens. And then I can just put up a wall heater which uses 1000 watts. So what did I need now? A passive vent. Iron. Maybe I should really just invest the iron to print the chutes and to use that thing from the indoors instead of running out here the whole time. Okay, that's the computer interfering. This can be done more elegantly, but I mean, I just wrote one line of code. In principle, I don't count the main loop as code in principle. So yes, I was here. I needed iron, that's in the works, and I need to connect the waste outlet of the filtration unit with this part. Funny enough, I need to connect the inlet with the outlet. That's possibly not too efficient, but let's do that anyway. Basically, I should just pump this out of the station here. But this should also work in principle, would just be much less efficient, I guess. Because, I mean, the purified air comes in here, so the mixture here lessens in CO2, and then the process of getting out the CO2 gets slower and slower. Better it would be to just pipe that out here, station wall, and then... But let's keep it like this for now. See if it works. Then we should have some iron now, I guess. There it is. So we can make that. So now I could pump in CO2 into the station, which I won't do because we still have this problem here. We need to cool the station by other means. How many pipe radiators do I have? Wrong. I think the problem was the absence of gold. Is there gold in here? Yes, there is gold in here actually. These you can build onto a pipe only. The ones you can see right now, this one is a convection radiator. As soon as you have some atmosphere here, you should use this one. It's much more effective. It also has radiation convection, but really it's radiation thermal energy transfer, but its convection aspect is really much more powerful. And then there's the other one. There's only these two. The pipe radiator, this one is really just for radiation on the moon, on the outside. If you use this, very effective. And this one is for when you have atmosphere. So on the moon you would on the outside use these, on the inside these. And here I will use these on the inside and outside. And take care not to build your pipes into the floor when you use these. I mean, I don't know about this one. It might be that this one works as long as it's rotated like this. But this one might actually not have any effect. So the pipes should have one distance so that they are free. It's not as many as I'd hoped. Alrighty, now I need an active vent because I need to somehow control whether there's atmosphere in my cooling solution, copper.
Hunger, caution.
And later, when I automate this, I also want a pipe analyzer, which the computer can read. Where do I have my electrum and such? Here. And what do I need to complete this guy? Welding torch and one steel sheet. No steel. And I wanted to make the arc welder. Steel, electrum, invar, solder, my god. Where will I have this cooling solution? Maybe kinda here, where I will also have the other one. Yeah, along the station. That's a nice idea. I will now need pipes, for which I need iron. But I guess I will now print some chutes so we can finally get that over with the arc furnace. And I will need a lot of them. Hey, we can directly use this new welder thing that we have. And there is the counterflow heat exchanger. On one side we pipe through the gas from the planet, from the moon, and on the other side we pipe through the gas from the station, and then it will get radically colder. It is really, really effective. But that's something you cannot print at the beginning. What does it even need to print the counterflow heat exchanger or some heat exchanger like that? It takes the hydraulic pipe bender tire 2, so the already modded ones that we have here. So that's a no-no, I guess. What about the other heat exchangers? Small direct heat exchanger. There are different variants for liquid to liquid, for liquid to gas, and for gas to gas. For all of these, it's the same. Kit heat exchanger. Small direct heat exchanger takes copper and steel on the hydraulic pipe bender tire 1. Large direct heat exchanger, steel and invar tire 2. Okay, so the large one cannot be made for you normally. And what is this? The counterflow heat exchanger, we already had that. And then we have just the heat exchanger, steel and invar on also tire 2. Okay, so in other words, you can only make the small heat exchanger otherwise. Or, of course, the, what's its face? The pipe radiators that I will now put up. Do you hear that? That's when you just bluntly turn it on and on and on again. So these are kind of like pipes, but you cannot cross them. There are various types, corner for example, then we have straight, and then we have also straight windowed, which like many of these takes 2 instead of 1 chute, so that's wasteful for me to use here. But then I can see what's still in the stack and I like that. So once this iron stack is through, I will print a lot more chutes, and then I will make it so that I can toss stuff in there from the station. And then we don't have to go outside every time. And then I can smelt the rest of the gold. So, about the hydroponics, I can already take the hydroponics tray and place that here. There's also the hydroponic device. The difference between the two is the device cannot be placed next to each other. So is there another device? And you cannot place hydroponic devices directly in a row. I explained that devices need some distance. So I can, for example, alternate hydroponic devices and hydroponic trays. The difference is the hydroponic device can be read out and the hydroponic tray cannot be read out. You know, the state of the plant, you know? Iron. So let's make some more chutes. Let's connect the liquid pipes. The hard suit, by the way, has a chip slot, and you can actually program that to automatically open or close depending on your environment. It strikes me to be slightly wasteful, but okay. iron is melting in front of our eyes. Right, maximum stack of 10. Yeah, okay, that's kinda crappy. It's inside the glass. Ah, come on, I can't walk past this guy. Fuck. Then I have to do it differently, I guess. This guy could be in the glass pointing down. Oh, I can do this from here. Okay. So, let's smelt some gold, shall we? No more leaving the station. Oh, and by the way, now we have an input stack. Also very convenient. Do we need more iron smelted? Maybe. Where were I? And where was I? The cooling system. I need pipes. More pipes than I have.
Power critical.
Oh. Did you just see that? It was accelerated up there. It's now going in the arc furnace. There. God damn it, we have some pipes in the arc furnace. Ah. Always something. God damn it, not what I wanted. We can also install a display here that shows us what's currently cooking in the arc furnace. That's possible, yep. And of course the progress bar that shows us how far the arc furnace is. So what I'm doing here is I'm building a pipe network that will allow this active vent to get some station atmosphere into that pipe network, which will then, well, that will cool the air. Actually, I realize maybe this active vent should be pointed towards the outside. That would make much more sense, because I don't want to get some station air, which also has some pollutant possibly, in this pipe at high pressure, and then slowly cool it down and then pump it out again when the station has... I mean, this would bleed thermal energy into the room. I'm not yet done. I will put some radiators up there. But then I pump this thing empty again to turn off the cooling system, but the air coming in when I pump it empty will also be very cold, and so I will overshoot. This is not bad, but I mean, I can just adjust the target temperature, problem solved, but still, that's not nice. It would be cooler if this could happen differently. Okay, let's just keep it like this for now. So here we put the pipe analyzer, which will be used to automate this whole thing. There. And then I need some radiators up here in the station and some outside. I only have 6 overall. Do I really have 6? No, 16. So I can make 8 inside, 8 outside. What could be more on the outside, more on the or more on the inside, depends on what flavor I want, and I actually don't know which would be better. I'm just guessing here, you know. So, pipe radiators, and I will put them up in a way that they don't disturb my walking. I don't know though what happens if I add some floor decorations, then I walk a bit higher, you know. It might be that I cannot actually walk underneath this then. 1, 2, 3, 4, 5, 6, 7, 8. Now the same on the outside. I wonder if the arc furnace will ever be done with those pipes. I mean, everything that is currently baking might be... everything that's remaining might be pipes. No, it's gold ore. I could save those pipes, but you know, I don't care. Aha, that actually works out. Nice. I don't need 9. I only have 8 radiators. But okay. So if there would be some gas now in that pipe, we would have a strong cooling effect for the station. Let's demonstrate that by getting some cables that we need anyway. Funny how we still have enough electricity. How this just balanced out here. I mean, two more wind turbines and then... I wonder what is baking now. How do I connect this here? Input 2. Okay, that works. Output 2. Just to be clear, this is not part of the cooling solution. This will be my actual cooling solution, but currently I want to show you one that you could build rather early once you have steel. So let's demonstrate that. We have 22 degrees in here. I will set the direction of the active vent to inwards so that it pumps into the pipe network. And now it has pumped some gas in there. Stupidly, I haven't yet connected that. Temperature in the station is falling. Let's pump that back out. And now we have 14 degrees, or 15, or 16 degrees. Auf jeden Fall ist es jetzt kälter als vorher. Jawohl, ja, es ist kälter geworden. Dachpappe. Bahnhof. And then we can automate that with programming. And the hydroponics, well, soon, very soon. Okay, now we can see what's in the pipe. Nothing. Pressure, none. Temperature, 0 Kelvin should basically also be none, because no vacuum means no temperature and not cold. Capacity 210 liters and liquid volume 0. It seems to be ready for action again. Okay, now that we have a cooling solution, we also need some heating. So I would say let's print some wall heater. Oh, it's not here. Okay, that's the hydraulic pipe bender then. We have pipe heaters and we have a wall heater. I will print 2 of these. Okay, this would be the cooling solution, and the heating, I will put that here also. Yeah, we're kind of consuming a lot of electricity by now, so it might be that eventually we use too much, and then we will get cable burnout. And we will not know which cable burns out. Could be this one, could be this one, could be one that is behind a wall or whatever. You don't know. Therefore, let's take an interesting measure. A cable fuse. Now, where I put this fuse is a strategic choice. So far, we've been fine with the power consumption that we had. This power is coming entirely only from that strand, so I will just do... That's not ideal. When I do it like this, then the logic is interrupted. Okay, but let's do it anyway, whatever. So now we can choose which fuse to use, 1 kilowatt, 100 kilowatt, 50 kilowatt or 5 kilowatts. So if there's power overload anywhere, if the cable network gets overloaded, then this fuse will be destroyed and the cable underneath also. And this means, for example, these 2000 extra watts will be gone then. That's one way to do it. Okay, I would say let's put up the plants or put in the CO2. Let's get the CO2 in the station. We're getting now CO2. This is very slow. Oh, I see that there's very little pressure in there. Why is this a little pressure? Huh. I thought we would get more, but okay. Let's see what happens. I will just leave it running. What we can also do is I can open this guy here. Let's see what happens. What happened is now this guy also has some room atmosphere because it's just an opening, so it's an exchange. That's always like this in Stationeers. Now we have room temperature of 16 degrees. It's a bit cold. Maybe I can turn on these guys, huh? And CO2 more than 1%, which is what the plants desire. and the temperature is now increasing. I think that is the wall heaters indeed. The pressure is fine. We have water in here, and the temperature of these guys is also nice, because the water must not be too cold or too hot. In other words, we can now go and just say, let's plant some stuff. As a beginner, you should always plant only one, but I will plant all three of them, because I hope to know what I'm doing. Let's save the game. I've turned off my autosave because I'm changing game versions every once in a while, and I don't want my save games to be overwritten with a different version. Short summary, what's happening here is these guys will now thrive towards fruiting. Hopefully, I mean, if these conditions are right. Let's print the plant analyzer so you can see that. Man, I've been talking for hours. My voice is kind of going away. Plant analyzer. And maybe I want to print another tablet. Or maybe even an advanced tablet. Is it here? Nope. Can I print an advanced tablet? Solder, electrum, iron, gold. Fuck me sideways. Okay, let's get that stuff then. The simple tablet doesn't need that much stuff. But I want to use the old tablet that we had so far for the plants, and the new one for my immediate purposes. Oh, that takes a while. Okay.
Hunger critical.
Well, I wanted to change the tablet anyway, lastingly, so that makes sense. Let's look at the plants then. And what we see here now. You have to understand these are groups. This is a grouping of all the things that are shown here, and is showing overall this results in a growth efficiency of 100%. And this growth efficiency is in turn a consequence of the breathing efficiency, the temperature efficiency, the pressure efficiency, and the light efficiency. This tablet is not properly organized. The breathing efficiency should be together with the gases here. The temperature efficiency is together with its depending values. The pressure efficiency also, and the light efficiency also. So it's kind of a mixed bag, but you have to understand this is a total summary statement which results from the breathing efficiency, temperature efficiency, and so forth. So let's see, breathing efficiency. They need CO2 at least 1%. We have 3, bit little, but okay. We need. Oh wait, how warm is the room? 26 degrees. Let's turn that off quickly. And actually, I want to take this one out of business so it cannot automatically open. We should get an error here now. It is saying that the target device is no longer there. Currently flashing an error, yeah. Let's turn these off anyway. And this one also, 100 watts. I need another large battery. Could we print one, please? Two, actually. Okay, then only print one, alright. Oh, the battery is empty. I mean, otherwise I would have expected this battery to be at 100%. But I guess we are using too much electricity. Which is not a surprise. I mean, the 2000 watts extra, do you expect the wind turbines to produce 2000 watts all of a sudden? So I will burn some more coal. And I would say the entire rest of it. What does the rest mean though? Let's see. Oh, it burns the rest then. I didn't know that. Okay, so we're not wasting anything then. That wasn't the best way to do that. Let me just check how much hard disk space I have left. Okay. Because these videos are ridiculously big. I mean, this one should be overall 100 gigabytes, I guess. Yep. So where was I? Cooling solution, yeah, that kind of works. 26 degrees. These are now offline. I wanted to check out the plants. So we have 1%. We have at least 1% CO2. In other words, we have 3. And this is already only 3.04. It was 3.05 earlier. I guess the plants are breathing that away. So then there's pollutant. The limit is 1 kilopascal, but we have no pollutant currently. Volatiles, same thing. And that would be the breathing efficiency, which is complete. Temperature efficiency from min ideal 19.7 to 29.9. And here we have different thing because we have genetic drift. Every plant has its own genes, and depending on what situation they have been in, for example, primarily too cold, they will be more cold tolerant, their offspring, which is the turbo evolution basically in a simplified form. Of course, evolution doesn't work like that. The plant doesn't decide what quality its offspring will have. Evolution works like a randomization, and over many generations and also many plants in parallel, the plants that have survived in the cold, they will procreate, reproduce, but the others not so much, and so those remain. This is the gamified evolution. Current temperature 26, so we are exactly on the ideal temperature basically. Pressure efficiency 100%, at least 50, maximum 100, we have 63, so that's fine. If it's outside of these values, then the efficiencies will go down, and so the growth efficiency will go down. And finally, we have the most important efficiency that people easily overlook, the light efficiency. The light intensity currently is 0%. Once the sun is out, it will be, I don't know, 70% or whatever. And we currently have no light deficiency and no darkness deficiency. That was related to the timers I talked about. You need some duration of light and some duration of darkness. Let's look at that again to refresh that. Here, light per day 5 minutes, darkness per day 3 minutes. And that's what it is. You have to give them that and the water, and then you're fine. We can also put up the plant light and add that into the mix and turn that on during the day so that we have actually more intense plant growth. But let's not do that now. What should be the next step? The plants are growing. We need to make sure that the cooling solution works and the heating solution works so that we can rely here on the... I will put this away. We can rely on the CO2 atmosphere of the room. Yeah, this is completely ineffective. I need to indeed pipe that out of the room. Not toolmaker, I need a pipe cowl. Yeah, it's a bit crowded in here, huh? And when I add a new part to the station, then of course that new part will be completely cold. Or in the moon, it will be completely evacuated. So you should try to prepare that section before you add it to your main room, if that is even the approach you're using. Ah, fuck. That's bad. That is very bad.
Temperature low. Temperature critical.
God damn it, where's the iron sheet?
Temperature low.
Why do I still have the welder? So we just wasted precious atmosphere and precious CO2 also, I guess, which means that the plants, all of which are now planted, are basically now in the process of dying. And it's too cold in here. We have CO2 2%, so we're still fine. The pressure is also still okay-ish. Yeah, that's what can happen if you point the wrench wrong. And I can place that from in here by pointing here at the edge. So now turn this on again. And now we should actually get some more CO2, because now there's an actual cycle going on instead of this thing, well, talking to itself. 4% CO2, and the pressure will of course increase in here because the gas is coming from the chamber of the furnace. Yeah, temperature 2 degrees, bit cold for the plants. Let's see what the plant analyzer would say to that. Light deficient, okay, that's not good. I guess I need the plant light, I didn't even think of that. Well, then let's make some cables and be quick about it, because the plants are now being battered from two sides. Action engineering. So, what does the plant cartridge say? Now we have 80% light intensity, and if the sun comes back, we will have much more than that even. And that's, as far as I understand, not bad. The more light, the better, as long as you don't get too little darkness during the day. And again, even if I accelerate the day-night cycle, which I think I've explained in this video, let's see. Did I show that orbit and timescale? I think so. Even if I accelerate that, the plants will stay on their 20-minute day-night cycle. Growth efficiency is very low. Why? Because the temperature efficiency is very low. It's increasing because the temperature is now coming back closer to where it needs to be. Illumination stress goes up whenever there's a deficiency, and also whenever the light situation changes. So if I turn this on and off the whole time, then the plants will get more stress. See? 20 instead of 14%. Guess I need to eat, huh? Soon we will feast on potatoes. I should put up the table if I still have it. There it is. Where? Maybe here. There are several tables here, some of them are powered, some are just decorative. And I tend to put up this one, doesn't matter which you use, but I tend to put up this one because it feels more like, well, more solid. It feels better to me. So let's put the microwave up there and then wrench it. And then it is cabled up. Now we need to connect the cable to the table. And then we can use the microwave. Microwave potatoes give you more nutrition. There's nothing in there. And you can also eat a potato in part only then, if you wish. Alrighty, the plants are at least not dead. Of course, at some point we will have the problem of darkness deficiency if I leave the light on for too long. So there's something to consider. Can we see the sun already? I think so. Ish. Yeah, I will just leave it on until the sun is here, then I will turn it off and the sun takes over, and then basically we have to program this guy to turn on when the sun should be up. So let's print a daylight sensor which tells us the angle of the sun and then program something in relation to that. Also, I already have some program running here in this station, which is the pressure thing with the door, no, the temperature thing with the door. I would like to reprogram that in IC10, in MIPS here, in the assembly language, but that doesn't make sense. I don't want to open the door here at all at this point. What's the atmosphere composition now? We have a little bit of pollutant, wherever that came from, and 7% CO2, that's pretty good. And this is now empty, so we can turn this off. Could also put a chip in here and say, okay, turn off automatically when there's no more power. By the way, then you don't want to turn it off because the chip is then also turned off. This guy has also the mode variable, mode 0 and mode 1. If you set that to, I believe, mode 1, then it will be turned off even though it is still powered, so the chip can still run. So a daylight sensor, where do we put this then? Here? To the computer? Yeah, why not? So then I will use once again the screws to teach you about this again. I will select here the daylight sensor. And I will select here the grow light alphabetically. There it is. And now we want to make sure that the grow light turns on and off with the sun being at the horizon. Okay, let's start programming then. Let me first explain what I programmed already here. This is a jump command. I mean, the computer will run through from line to line to line and do whatever's written there. Here it is, nothing's written here, there's just a label. So that, see, I'm jumping here to the line 2 without saying that it's 2. And now I'm jumping to the line 5 without saying that it's the line 5. I'm jumping to this position in my source code. I could also say this will work, but of course it's very risky. And then the yield command, this is all running in a game simulation, and so you need to consider that the computer needs some breathing room to simulate the game itself also. And so the computer will execute 128, I believe, lines of code when there's actual code there. And then it will force your program to wait for one game tick, which is half a second. But so if I remove this here, then we'll basically write to the arc furnace during this game tick 128 times, or maybe 64 times then only, to activate, which will not do so much. It will just activate it once, and then the other calls will be without actual effect, I think. And then it will force your program to yield. But obviously it would make more sense to just say, I yield out of free will at this particular point. Then I also know when this happens, what my program timing is. And I also don't need to write this to the arc furnace more than once per game tick. Once per game tick is enough. So your programs will often look just like this. You have a start marker, you say yield, usually exactly here at this place, and then you say jump start. And here you do then the things that you want to do. And what is it that we want to do? Well, I have this daylight sensor here. Oh, the sun is up. What is the intensity of the light now? It is now 84%, so the sun is actually not sufficient to drive these plants. On the moon and on Mars it should work, but here we do need the grow light. I didn't even consider that. Nice save. What's the room temperature? 22 degrees, so let's turn this off. And I wonder how full the station battery is. It is basically... there's still some electricity in there. Can we print some more upright wind turbines? 2 of them more, then I think we will have a nice excess. That would be cool. We need gold. No, we need more iron. Do I have some more iron? Yep, I do. this would print 6 in regards to iron, 4 in regards to gold, and 1 in regards to copper. Okay, that's that then. So we have the daylight sensor on screw 0. Let's look at the daylight sensor again. We have these logic values and we can access them with the logic chips and also via programming. Now let's read out from the daylight sensor the vertical angle, which, like I said, 0 degrees is noon, 180 degrees minus 180 degrees is... Oh, is it 180 degrees? Actually, I don't remember. 180 degrees is midnight, but depending on world, the sun will not actually go that far. It will only go to like 4 degrees, and then it will start rising again to 5, 6, 7 degrees, because noon is actually never hit directly, because obviously this guy, we are experiencing a circle here. And the sun is also moving. I mean, of course, the sun is not moving at all. There's also the horizontal angle of the sun. So what I want is, whenever the angle of the sun is 90 degrees or less, then we are during the day phase. And during that time, this guy should be on, together with the sun. I mean, if I turn this thing on during the night only, then during the day the sun will here and they will always have light, even if it's only a little, and that's not advisable. So I will just have this on together with the sun. I think I need some more heavy cables. Power coming in now. 600 watts, yeah, okay, of course it depends on the wind speed. Okay, and during the night this should be off. What angle do we have? 61, 62, so the sun is... let me just accelerate this a bit so we get to see that, and then I explain the source code. Load from D0, which is the daylight sensor, into a register the angle vertical, or is it just vertical? Aha. Then I will turn this number into a logic statement. I will just say if this value is greater than 90, yeah, if this value is greater than 90, that's a logic statement, and then I want to write to the grow light that it shall be on respectively. Export. Oh, okay, I did it wrong. Oh yeah, of course, greater than bullshit, I mean less than. Ah. Okay, now when the sun reaches 90%, 90 degrees, the light should automatically turn off. And the plants will then have survived the first very stressful day. But growth efficiency is fine, so... Do I still have the things on? No, I don't. I mean, you have seen already how powerful this is. Just a few lines and it does that. I would have to put up quite a few chips to make that happen. Aha, look, the plants have grown a bit. They are now thriving towards fruiting. Once they at some point they will have potatoes. Sometimes one, sometimes two. Depending on how stressful their growth was, how efficient it was, they will have only one, but normally they will have two. Then you can just pluck one of these and leave one on the bush, and then you can eat it. If there's only one on the bush, then you shouldn't take it, because after they have fruited, they will be thriving or growing or growing moderately well or whatever towards seeding. Oh, look at that. It went off. Haha, we have automatic grow lights. Now we need to regulate the temperature also automatically. Anyway, so you want to wait until they have seeded before you pluck away all the potatoes, because once you have plucked away all the potatoes, the plant will be gone. We also have some perennial plants, like for example the tomatoes, which grow very, very slowly, but once they have fruited and then seeded and such, then their cycle until they are fruiting again is very short. But I don't have tomatoes here. I would have to ask a trader to sell me some. So I would have to make a landing platform and a radio dish and a computer and the communications motherboard and so forth. Yeah, that's so much for the plants. So let's talk about the source code. This is me turning on the arc furnace the whole time, but I don't need to. What I can do instead is, okay, maybe I should. Okay, let's do it differently. Let's talk about this part here with the grow light. You know that I assigned to D0, to the first screw, to D0, the daylight sensor, and to D1 the grow light. That's why I can load a value here, L load from D0, and I can save one to D1. But this is a bit cumbersome. I can also say alias whether I write uppercase or lowercase doesn't matter, but underscore is illegal, and since I don't want to collide with any existing names, which are always written like this, upper case, I will just write them like this. My day sense is D0 and my grow light is D1. See, now I can use this and it will work just the same. No problems. What would a problem be? Well, what if, for example, I remove the grow light from the wall and put it up again? What happens then? Let's do that. So it's up again. I mean, it was flashing an arrow before already. The day sensor is still there, but the grow light is no longer there. The grow light, it is assigned to the grow light, but the reference internally in the game system works via identity numbers. Every device, everything in the world has an identity number, and this one has one too. And when I deconstructed it, the item that emerged from this in my hand also had an identity number, and then I put it up on the wall again, and now it has an identity number again, and every time it's a new one. Always a new one, and so this one is now pointing to a grow light that no longer exists. And so now the chip is not running, and the plant light will not automatically be turned on and off. But we can also develop it in a way that it is not so dependent on that. And I want to demonstrate that here. I will now turn on the grow light, and it turns off again. So this means the computer is in control. What is it that I just did there? You can see here structure arc furnace or structure grow light. What is that? blah blah blah, human text, not too much, not too reliable, and here's all the computer stuff like I already explained. And here we have the name, structure grow light, and here we have a number. This is actually the number of the device. Now please don't get confused. This is the number describing the type. This refers to any and all potential grow lights. Whereas the identity number that I was talking about earlier with the screws, that is the reference ID? I think so. Let's look at the logic values. The prefab hash, that is actually here, the prefab hash. You can actually read out that number. So if I would access that via its screw, then I could read out the prefab hash number, and that would be this number. So then I would know what its general type number is. I'm not saying that's the way you should do it, I'm just saying I could. And here we have the reference ID. That's the one objective number in the world that every object, every item, everything has. That is what I could read out here. And then I could actually do something. Let me just read out that number. I want to read out the number. So currently I'm turning the grow light on in a different way. But now I would change that. I would just say R1 on R0. Let's see if this works. I'm not sure. Oh, there's a problem. Unknown at line 17. Right. See, I wanted to write directly to the... Actually, what am I saying? This doesn't make sense. The current situation doesn't make sense. I made a mistake somewhere. Right. So I turn this on and it turns off again. See, there are different load and save commands. You can pause the simulation of the game also by clicking up there. Let me just write them down. SSD, SS, SDS, sadly doesn't exist, I will leave it here anyway. SB, SBS, SBN and SBNS. Now this seems very complicated, just like when you look up here, you can see all the commands that exist in the game, and then you see BGT, BGTAL. Who the fuck is supposed to remember all these commands? Nobody, because it's a concept, just like these names here, structure, grow, light. By the way, by using the hash function on this text, I'm turning that into the number. You know, when I was looking here at this, I can click here and copy that to the clipboard, but I can also click here and copy that to the clipboard. Basically, what I'm saying is, instead of saying define growly hash blah blah blah, I could say define growly this. But obviously this is much easier because then I don't have to remember the number. These names are always the same. Structure grow light, structure arc furnace, structure daylight sensor. So the daylight sensor could also be accessed like this. Let's do this. Define day sense like that. Man, it's late. Structure daylight sensor, which I could have copied to the clipboard also instead. So, okay, let me just remove that for a moment. I will keep explaining that soon. So I want to load into register R0 from any and all... oh, that was stupid. Heh? Where's the daylight sensor? Oh. I did something stupid, I guess. Ah, damn it. Define day sense structure daylight sensor. And that should theoretically work. To verify whether this works, I will just... I know that I'm explaining too little, but I will fill this all in. Don't worry. Aha, okay. See, here we have the daylight sensor vertical angle 124 degrees, and here we can now see live with many decimal places what that actually means. And I did this just now to find out whether I had made a mistake. I have not. So you can define that... Okay, we can turn a word into a number. And if it was a meaningful word that the game knows, then this will work as a number. I have to basically turn these on again. Ah, crap. Did something just... Yeah, okay. So we can write a value directly to a screw. That is S. That is for writing to D0, D1, D2, etc. If you have a filtration unit, then you will only have D1, D0 and D1. Obviously, there are only two screws. That is for directly writing to a device. You can also say DB, then you're writing to the device in which the chip is housed. So if it's a filtration unit, then DB is the filtration unit. And you can also load from there, of course. And SD is for writing directly to an ID number, which is something I did down here. See, I found out what the grow light's reference ID is, the objective number in the world, the unique number, and I said write directly to this number that the device shall be on. And this worked. Then we have SS, which is the same as this one, except it is writing into a slot, in case there is something that can be written in the slot, which is normally not the case, but that could be the case. I mean, I already told you about the arc furnace slots. You can find out if there's something in there. Fittingly, we also have the load commands somewhere here. But, I mean, I just have to replace the S with an L, and that's the same thing. Just this group of command also exists for loading. That's for slots. In other words, we have now write and we have write directly. This writes to a screw device or to the device itself where the chip is housed, and this writes to if you have the objective ID number of that. And if you print the configuration cartridge, then you can actually look up this objective number. This is possibly no longer in the game at some point, the have said, but it has been in there for a long time and the devs have their hands quite full, so let's just use the plant cartridge thing for now. So when I look at the grow light, you can see here, this is the reference ID, 15545. So that's the number that I'm reading out from this device, and then I'm using that number to write to this device directly that it is on. This is of course asinine. Normally you don't do that. I'm just explaining concepts here. That's why the examples are so wicked. Up here we have the reference ID again in hexadecimal notation. You can use that in your source code also if you wish. And the power is currently powered, and it is not locked. So if it would be locked, then I could turn it. Then I could not turn it on or off manually. That's the same that you have here in the airlock. Is currently I'm not sure if the airlock is not completely configured, but this door is already a part of it. It will tell us this is locked, and so you cannot operate it. Oh yeah, here, the device is currently locked. That's what that's good for. This lock value. Many devices have that. Then the on value is true, obviously. Where's the sun? 66. So it's going towards noon behind Jupiter. Where is the dude? Oh, over there. Then we have the required power, the prefab hash. This refers to the type. So any and all grow light, all of them have this number. And this number again is exactly the same as this, except this you have to pipe through the hash command to get this number. And the computer can only work with numbers. And then there's the name hash, because the name itself can also be turned into a hash, and meaningfully so. And I will get to that very soon. So, turn this around again, and off, and away you go. So here I'm turning the type name for the grow lights into the number for any and all grow lights. Here I'm doing the same for the daylight sensor, and here I'm doing the same for the arc furnace, without defining it as a number first, you know. But now I want to do multiple things for the arc furnace, or very soon, so I will define it here, and then I can just use this name instead. Both works, but obviously I will now use this instead. Okay, now I just explained the S and the SD commands, and SS and SDS implicitly. I mean, SDS sadly does not exist, and we have been lamenting this many times. But it's the same command, only this refers to a slot. See, here I'm writing to a screw device, and here I'm writing to a screw device's slot. And then the logic type on, and then the logic slot type on. If there's something in that slot that can be on, then I'm turning it on. If the device itself can be turned on, then I'm turning it on. That's the difference between these two commands. So I think this is now clear. So now we have write batch and write batch slot. In other words, I can delete this one and this one, because you can infer them. And then we have write batch named. I'm using these commands already, except it's not writing, I'm loading. Here we have the daylight sensor type, and I'm loading from any and all daylight sensors that are in the room, maybe 10 of them possibly. I'm loading the value vertical, and since it's multiple potentially, I have to tell it what to do with them. And the batch mode is sum, or average, or maximum, or minimum. I usually, when I don't have different intentions, I always use sum, because this increases the probability that the source code will not work. In other words, if I have multiple daylight sensors here, and accidentally I'm reading multiple of them instead of only reading one of them, then if I would use the average command, then I would possibly not spot the error. But since I'm using the sum command, the likelihood that things will completely be out of bounds, and so I would think, hey, why is this not happening? The likelihood is much higher. That's what I use, why I always use the sum command. It's also typed much more quickly. How much electricity is coming in? 7,000 watts. Not bad. So the battery will certainly be charged now. Good. Thank you, Storm. Right, edit. Okay, that is the load batch command. But first, something fundamental again. We have S commands and we have L commands. The first thing a command always wants to know is where does the data go. We also have the move command. So the write command wants to know where does the data go to the screw, or the write batch to the arc furnace, or the write batch named to the arc furnace with the name this and this. And the load command also wants to know where does the data go. It goes into a register. What is a register? It is just a number, placeholder. We can change those at any times, and you can also use it with alias. And I will actually do that, and I will use R15. We have 16 of these registers, R0 to R15. And I'm reserving this basically in this way. I mean, I can still use R15 happily down here, easily, no problem, but I would rather use this name. And I want to use the temperature possibly more prominently across the source code in several places, and so I will not overwrite this, and so I will use register R15, which is least likely to be used, because I always start with R0, R1 and R2. That's also why I gave this one a name, and these temporary ones I mean, they are the same function-wise. I'm just saying I'm using them differently. Okay, so it wants to know where to load the value, and here it wants to know where to write the value. The move command writes a value into a register, so it should basically be called copy, but for whatever reason it's called move. That's not a Rocketworks thing. This has been the way in assembly, like as old as processors are. The command was always move. So move to where and move what. The register will now have the value 10. And this register will now have the value of the daylight sensors that I may station on this cable network, the vertical logic value of them. And I have to tell it what to do if there would be multiple values. But I only have one daylight sensor, that is why I'm recklessly just doing this. If I want particularly only to request from this daylight sensor, then I would have to do this. I would have to give this sensor a name with a labeler, and I would have to use the hash here, which can also be done by using a defined number. So I can say basically the one that I placed on the floor or whatever. This is the way that you use this. I will have practical examples later so that this is not so abstract. So this is already very concrete. I'm loading the value from the daylight sensor. And I'm also writing it to the housing. I will no longer do this. S is for dB and D0 and D1 and so forth. I said that. And what is this? This is also a write command. And where does it write the data? It writes that into this register. What does it do? Well, it writes a 1 into this register, or a 0. The 1 will be in there if value A is less than value B. R0, value A is also R0, value B is 90 here. This seems a bit confusing because I'm recycling the register. Here I'm reading, I have the daylight sensor's vertical angle here in register R0. And now I'm checking if the value is less than, LT less than, or GT greater than, or GE greater than or equal, or LE less than or equal, or EQ equal, or NE not equal, or not equal to 0. Yeah, that's another thing. There are some special cases. 0, you can't put the 0 here, not a problem. But you can also just omit this. You can do it like this. Why did they do it like this? Because for the longest time processors have been having these kinds of commands, because when I do this, then the processor has to read that value from memory. But if I don't do this, then it can just use the statement itself. Anyway, so I'm saying write into register R1. I want to write that into R0. If R0, which so far is the vertical angle, is less than 90, so we are on the daylight side of things, then I want a 1 in this register, whichever register this is. This happens to be register R0 because I don't need the vertical angle anymore. I just need this value, the logic statement 1 or 0. And so I will just recycle this. This is also why I don't give this register a name, because it's just a temporary value for me. So now I have the statement in here 1 if the sun is above the horizon. And here I'm saying load batch from the grow light. Actually, let's remove this. I'm loading batch from any and all grow lights, the reference ID, sum. I only have one grow light, so this actually works. And then I'm using the write direct command for this, and it's pretty asinine to do it like this. Instead, let's do this. Write batch to any and all grow lights. There shall be on, depending on register R0. I think I have now explained this sufficiently. So now let's find out if we actually want to turn on the arc furnace, which is wasting 10 watts this whole time. And is also clack, 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 clack being turned on. You have heard that out there, right? So load batch slot into register R0 or whatever we choose from the arc furnace. Actually, yeah, from slot 0, which is the input slot, which you can look up in the Stationpedia, whether it is occupied. it's a batch command, so we have to give the mode here. And if it is occupied, then I want to turn the arc furnace on, and I also want to activate it. And as soon as there's nothing in there, the arc furnace shall be off. No error here. Oh, by the way, if I now... if I click here on the grow light, it should actually turn on. Yeah, I guess I just clicked in the exact wrong moment. And now if I deconstruct this and put it up again, there's no error here right now, so you don't get an indication that something is wrong, even though something is terribly wrong right now. And now I try to turn this on again. Come on. It turns on, but it also turns off again. So in other words, now it is not losing track of the grow light, because I'm not using its objective reference ID by means of these screws or by means of using the reference ID here in the source code, but I'm just addressing them by type, and the type does not change. And so this is much more stable as a source code. I will now reset this to nothing at all by going backwards. Left mouse day sense? No, what's happening? Why is it saying day sense and grow light here? I think I just found a bug. This is not connected to any device. Oh, the alias! Of course, that's the alias as set in the source code. I did not know you can see them actually on the screws themselves also. That's pretty cool. So, alias D0 day sense. And then we have this name here. Huh. Not bad. So, does the arc furnace do what it's supposed to? For that we need to smelt something. Do we have something to smelt? Yep, I think so. I will just toss some silver up there. So you heard two things, hopefully. It clicked on, and then it tossed that out when it clicked off again. So yes, the arc furnace is now pretty much ideal. We can throw out a stack, and this will then all be smelted one after the other. But now let's see to that we get the cooling done. Thriving towards fruiting, we're not yet done with these. It's currently 23 degrees. And I want to control the temperature. Let's read out the temperatures, the gas sensor that we have here. And I would just be blunt and read out, or should I give it a name so that you get an actual demonstration? Yeah, let's do that. So I will give it a name, sense gas indoor. Then I can copy this into the clipboard by pressing Ctrl A and Ctrl C. And then I will say define sense gas hash structure gas sensor, and I will also say define sense gas indoor hash paste. Okay. So here we're dealing with the plant light, here we're dealing with the arc furnace, and now I'll be dealing with the temperature. And I will say load batch named. Right, I'm loading from D0, for example, but I don't want this now, into R0. I'm loading batch from the sense gas, and I'm loading batch named from this temperature. Batch read command, so I have to give a mode.
Power low.
And I will actually use the reserve register here. Sorry about my voice, I really need to get this video to an end and go about my day. For example, I haven't eaten in the last 24 hours, so that maybe also play a role. So load something into this register, and now I want to debug this. So write to the housing setting temperature, so we can see the temperature. And always take care that you write to the right thing, as you might be overwriting some valuable source code somewhere, and that's pretty much annoying. Yeah. So what temperature do we have? we have 269 Kelvin, which is 23 degrees. But we can convert that into Celsius easily, very easily. Subtract. The target of this activity shall be a register. Which register? I will use temperature. And now what do I want to put in there? I want to put in there the difference between temperature and 273.15. I'm subtracting from temperature, which is this register, 273.15, and the result will then be stored in a register, which happens to be the same one. And then I have this in Celsius, 23 dot something. We can see that the temperature is very slowly decreasing, so I guess we have a lot of thermal energy bleed by these things. Would be interesting now to swap these out for insulated pipes, since we have this very nice balance here, and then we could see if that still decreases. Though this doesn't really work. Once I've done this, the sun will be up again, and then the sun will shine into this, and whenever the sun hits a space in here, this will heat up the station, so this will not work. Anyway, I want to make a decision. When the temperature is below 20 degrees, these guys should both be on. Let's do this. I will remove this. Actually, no, let's have the temperature displayed on an LED. So I will print a console. And where will I put this? The stupid thing is, see, the consoles, you can place them any which way you want, any which way the wire shows. The display will always be correct. On the floor, maybe not so much, because there's no down, and maybe it will then be oriented like this. But with the LEDs, that's not so convenient. You cannot turn it upside down and will still read the number, and I definitely don't like that. But that's the way it is, so we have to live with it. Up here I want to show the station's temperature. And since we will probably have more than one LED display, in this case I will definitely use the named approach. Bit unfortunate that the word temp can also be associated with temporary. That's why I use the word temperature here and not just temp. Would be ridiculous. Hey, I want a permanent register here and it's temp. What? Define LED temp hash. Okay, that was wrong. It needs to be a different word. We need to go back to the kit, consoles, and we take the small LED display because they're all different. I copy this, I paste it here, done. Oh, damn it. Shouldn't confuse the buttons, that's not good. So, LED small, LED temp. I will turn the thing on, SBN. And I will also give it a color. I can do that from here. For example, color.white. Of course, I then have to say color is the logic value I want to write. And well, there are some values which are defined here. Now these are logic keywords. What I'm looking for is rather this, I think. And we have colors here and all kinds of keywords. Color.white. And I want to write the temperature here. I have the temperature, so all I need to do now is write the setting. Temperature. And that's the temperature. maybe I want to see a bit more decimal places here. So how about a bigger console? That's another 7-hour video, man. And no crash, no problems. This is a beta version of an early access game. I want to repeat that. Damn, I can't get here with the cables easily. C is red because the word no longer exists. That didn't work. Why not? Oh, I haven't given it the name, of course. So I can just click here, copy the name, and paste it here, and nice demonstration actually. Alright, so if the temperature is below 20 degrees, I want to turn on these wall heaters, and I believe their name is indeed structure wall heater. Since I want to turn on all of them, I can just use the non-named approach. So now I will once again create a logic statement like this. Write if less than into register R0, the temperature of the room 20. Now I have the logic statement. I can say write batch to all the wall heaters on R0, and that's it. That's all of it. So if the temperature would now fall, which it currently doesn't, I believe it's increasing because the sun is shining in, but let's change the number here to test this out and go to 24 degrees. They are now on, look at that. They will now heat up the room, and once the temperature over here at the sensor, which is displayed here, which is 24 degrees, they will be turned off. Since we have some wafting back and forth in here, I guess they will turn on again in a moment. They don't, okay. Let's go back to 20 degrees. If it's below 20 degrees, they should turn on. I want 20 at least. But now the complicated stuff comes. We want to operate this guy here. So let's do that then. By the way, the computer eats 200 watts every time. Let that be automated, please. Another annoying message that I have to get rid of. So when I'm very close to this thing, in other words, when I'm within proximity, then I want this to turn on automatically. What proximity do I want? This is... I guess that's okay. We can adjust the value up here with the dial, and I can also program that. For example, let's set it to 1. Nothing's happening. Aha. So it's still turning on when I get really, really close. So this is too close. Alrighty. With the computer's name, we have to look that up. the retro computer. So load batch into R0 from any and all structure proximity sensor of the local cable network. The value activate, and then write that to any and all computers on R0. That's it. Except I also wanted to write the distance. Didn't this work before? Oh yeah. So that's of course ridiculous. I have to adjust this. And I think we can just leave it like that. I can adjust this manually. I could also just write its setting value from here, and then it would be more prudent to have this as a defined name up there, I guess, instead of writing it several times in the source code. But now we have this. So now let's look at the cooling solution. How are the plants looking, by the way? Okay, we have 2 potatoes here. Let's eat some. Yeah. 2 potatoes here, 2 potatoes here, and 2 potatoes here. So the plants, despite the stress that we exposed them to, are fine. I will harvest another one from this plant, else the plant here would be gone. I'm trying to eat something. This doesn't work. I have to wait until the progress bar is full. See that now I just ate 20. So let's see how much we can eat here. Until it's 20. Okay, we can say it's 4 times more productive because only 1/4 is now gone of it. Also, we don't have to eat the entire thing. We can just eat a slight bit, which is very good once the health is ticking down because we are too hungry, because then we can just hit the mouse button for a short second and yeah. We could also make a fridge now to keep these entertained. Let's see, I think that's the electronics printer. We have 2 different kinds of fridges. And I will make the one that's ideal for Europa. What am I saying? Fridge. The small fridge doesn't have any moving parts. You just have to expose it to Europa atmosphere, which is very cold. And then, yeah, where can I put this? Is there some room here? No, sadly no. Maybe I would just remove this guy. I mean, I don't need it. Why have it then? Careful. But before I do that, I want to place the respective pipe and a pipe cowl, which I need to print. Oh, that's it already. What's happening? Where's the fridge? Fridge. There. It is yellow, it is green, it is yellow, it is green, so it has contact. So if you look now with the tablet at the fridge, we see not much, minus 149 degrees. So this thing is connected to the outside atmosphere, even though it is indoors here. And now when we look at the potato, we see in 6 hours it will have decayed. But here, 13 hours. Haha! Not that we need it that long. So the temperature is pretty high by now. Let's program the cooling solution then. I want to turn on the pipe analyzer, and I want to turn it on in the way that I can no longer turn it off. Why? Because I will need it for the logic of the cooling system. And I don't want I don't want me to accidentally click on the thing and turn it off. Of course I can turn it off here and turn it on here in the source code, but what happens if that happens in the wrong moment? What if I turn this off and then it measures or whatever? So define that's the pipe analyzer hash structure pipe analyzer is what you would think, but Rocketworks did a mistype and they haven't fixed that since, and they could fix it by having both numbers be valid, I guess, but they don't, so this is what you have to type. But it's also in the Stationpedia, so don't worry, you don't need to remember that really. I should basically name this dude, but I'm not going to do it. I will just stick with the simple approach so we are faster. You have learned how this works, so I don't have to show it every time, and we want to get somewhere, right? Okay, so let's write to the pipe analyzer lock 1, and then write to the pipe analyzers all on the local network that they should be on. And now this thing is on, and I cannot turn it off. You can see in the tooltip it's locked. And now I can read here, there's nothing in there. What I want to do now is I want to pump from the room, if the room is taut, something into the pipe. Once the room is cold enough,
Power critical.
I want to pump everything out of that pipe again. And once the pipe is empty, I want to turn off the active vent. This is actually very easily accomplished. So first of all, I want to do a debug. I say I want to know the pipe pressure. I will once again use the register up here. And I will load batch because I don't have a direct device, D0 or whatever here, and also not LD, the perfect ID number, but instead load batch into this register from any and all pipe analyzers, the value pipe pressure, and it's a batch statement, so yeah. I want to see if that's actually correct. SDB setting pipe press to see if that works. I mean, currently we should actually see the value 0 here. We do. Let's pump something into the pipe. And now we see the value 308 is decreasing because the temperature of the pipe is falling rapidly. Oh, and this actually cools the room so much that we just reached less than 20 degrees Celsius. So that's why these guys just kicked in to heat up the station again. That's ridiculous, isn't it? Huh. Yeah, they're not well placed. I should put them in a different location. Or no, what am I saying? The sensor is over here, so it doesn't matter. Yeah, that's how strong the cooling system is. Extremely strong. But that should just be strong enough then for the furnace once we run it again. Okay, now we have the pipe pressure. Let's say I want to turn the temperature into a logic statement. So I I write into register R0 if the room temperature is above 25 degrees. That I consider too hot. Well, let's say 30, because the pipe will have some cold gases in it, and I don't want to... I mean, I will overshoot a bit, so let's go for 30 degrees. Which also means that I would have to heat up the room a bit to test this. Or we can just say I disable the heating system for now, and we'll just work with colder temperatures than this. That's also fine. In other words, since we now have a full station battery, let's heat the room up to 25 degrees. Did you hear it clicking? The storm charged it up quite some. So, the temperature, if it is greater than 30 degrees, and I will now say 25 degrees to test this better, Then we have a logic statement here, but I will actually not write it into a register. Instead, I will immediately jump based upon this. I will say branch if greater than branch if this is greater than 25 to a location. You can see that here, A, B, and C, branch to line C, that is over here, if A is greater than B. A, the temperature is greater than 25, then it jumps here. So, room to hot is my label here. Room temp done. I jump to that also, unconditionally, because when I execute this part here, when this part here is executed, then the room is not too hot, and we have to deal with that. But if the room is too hot, then we jump down here, and then down here, we're done. So, when the room is too hot, I want to pump into the pipe, but only to a certain degree. So let's just say write into register R0 if the pressure is less than 1000, which is 1000 kilopascals, which is 1 megapascal. If the pressure is less than 1 megapascal, then this here will be 1. Now I need to control the active vent over there, and this I should definitely name because there's so many active vents around here. Vent cooling. And this thing I will also name while I'm here, cooling. I don't have to use the name, but it's there already in case I need it. Okay, let's prepare the active vent then in our source code, so we can access it easily. Define, by the way, be careful, you only have this amount of lines, and any line you have down here will be gone, so take care not to write too much, or not to have too many empty lines. Define vent. Structure, whoopsie. Active vent. And define vent cooling. Vent cooling. So, down here, when the room is too hot, we need to suck from the room. So I will set the mode of the active vent to 1, which you can look up here. Mode outward means out of its pipe network. It doesn't refer to the room or something, because you cannot know where the vent is placed. How would they document this then? I mean, it could be on the outside of the station. This refers to the pipe network. This is the harmless setting, 0, the default setting, which doesn't suck your air away. And this one is dangerous, not the default setting. You have to set it explicitly to this. This is how you can remember this. Excuse me. By the way, I talked about the let me first turn on the guy who has his this toothache. So when I look at the pressure regulator, the back pressure regulator I already explained. You can define, here you can see it's an arrow pointing towards a wall. You can define the gas pressure on the input side. The pressure regulator is a wall from which an arrow is pointing away. That defines the pressure on the output side. So with this you can say the pressure on the output side should at least be this. If it is higher, then it can't do anything about that. But if it is less high, then it will pump. The back pressure regulator makes sure that the pressure on the input side does not exceed a certain value. If it exceeds that, it will let out some gas. Then we have the pressurant valve, which is actually for liquid pipes. On the input side we have gas, on the output side we have liquid pipes, because we can just give some pressure to the liquid pipe. The purge valve does the opposite. It pumps to a gas pipe from a liquid pipe, and you can set the value that it shall achieve. I will explain that here with the example of the liquid pipes. Here we can see we have some liquid water and we have some water in gaseous form. Why? Is it too hot for the water? No. You have to consider, if there's only liquid water in there, what's the rest of the pipe then? Empty. Vacuum. And vacuum is no pressure. And no pressure means that water will evaporate because, like I said, if there's a vacuum, the water will evaporate. And then we have like 10 kilopascals here, and then there's enough pressure and no more water evaporates. So this means that this cools down a bit by evaporating, and sometimes it condenses again. It is balanced. However, if I would use now the purge valve, which can be used to remove the gas pressure in here, only the liquid pressure remains then, and I set that level to 0 so that any and all gas would be removed, then more of the liquid would evaporate, and this would cause further cooling. And then I would remove that gas again. So you can use that as a cooling solution in principle, and this would also eventually destroy the pipes because you would have frozen stuff then here. Conversely, if you want some pressure in here that is not H2O, you can pump some nitrogen in here. You will then have nitrogen gas, and the H2O will just condense back to H2O and will stay H2O. So now that I explained these two regulators, these pressure regulators, let's go back to the active vent. The active vent has pressure external and pressure internal. We already know what that means. External would mean where the vent grill is pointing, and internal, that's the pipe network. When you, let's see if that's written here. The vent has two modes. Outwards sets it to pump gas into a space until pressure is reached. Inwards sets it to pump gas until pressure is reached. Okay, that's not a good explanation. Let me explain this then. Let's say we set the mode to outward, which is mode 0, which is when the switch is blue. Then whenever you change the mode by programming or by switching it manually, I mean, you have already seen that the power switches change when you change a value, and that's nice that the physical and the logical is connected this way, that you're never confused about that. So when it is set to blue, then it pumps to the room, and whenever you change the mode, then its pressure external setting will be set to 101 kilopascals, and its pressure internal setting will be set to 0 kilopascals. This means it is now willing to empty the pipe entirely, but is not willing to pump gas into the room to a degree higher than the default setting of our spacesuit, which is Earth at sea level pressure 101 kilopascals. When you change the mode to internal so that it sucks into the pipe, then its pressure external setting will be set to 0, so it is willing to empty the room entirely, like in an airlock for example, and it is willing to pump the pipe to I think 50 megapascals, which is when the pipes have started moaning, which is at 49 I think, but it's not dangerous to the pipes, so the pipes will not be destroyed. But if you want to pump into the room to a higher pressure, or into the pipes to a higher pressure, then you have to change these values, either with chips or with programming. And these are basically then back pressure regulators and pressure regulators. So much for that. So let's go back to the cooling system programming. So we have now said that the vent shall be set to sucking from the room, but shall it be powered? Well, only if the pressure in the pipe is less than 1000, else it will just stop. So when the room is too hot, the vent will turn on, but then it will turn off again, and then the cooling will just happen. When we pump back into the room, we just want to find out if the pressure in the pipe is greater than 0. I could just do this also, like I said, but I will just do this. And then I want to do the opposite. I want to set the mode to 0, as in pump into the room from the pipe, and oh, I made a mistake, and it shall be on then. This is our cooling solution. The room currently has 25-ish degrees. Let's see what happens if we export this. Yeah, it already fully cycled. We have now a room temperature of 23 degrees. These guys are now heating up the room again to 25 degrees, which is ridiculous. And then this guy will kick in. So this is already the entire cooling solution. We have a cooling solution, we have a heating solution, and so the plants are now safe. This one has seeded Now we can also harvest the potato, and we can replant the seeds if we wish to, or we can replant the potatoes. Both works. And I actually should have kept the seeds around here, because if we have some kind of catastrophic situation here which destroys all the plants, then we would still have the seeds. And that's why you should not plant all the seeds at once. So what we have now is we have drinking. We have eating. And how do we get some more water? Well, you can harvest water with a drill. And you can put up an ice crusher, which will heat the ice to 15 degrees and then spit something out, but it too has logic values. Its logic value here is setting, and when you look at it with the cartridge, with the configuration cartridge, you will also see that the setting is, let's see, it should be 298.15, I think, which would be 15 degrees Celsius, and you can just set that to 0, which would be 0 Kelvin. It will only accept a 1, but okay, you write 0, it will then be set to 1. So it will not cool the gas, it will then just crush it very quickly without any heating. That's what I'm saying. So if you put up an ice crusher, you should write the logic value setting, set it to 0, and then you can crush that very quickly. The ice crusher on its backside has a liquid connector and a gas connector. You should, when you use an ice crusher here for the water pipeline, just put a pipe cowl on the gas outlet, because the water that you gather here on the planet only has nitrogen. That's fine for your station, and actually some plants need it, these don't. And the liquid connector, you connect that with these pipes, and then you toss in some water ice, definitely not volatiles, please. And then you will have additional water here. So that we have. Then oxygen supply, you can just toss down some oxide in here, or rather here on Europa you can just pump in some gas from the outside, which will be very cold. So you could, maybe it's better to just pump in some oxide. I could also just open this. I mean, there are various ways. There's enough oxygen definitely here. And we have the filtration unit in case you need it, if you want to refill your canisters. I think I've explained enough for this video. It's also pretty late now. So yeah, that's it. That is Stationeers for beginners on Europa, which beginners would normally not play, but I think we managed, right? It wasn't too hard. So, and you learned tons of things. I hope. So that's it. Goodbye.